And welcome. Hey, this is SQL Conf 2025. This is our spring edition. We're calling it the Developer Marathon because we built it just for you with so much content. It just goes and goes all day long. This is a conference about SQL tailored towards you, the developer. Hopefully, all of this content will help you feel more confident as you start to incorporate SQL into your applications, but also gives you the opportunity to discover not just some of the features that we've already implemented, but some of the features that are coming right around the corner that you'll be excited to see, and how it can transform your applications from being straightforward data-driven applications to applications that have AI, applications that have additional functionality and can perform and can really lock in and integrate with your applications and architecture in an easy and straightforward way. We have a big day ahead of us, but first of all, I'm here with Muasma. Muasma and I work on the same team. Who am I kidding? I report to Muasma. She is my boss. She is in charge of everything that has to do with developer evangelism around SQL. And she runs the team of developer experiences where her team is like a hive full of bees, all running around trying to figure out what kind of features will improve the life of developers, what type of tooling will improve the life of developers. How can we make it so that your onboarding and your friction is lower, but also how can we make it so that your experience is just something you love, something you enjoy doing when you're interacting with SQL. We've done so much in the last few years, and we have so many exciting things right around the corner. I'm excited to have her here. We're going to talk through really some of the strategies that we have and some of the things that, well, honestly, we have going immediately. So a tiny drop of feedback, but to me, let me see if that's me or if that's you.
Yeah.
All right, so let's go with it and hope that we can figure this. What is going on here? I think I can fix it maybe like this. Maybe I'll see if that helps. All right, Muasma, thanks for being here. This is kicking off SQL Conf. It's really our first developer-focused SQL conference full of all kinds of content. And what do you think? If you were a developer today, is this a good time to be a SQL developer?
Yeah, thank you. Thanks you, everyone. Thank you for joining. Good morning, good evening, good afternoon, depending on where you're joining from. My name is Muasma, as Jerry mentioned. I'm really excited today about the SQL Conference, a developer marathon. We have lots of content today that you can watch live, you can watch later. I was just looking at the list of the speakers and the topics. Super excited about many of those. Some of those I'm still learning, and I'm also figuring out what is the best way for you as a developer to get most out of SQL, right? So as Jerry mentioned, we have sessions talking about the latest and greatest AI features, agents, vectors, all of that stuff. We have about data API builder, the new JSON data type. We have sessions focused on our tooling like VS Code and SSMS. We have sessions that are talking about web development and .NET Aspire. So really, really excited about today. Thanks, Jerry, for putting this together. This is not an easy task, and I'm really excited for today. Really, really looking forward to what all of you are going to walk away with and learn from today's sessions.
Muasma, we've really put a lot of candy in the basket for developers recently of things that really make it easier and just a way that they can discover SQL. Will you talk to me just a little bit? Why are we giving SQL away with a free edition?
Yeah, so we got this feedback from a lot of our developers. Whenever you're going to actually get started, right? So you want something to just do a POC, run an idea. Maybe you're a student, you're actually just figuring some stuff out. So it's very important to get started really fast. So for that, we have offered this free offer. We just went to GA. Now you can have up to 10 databases, up to the limit of 100,000 vCores per month, which is a lot if you really are building something with SQL. So this is the main reason why we announced this offer free. We see a lot of adoption. We see a lot of excitement. We see a lot of customers trying this out, a lot of developers trying this out, building amazing applications using SQL. So definitely try this out. There are no strings attached. It stays free for the lifetime of your subscription. You can choose to never pay for it as long as you are within the limits. and you have an option to actually set on the meter once you, if let's say your application is growing and users are growing, then you can actually start paying for it as well. But there are no strings attached. As I said, this is absolutely free offer for you developers, for anyone who's building applications with SQL, and definitely a great win for our customers.
The only requirement is that you have an Azure subscription, and that doesn't mean you're paying for anything. You just create your account, and now you qualify for a free database. Now you qualify for 10 free databases. So it's really a great, if you're just a hobbyist or you're just starting to like dabble into SQL, this is a great way to kind of get all of the features around SQL kind of at your fingertips without being concerned of, whether or not there's going to be a billing event at the end of the month, because this is a cloud service. And so it really, really helps. If you're a student, it's also a great way to get started as well. And when you think about the 100,000 vCore seconds, that translates to be a little over 27 nonstop hours of interacting with it. And the fact that you can have 10 of them, you can do the math. It's pretty fantastic what we provide here.
Yeah, and something to add on that is this is the full SQL engine. So this is not like a lighter version or something which does not have all the features. This is what everybody else gets as well. So you can basically build anything that you want. All the features that you're going to hear about today can be built on this free offer.
One of the other things that we are introducing as well, or we introduced maybe a month or so ago, is the learning path for SQL developers to be able to go in and really kind of wrap their head around all of these features. If you feel like it's getting away from you, if you feel like there's so much information, we've provided it now inside an individual learning path that's associated with an applied skill. And so that applied skill, it's a credential that you can earn. We cordon off a special part of Azure just for you, and we pre-configure it through scripting and things like that to make sure it's exactly what you need to be. And then inside that, you can go in and you can configure it, and you can go through a series of tasks to prove that you understand how these features work. You get a credential that Microsoft provides back that you can show off on LinkedIn and things like that. So it is not just something you go and do, it's something that sticks with you for a while to show that not only are you it's not answering questions on a quiz, it's actually accomplishing the tasks at the same time. So I feel like that's really another value add that we give. It's completely free as well. We just want to make sure that if you are interested in all of the advanced capabilities of SQL, we make those available to you as well. Now, I know that you care a lot about the AI side of SQL. And so let me ask you just a couple of quick questions, Muazba. First, we are there. So I see AI two ways, and I'll bet you do too. First of all, we are using AI to make developers' lives easier, to enable them to do things. On the other side, we're enabling developers to use AI inside SQL and inside their applications, and we want to complement that. Let's start on this side. What are some of the ways that we are using AI to make developers' experience better inside SQL?
Yeah, and then exactly that. Those are the two ways how we look at our AI strategy for SQL as well. So on the side of how we can make developers more productive, we have a set of offering in terms of copilots. So depending on your favorite tool, be it SSMS or be it an Azure portal or be in VS Code, we have the Copilot option for you where you can ask questions like, why my database is slow? Or what happened in the last 1 hour about my application. And this will go in and actually run the telemetry for you, give you insights about the database, make you more intelligent, be more productive about the tasks that you as a developer have to spend lots of hours on. So one of the great way of giving you an example of something like that we have built internally for us is for our engineers. When you create a ticket for us, we have a similar Copilot for them. We call it an ICM Copilot. And that where you are responding to a customer escalation or anything like that, which used to take them hours, now it's down to minutes. So this is a great productivity hack for our engineers. So we believe that you as a developer building applications, this is a great win for all of you. So a lot of work is happening in that space. SSMS 21 is going to be, we already announced it, it's in a preview right now, which has this Copilot features, which caters to both DBAs and data developers and application developers. And we already have in public preview our Azure Copilot experiences as well. So definitely check them out.
I would bet most of the developers watching already have some kind of experience with Copilot while they're coding. And we want to bring that to all the different tools that we have as well. So you're going to see it inside Visual Studio Code. You're going to see it inside SSMS, and you're going to see it on the web in the portal when we have that as well. So some of these features are kind of around the corner. They're on their way. Some of these features are already in preview, and you can start to experience them today. So a lot of neat ways that we're trying to bring in not just an ordinary Copilot that understands what SQL is, but a more advanced Copilot that understands your SQL database and all of your schema as well. So a lot of really cool things that hopefully will just delight our developers so they can see that development can be unbelievably productive. Now, on the other side, we're trying to enable it so we have capabilities inside SQL for those developers wanting to integrate AI in some way in their application. What are some of the things we have going on there?
Yeah, so on that side, we have what we call building intelligent applications. So we just announced in public preview the vector capabilities. So we have a native vector type. We have vector functions, distance functions, finding out if this is a vector or not, and a few more. And we're working on a disk-KNN based vector index. So what you can do is using building intelligent applications with SQL, store data in SQL. Any of the text data can be converted into embeddings. We have lots of great samples available for you to try out. You can do natural language to SQL. You can actually do a lot of intelligent applications, which is about chatting with your data. We have integrations with LangChain and Semantic Kernel. So both of them are top kind of frameworks that people are using for intelligent applications. So this is kind of the work that we're doing when it comes to you as a developer building intelligent applications. We in SQL have been supporting full text search for a very long time, even before AI came out. Now you can do full text and vector search, and basically a thing called hybrid search, where you can get the best of both worlds. So full text is what we call keyword search. And then vector search actually goes to the semantic meaning of what you're looking for in your data. So really very accurate search, very effective search with the world of AI. And this whole is enabled natively in SQL. We have this capability called SP invoke REST endpoint, where you can call any LLM that you have access to as REST endpoint, be it in Azure OpenAI or OpenAI directly or anywhere else, with literally 2 or 3 lines of syntax. And then you can connect to it, and you can call that LLM, you can do summarization, you can do a lot of those things. So all of this is enabled using that, and we heavily use that for the embedding use case for the RAG pattern, which is retrieval augmented generation. So if you're building RAG pattern applications, if you're building agentic AI applications, we have the support for it. You will see it later in the session with some great demos, some work from Davide, who has been the PM on this side, and also some other PMs in my team, Pooja and others, which have been working on this area. And Brian also has a session later today, which is going to talk about GraphRAG. So a lot of great content for all of you, super exciting times. I'm really excited about where we are taking SQL for developers for intelligent applications. And please share your feedback. Please get your comments coming in. I see a lot of folks are joined here. Looking forward to your feedback and seeing how you build these kind of applications. What are the things that are missing, and how we can improve our product for you as well.
This advanced capability now that we're adding so that you can start integrating AI, it's going to be available, of course, in Azure SQL Database, but developers who are on-prem and they're running SQL Server and they're going to see themselves upgrading to SQL Server 2025, they'll have the same capability, won't they, Moazma?
Yeah, it is what we call is that all these features are available from ground to cloud to fabric. No matter where you are, it is available in all flavors of SQL. We are not limiting to any flavors. This is available in existing pricing. We are not adding any new pricing to any of those features. So SQL Server 2025, which is in private preview right now, when it comes GA later this year, you will have all these features available in it. SQL MI already has in preview as well in SQL database, Azure SQL basically database, that is in preview as well, and also in SQL database and Fabric. So no matter where you are building these applications, we have these AI features available for you in all these platforms, all these offerings that we have for SQL.
Now, throughout the day, we'll be talking about what it means with hyperscale, a SKU of SQL that really is the future of SQL for us. We have a session also coming up on Aspire, so that kind of prescriptive guidance that .NET is providing today, how that integrates in with the SQL story as well. And everything is really a handshake scenario where I think developers are going to start to see a pattern and sort of a constant narrative across all of the different tooling, all of the different capabilities that we have, so that they can have this sort of fluid experience and not feel like they're making compromises or cutting corners, but being able to walk into a rich experience that provides to them things that maybe they hadn't even thought of before, and they can be able to leverage that without having to become an expert in it, because we're wanting to make it so SQL is an enabler for developers, not just a tool they can use, but a tool, but also an enabler that brings technology to them and makes it so that it's very straightforward and sort of democratizes some of that technology for them as well. A lot of work, frankly, that your team has done. Our team, I'm on your team too, and it's really exciting because the attitude is always towards the developer. Why is it we like the developer so much, Moazma?
So I truly believe that developers are the future. They are the decision makers. They're the ones who are building these applications that we all love and use all the time, be it in an airline company that you're working on, or it is one of these social media platforms. All these apps that we interact with make our life easier and fun. So really, it's the developers who are thinking about making those apps more efficient, more AI-driven, more intelligent, all of those things. And the experience for developers for us is top priority. We have invested a lot of time in the last few years in these features that you can see today in this conference, and we really believe that that can act as a driver for you building better applications that can bring more business to you as a customer as well. So again, I am here to listen to your feedback. All of my team, all of the broader SQL team PMs are also presenting later today, product managers, and also we have friends from DevDiv and other departments of SQL, other departments of Microsoft who are using SQL and have been building great applications with it as well. So we're really looking forward to your feedback. We truly believe that developers are the future. They are the ones who are giving us a lot of feedback. They are the ones who are building these applications that make a lot of sense, that bring a lot of business for you. And then at the end of the day, makes our product much better as well. So
yep,
really
I totally agree. I'm looking forward to the comments. In fact, if you're watching now and you feel like there's a question you have and it is not related to what's being presented right now, don't wait for that session. You can ask it at any time, and we'll be monitoring the Q&A as well. We're happy to take feedback this way. You can be direct with us, and we're happy to take it as well. And if you have a compliment, we're also happy to take those as well, for sure. SQL is such a mature product. It's been around for a long time. It's the reason that it's so stable. It's the reason that we've worked the bugs out. It's the reason it's so fast. It's the reason we don't lose data. It's the reason it scales so well. We've been able to invest in it for so long. And we've really had our attention for, if you look at the life of SQL, we've really had our attention towards the DBA, towards the administrator of the database. That's not the developer. That's the one that's figuring out how it can be reliable, how it can be highly available, how it can be set up in a cluster, and all these other things. And on the other side is the developer that's interacting with it, that's trying to engage the data. That is really where I would say in the last 5 years or so, we have really leaned in, really made it so that we are paying attention to the needs of the developer to make this really a developer-oriented database. And so we've already got it on one side, nice and kind of a slam dunk. Now we're on the other side, trying to make that the same sort of goal and target and experience. And so it's all the way across when you look at our tooling. When you look at the developer experience inside Visual Studio Code today, we have a session that Carlos will do that is dedicated to all the things that are coming. If you look at it right now, you're like, wow, what you can do in Visual Studio Code is pretty spectacular. It is not even scratching the surface of all the things that we have right over the hill that are going to make it so that the developer experience inside Visual Studio Code is just off the charts. And the same thing inside SSMS. We have Erin coming later today. She's the PM for SSMS, and she'll be talking about all of the dramatic changes in SSMS incredible upgrades that we've been able to accomplish just in really a short amount of time that you'll appreciate, and as well as the synergy across the Visual Studio product line as well. So I think there's a lot of, when we start talking about all of the things that we are now kind of giving out to the developers and kind of letting them get started in, it's pretty great. I'm with you. I think the developers are the future. You know, it's like teach them well and let them lead the way. So just like the song. And I just think there's something about it where who is making technical decisions inside organizations today? More and more, it's engineers. More and more, it's the developer. And we recognize that. We realize that. We want to enable them to make smart decisions, but also to not regret those decisions, to make it so those decisions are the reason for their success, the reason for their application success as well. So I think there's a broad story here that today we'll be able to tell. Moazma, the first person, I'm so glad you talked about Davide. The first person presenting today is Davide on our new AI capabilities, and he'll walk through vectors. And so that is, it couldn't be anything else. Before we get started with Davide, though, tell me if there's anything you want developers to hear before you go.
I just want you to take all the notes, look at all the content that we have today. If you are not able to attend a session, definitely come back to this channel. You will have lots of great links and demos and things. Most of the stuff is all available in our GitHub. All of these links, all of the samples are available for you. So the one thing I want you to go away with is to try any one set of features, be it the JSON data type, be it the data API builder, be it the vector AI, whatever is that you're really looking forward to learn, maybe a combination of these things. Try an app, build something cool with it, and send me a note. Send me a note on LinkedIn, send me a note wherever you can find me. I'm on all the social media. Send a note to Jerry or the presenters. Would love to see that, what you built. Really excited for today again. And thank you again, Jerry, and everyone who's made this day possible. So really excited for this, all the sessions, and really looking forward to what you build with this.
Thanks, Moazma. Thanks for being here and kicking us off like this. Now let's move over to Davide and see about AI capabilities inside SQL. Thanks again, Moazma.
Welcome everyone, and welcome to the SQL 2025 conference. This is a session about vectors, AI agents, and databases, and I am Davide Mauri. I'm a PM in the Azure SQL team, and I focus on Azure SQL, developers, and AI, and especially when all these things are together, like in this session. And I'm very active in the community. You can find all the details on these slides. I blog quite a lot. Follow me also on LinkedIn, Twitter, and Blue Sky to make sure that you keep updated with all the fantastic stuff that we are adding to SQL Server and Azure SQL. And 2025 is going to be a great year, so make sure to stay tuned. Having said that, let's just go quickly over the agenda, which is pretty small because we'll start with an introduction and just an overview of vectors, embeddings, and agents. And then we'll move to understanding how we can build an entire end-to-end solution using agents, and maybe how we can do it in pure SQL and see it in action. So what are AI agents, first of all? Well, an AI agent is a software that is able to do autonomously what basically you ask it. So it is, for example, is able to go and retrieve the data from a database, or even open a web page and retrieve the information, or create an order, or do whatever it has been trained to do. The AI agents are really cool because they just allow you to basically talk to them in natural language. So one of the things that we'll be doing today is create an agent that is able to find SQL samples for you, samples with AI and SQL together. So you may be asking to the agent, find me a sample to build AI agents in SQL, and the agent will do stuff behind the scene. You just have to wait and sit and enjoy a cup of coffee, for example, and then the agent will come back and will present you the result. Those results can be in natural language or in what we call a structured output. We will see that second one today because it's very interesting, especially when you use it within a database. But that's pretty much it. So the idea of an agent is pretty much what you have in mind already. Just instead of being a human, is AI construct that can just do something that you ask it to do. Why AI agents that are so common today needs vector and embedding to work properly? Well, the point is that embeddings are numeric representation, in other words, vectors, of data like words, images, or items that capture the meaning or relationship with something. And those are crucial for AI because that allows AI agent not only to do precise search, like, okay, find me all the data that was created at this moment in time, for example, so very precise, or all the products are red in color. But it helps the agent to do all the semantically similar queries that you may need to do when you don't have a precise question. Like, for example, if you want to find books about science fiction, the Foundation series by Isaac Asimov is probably something you're interested in. And the embeddings can capture the information in form of vectors about the Foundation series by Isaac Asimov, about the fact that an agent is looking for science fiction books, and put them together so that the agent can, in quote, understand that the Foundation series by Isaac Asimov is actually a science fiction book or a series of books, and then return to it if your ask is, find me next science fiction book for me to read. So those are kind of the foundational aspects. Let's now make a more practical and business-related example. And let's take a fictitious insurance company that want to use agentic AI to improve the workflow of their human agents. So let's say we have a human agent that is about to meet with John Doe, and he wants to find anything that is in the system about John Doe, so he can be prepared to meet the customer, make sure he is happy and loyal. So the human agent will actually work with an agent that we can call orchestrator here to basically ask a question like, hey, I'm meeting with John Doe later today. What can you tell me about him? The orchestrator agent will take care of communicating with other agent, asking the right question so that he can ask the CRM agent return all the information about John Doe, like the address, the information about the number of cars or houses or whatever that he has insured with us. The claims agent to get information about the latest claims or the past claims and understand how they were managed. And the payments claim to understand is this customer paying on time? Are we charging him a lot, or we increase the premium lately? So everything that is helpful to answer the first question. And of course, behind the scene, each agent will be able to run queries or create queries or find information in our case, database that is appropriate for their work. And they are actually able to create the query on their own. Of course, you can have a storage procedure they can call, you can prepare some code they can execute. But since you don't really know what the human agent will actually ask to your agents, yes, you can definitely prepare some tools for agent to use, as we'll see later. But also you want the agent to be able to completely be free in asking a question to the database or actually creating query and executing those query so that they can return information that are needed to answer the question. So this is the first super important step. Agents are able and will be more and more able in future to create a SQL statement on their own and execute those statements. So this kind of change a little bit the way we approach as a developer the creation of our application. It's really a revolution in my opinion. In fact, you will not be the one writing the query that will be executed against the database anymore, but the agent will be the one creating and executing the SQL query. Of course, you can limit the scope of the agent, maybe using storage procedure and functions, but still, if you want to give to the agent the maximum flexibility to answer any question, then the agent will write the query. It will not be yourself anymore. So this is a very big mind shift, especially from a security perspective, because now you don't control the query anymore, or you have a very limited control. So you need to make sure that the data is protected using other tools like row-level security, like correct security on database, because otherwise, possibilities of leaks or misuse are always around the corner. So this is a very, very important topic in my opinion, as agent will become more and more common. And again, they will be writing and executing code against your database. So from a more practical perspective, what could be a simple example of an agent that is able to understand the natural language query that you are submitting, deciding what to do, generating SQL or executing a storage procedure just to simulate a little bit more complex solution, and then providing the final answer. Well, that's what we are going to build. So we will have an LLM here that will understand the natural language, decide what to do if an approximate answer or a precise answer is needed. In the first case, it will generate it will execute a storage procedure using vector search. In the second case, we'll generate a query with a where clause, and then execute the query, get the result, enrich them with data, and then merge back with the structured data, and then finally return the structured result. So that's it. That's the demo. Before moving to the demo, I want to answer a couple of common questions, like how do I apply this concept to my application? Well, first of all, agent frameworks are becoming common. There are a few samples in this conference also. Semantic kernel is one of my favorite, but there are many available. And the main problem is that what happens if you already have an application and you cannot just change it, right? Maybe it's an existing application that could be changed but requires a lot of effort. Maybe you just want to have a KISS approach, so keep it simple, push the AI in the database and make it available to any of your application without changes. So in either case, you probably want to see, even just for a learning perspective, how everything can be done in T-SQL, and then you can decide if to use an agent framework or not. So let's start using T-SQL to create a very simple application end-to-end that allows you to search using natural language all the samples that are related to AI in Azure SQL or SQL Server, and find the one that is most appropriate for the question you are asking or for the sample you're looking for. Okay, so this is the example I've been mentioning as the simplest one that I can possibly think of an agentic AI RAG solution. And basically what we can do is just search in natural language and let the agent figure out what is the best way to do to solve our question. So let's start to say, show me the sample used at SQL Conf 2025, and let's see what happens. In this case, of course, this question cannot be answered just using SQL. So we need to do a more semantic search, and it looks like the AI bot correctly returned the answer because it is saying this sample is relevant as it was used at SQL Conference 2025 and demonstrates the integration of various Azure services to create a functional AI search website. The other option where the AI needs to make a choice is if we ask, show me the last 5 samples, for example. And in this case, there is no need to do semantic search. So another tool should be used actually in this case. SQL query should be executed. And here we go. We have the latest 5. So what is happening behind the scene? So this is the GitHub repository. And what happens is that when you search something, the storage procedure find sample is executed. And first of all, what I try to do here is get embedding of the text to search if I already have provided, if the AI model already provided an answer, so we can use semantic caching. If yes, we just return the cached result. If not, then we call this function, called this storage procedure called orchestrate request, which is where the magic happens. So let's take a look at the orchestrate request. And what is happening right now is that I am telling the AI model, so here I will be connecting to an AI model, that you are a SQL Server Database Assistant. You can answer question providing the correct T-SQL query to get this result. And here I'm specifying the structure of the table that I want to use, or that I want to be available to be used by this AI agent. And you can see here I'm just limiting the schema that is available to my model to basically to query my table. So I'm not adding the title, I'm not adding the description, because I want kind of direct how the agent will be using this table, depending on if it is trying to do a precise search or a semantic search. So in this case, I'm just saying, okay, for you, just pretend that only these columns exist. And then I just tell that the T-SQL must return a JSON document. So using a for JSON auto statement. So I'm explaining my AI model how it should behave. Then I specify here the question that the user has asked. And then I define the schema. This is very interesting. I define the schema that must be used by the AI model to return my result. And specifically, my result contains two columns, if you want. The response type, so if a query is provided, there will be the response type called SQL, otherwise none, if the answer cannot be answered just generating SQL. For example, I'm asking something about session title, which the agent doesn't have access to that column. So it will say, I can't answer that, just running a SQL statement here. And if the agent can answer using a SQL query, then I want to have the SQL query in this specific property. And now, since the data is returned in JSON format, then I can ask the AI model to basically understand what I'm asking, return the answer. And then here I will have a result that will tell me, is the agent able to generate a query for your request, or it needs to use something else? For example, a semantic search is needed. Because we know for this specific code that I'm writing that if a SQL query can be generated, then we have to switch to semantic search, which involves the execution of a storage procedure that I have prepared. The agent framework are able to automate even more this approach. So they will automatically be able to figure out if a storage procedure needs to be executed or not. This is just a starting point for you to get confident with the agent. So I'm doing everything manually, but the principle is basically the same. There is an orchestrator that needs to decide what to do, and then it can either ask to do something using a tool, a storage procedure in my case, or can do directly something, in this case, writing a SQL query and executing it. So at the end of the orchestration phase, I will have an output, so the result output and the query output. If the result is a SQL query, then I will just try to execute the SQL query, making sure, in my case, again, this is an example, I want to show some best practice to make sure that the SQL doesn't contain anything I don't want it to contain. Or if the SQL has not been generated, which means that we can't use SQL just to query that answer because we need to do some semantic search, then I'm helping the AI model here to do semantic search using the new vector distance function, the new vector support that we added in SQL. And the reason why I need to help the model is that the model has been trained before we release this feature. So the model itself doesn't have knowledge about the existence of this function. So I can do two things. Or I either provide what is called a few shot prompt, where I show the model how to use these new features, or in this case, I prepare a kind of a tool. Imagine this could have been another storage procedure. In this case, again, for the simplicity of the example, I'm just showing it in the most simple way possible. And here I'm just helping the AI model to execute the right query to return the most similar samples that are related to the question being searched. Once the results are done, basically I just take the samples generated and I ask the AI model to generate an answer. Now, generating an answer here is, again, it's very simple, because basically imagine right now that we either have the result generated from the SQL query or the result generated by the semantic query. Now, what is left to do to fully implement the RAG pattern is to take the result and pass it again to another LLM model to make sure that only the proper results are returned, given the provided question. And that is exactly, again, what I'm doing. So here I am now saying, okay, this is if you want, the second agent. So we had the first agent that was orchestrating the request. Then we executed some tool that the agent told us to execute. And then now this second agent takes the answers and finish the RAG pattern, saying, okay, you are a system assistant who helps user find code sample. So you see the difference is how I am using LLM models here. The first one, the request was decide what to do, basically, or which tool to use, SQL or the storage procedure or the semantic search. And in the second usage of the LLM model, I'm saying, okay, now that I provided you with the answer that I think may be in scope for the question, understand if those answers are in scope and return the full answer. So here I'm just completing the RAG pattern, giving the examples to the LLM model, providing the original text and explaining it what I expect it to do. And then the result again is returned as a structured result. So I don't want a natural language answer. I want to have the result in a very specific format. So I want to have the result position, the ID, a summary of the sample, and the thoughts that the AI model had while deciding to return that specific sample. So I will return like 10, I will give the AI model 10 examples, and it will only return to me the one that are relevant. I want to understand each of the sample return, why he thought it was relevant. So I will find that here. And then I just run my query against the AI model using a spivok external REST endpoint, because of course my AI model is outside database, is in Azure AI, and then I get the result and basically return the result that are again a JSON document here. So if I go back to find samples, you will see that the result here are returned opened as JSON, so they can properly be returned as a table. So let's take a look behind the scene what's happening on database, because that gives us some interesting result. So here I'm connected to the database. So let's take a look at the semantic cache, because aside of caching the result to provide a faster response without using the LLM always, here we have some information on based on the query asked, what is the action that the agent decided to take. In this case, it generated a query, and as you can see, the query is very nice, very elegant, and it just contains the 4 JSON auto clause as I asked. And so in this, to answer this question, the agent decided to generate a SQL query that has been executed, and instead to answer this other question, it decided that it should have gone for a semantic route and execute a similarity search query. So very nice, very simple, very powerful, right? Again, I have not written, there is nothing in my code that where you can find this query. Now, this brings to me to a very important discussion about security. Let me open a file that shows you the importance of row-level security here, and why it's so important that you start to take a look at that. And gladly, we have it in Azure SQL since long time ago. So let's move out a bit from our example right now, and let's just say that I have a table with some sample data, right? So let me make some space here. It could be our samples, it could be anything else. For now, I just have a table with some sample. Let me create this example, and now, okay. Now what I want to do is show you that even if I'm an administrator, or even if I impersonate the entity used by the agent, I can instruct Azure SQL or SQL Server to show me or the agent only the thing that we are allowed to see. So to do that, I need to, in this case, just again for my example, create a table where I store the security levels of my users, right? So I'm setting myself to have a security level 0, which is one of the most privileged, and the agent specifically its managed identity to 1, which is a little bit lower. Okay, so let me create. I think I already did, but just in case. Perfect. I create the user agent identity. In this case, I'm just simulating it with a local user without a login. But just imagine that this is the identity used by the agent when connected to the database. I'm doing everything local here for trying to stay within the 30 minutes allocated for this session. So otherwise I would have had a function or a container running my agent, running my code actually. Running the website that would have connected to Azure SQL presenting this identity. Here, we're just simulating it. Okay, so now we have a sample data. We have a table where we can associate a user with a level. And what I want to do is create what we call a row level policy that says, okay, if you are a certain user, I can check the level and return 1 if your level is above or below a certain threshold. And if it's 1, means that you are authorized to see a certain row. Or if it's 0 or nothing, it means that you shouldn't see that row. So let me create this function. And now I apply the policy. I'm saying whenever someone queries the sample data, take the security level column that I added to my sample data table, security level column, and pass it to the security level function I created. So the level will be passed as an input. If the level is it's outside the boundaries of 0 and the level that I set here, then you can't see the query. You can see the row. So let me show you. Now, of course, this policy is set to off, so it will not be applied. And if I query the sample data, I can see everything, right? Now, who is the person, the identity I'm using here? Let me show you. So I am the DB owner, which means I am the administrator here. I should be able to do everything. Now, the moment I enable the security policy, you will see that I will not be able to see the row -1 anymore, even if there are nowhere clauses here, no predicates. So this data is gone for me. It's like it doesn't even exist in the table, even if I administer it. So this is the power of row level security. It works at a lower level than your query, and it makes sure that all the data returned is authorized to be shown to you, applying this logic here. And this logic is very simple. As long as 1 is returned, and imagine it is just a logical explanation. Imagine that this function is executed for every row. It doesn't work in that way, otherwise it will be very slow, right? But logically, imagine that this function is called for every row, and the value of the security level passed as a parameter here. So the value with security level -1 is not shown to me because I have security level 0, and -1 is outside the boundaries, so it's lower than the security level I have, so I'm not shown that row. Now, what happens if I change my user and I impersonate the agent? I have set the agent to have a security level that is a bit lower than mine. So the security agent, the agent can only see the rows that have a level greater or equal than 1. So let's see what happened. Now I am impersonating the agent here. So if I now execute the database, the query, well, in this case, I probably even forgot to give myself permission. So let's go back. That's good. That's another good example of permission. I need to grant the permission to the agent. Let me go back. Let me impersonate the user again, execute the data. Now you will see that the agent doesn't even see the row number 0. So it's very, very important that row level security is applied at the database level to make sure that no matter is the query, here my agent could write anything, can write also something like that, but that will not trick the system. It still only show the data that I'm allowed or I want the agent to see. So just imagine someone trying to hacking to the prompt of your agent, trying to make the agent do something that is not supposed to do. This is a huge security guarantees to make sure that your data cannot be leaked. Now, if I go back to my user, of course, now I'm back administrator, but the row level security is still in place. I can't see the row with value -1 anymore. This row here is just like it never existed to me or to agent. And of course, I can also change the data. The table is absolutely a regular table, so you can add data, remove data, update data, and based on security level, following the function I created here for the example, I will be able to see or not see any row. So that's very important, because the moment the agent will access the database on your behalf, you want to make sure that the agent can only see what you want it to see, to make sure that, again, no one can abuse the agent and hack into the prompt and maybe ask the agent to do something that it was not supposed to do in first place. That's it. So let me clean up the database and let's go back to the slides. Okay, so you have now a complete picture of the end-to-end solution. We just focus on the database side, of course, but the example you have seen, which is available here at this address, comes with a full end-to-end solution with the front end in React, the database that you have seen already, and data API builder that is discussed also in other session of this conference to act as your backend for front end. So you can have a very nice end-to-end demo that you can deploy in your subscription. Now imagine doing what I did instead of samples on your document, on your customer data. And if you want to have a even more complete example and even more realistic example using Semantic Kernel to orchestrate the agents, you have the Ultimate Chatbot demo that is available at the URL that you can see in the slide. But also you can ask the website linked in the first resource about show me the insurance sample demo that Davide created, and it will return to you the right one. You will see a more complex example, actually the one that I described in the slides before, with the claim agent, the payment agent, the CRM agent, all working together to basically answer your question. Then make sure that check out the devlogs, because I'm blogging a lot. My colleagues are blogging a lot about all the features that we are releasing. And again, 2025 will be a very interesting year for SQL Server and for the AI. And in general, then if you want to have access to all the AI, a single place where you can find all developer resources, go to azuresql.dev and you will find plenty of things for you to have fun with. Thanks a lot for coming to or watching my session. Make sure also to take a look at the path that we created, develop data-driven application that will give you a kickstart in using Azure SQL to create modern application. And with that, have a great day and see you next time.
Thank you so much. Thank you, Davide. Davide always has the best demos because they're always realistic and they're always all the way across the board, end to end. It's really something else to watch him. Thank you, Davide. This is SQL Conf 2025. This is a developer marathon. It's SQL content curated specifically towards you developers. Now, we have a couple of questions that I just want to make sure we kind of walk through. First of all, thank you for interacting the way that you guys are. Vinny, first of all, you're asking where can you find today's agenda? That's really, I mean, there's no reason to keep that a secret, is it? And I see Gene has a really good idea. Where could I find today's agenda? That's really good. What Adolfo's even commenting. Ditto on the agenda. I think we need to bring up the agenda so that you guys can see it. Today is chock full of content. Not every session is exactly the same length. Not every session is going to be as rich as full, right? So you can kind of dabble into it. And by the way, this conference will be completely recorded and chopped up and put on YouTube as well. So if you feel like that you missed something because you had to go to a meeting or your manager walked in and asked you a question that you had to give them their attention, great, no problem at all. So here's the agenda for today. Today's agenda really is full. We will go for a handful of hours together and we'll be able to see some pretty amazing things. Cyber jumps in. Thanks. Hey, absolutely. We're glad to do this. No doubt about it. Thank you for joining us. And here's the agenda for you. Take your screenshot if you want to. We'll show this over and over again together. All right. So next, I want to talk about specifically that SQL Server is not just a database for relational data. We refer to it as a multimodal database, meaning you can put all kinds of data in there. Of course, you can have relational data. That's the bread and butter of SQL, but we also can have a graph database in there. You can also have a name value pair database in there. And you can also have a document database, things that are either in XML or JSON, like you might put into a regular NoSQL database. Now that's really important because it means that you likely already have the core business data inside a relational database like SQL, and you want to enable the capabilities of NoSQL interacting with JSON in an advanced way. Well, in order to do that, we have capabilities already built into SQL to make sure that you can do that, to make sure that you can query and interact with your JSON document. But new features are now available, and that's what we're going to be talking about in this session. We're going to go through the new JSON capabilities inside SQL to allow you to not only manipulate large documents, but maybe you have small tidbits of information and you want to make those as efficient as possible. One of the things we'll talk about are the new methods to interact with JSON like you would expect in a normal language. So if you're writing like a C# application, you expect to interact with JSON in a certain way that's very efficient. So do we. Also, we have a data type we'll be talking about as well. So UC will be talking about that here together. And so I hope you enjoy what you're going to learn about SQL and its new JSON capabilities when interacting with a document.
Hello everyone, welcome to the session on harnessing the power of SQL and JSON. My name is Umachandar. I am a program manager in the Azure data team. I've been leading many developer features over the last 2 decades. So right now I am working on the JSON support for SQL. And in the past, I worked on machine learning services, window functions, and many other improvements. Okay, today we'll look at the JSON support in Azure SQL Database and SQL Server. So first we'll have a high-level overview of where we are today. And then I'll drill down into some of the new features like the JSON type, which we introduced for public preview. And we'll take a look at how to index JSON documents and also like few other key scenarios about how to use SQL and JSON together. Okay, so the JSON support we first added back in SQL Server 2016. So the initial implementation was around the character string columns. So the JSON documents can be stored in a varchar or in varchar data type. And then you have many functions which can be used to manipulate the JSON document. Either it's for changing some property or querying a particular property or validating the JSON document. So these are some of the functions which are added at that time. Then we also added a few relational operators to help with taking your relational dataset and transforming to JSON, or taking your JSON document and transforming it to a relational dataset. So these two operators like OpenJSON and ForJSON can be used for that. Then in SQL Server 2022, we made some minor enhancements to isJSON to help validate JSON documents better. And then we added a new function to check for whether a particular path exists in a JSON document or not. So this can be useful in cases where you want to set up a check constraint on a table and the property is in a JSON document. Then we also added two new ANSI SQL functions from the standard, and these are JSON object and JSON array. As the name indicates, you can use these to construct an object or an array out of relational data. So last year, we also announced the public preview of the native JSON data type. So I'll drill down into that later. So that's currently available in SQL database and SQL managed instance with the versionless policy. So as part of that, we continued adding more features from the ANSI SQL standard, and we added the JSON aggregates, one to aggregate data into a JSON object and another to aggregate data into a JSON array. This can be used with other aggregates in any of your queries with group by and so on. So we also made some enhancements to JSON aggregates itself to make them work with the grouping sets feature. So I'll show this a little bit in a demo. And then we also enhanced some of the JSON path searches to support wildcard searches on arrays. So this is a high level where we are today, and next I will drill down into some of the features which I talked about. So the JSON type, it's a new data type. It's a binary format. So once you store the JSON document, we basically store it in an optimized manner. This uses all the existing LOB data type capabilities in the storage engine, and we support up to 2 gigabytes of size in terms of the JSON document. So now, how does this new JSON data type compare with the what we call legacy JSON, which is based on character strings, meaning you store the JSON document as a string in a varchar or n varchar column. So let's look at some key differences. The JSON type is a native type. It has its own binary format, whereas the previous approach, you store the JSON document as is, including any white spaces, formatting, and so on, right? So to the database engine, it's only strings, unless you work with the JSON functions. Then JSON document itself can contain values of different types, and JSON has numbers, strings, and Boolean. So we store them as native SQL types. Whereas in the legacy JSON, these are stored as strings always. The parser has a little bit different behavior, where with the native type, all the JSON document contents are validated and stored into this binary format. Whereas with the previous string approach, depending on how you use it, I mean, you may get results on incorrect documents, like shown in this example. The new JSON type is optimized for very fast query processing. So this can be used to look up keys very quickly, locate array elements, and so on. The character string approach, I mean, you have to basically parse the JSON document for every operation. The native JSON type also supports in-place modifications of JSON values or keys. So this can be very useful when you're updating only a specific value and not making any big changes to the JSON document. Whereas with the old string approach, even if you were to change a single property, you need to basically rewrite the entire document. And lastly, since we store the JSON document in a binary format, you get some inherent storage savings, and that is evident as you store larger documents into the JSON type. Whereas with the older character-based approach, it's the string is stored as is. There is no compression other than like some string-based compression if you turn it on, and or you store it in columns too. Okay, so with that, now once you have a JSON type and you have a table with a JSON column, then there are a lot of scenarios where you want to index certain properties and query them in your SQL statements. So for that, currently the approach to use is the computed column based indexes. So in this approach, you would basically write a JSON value expression as shown in this example, where in this JSON value, I'm basically looking at a specific property called price, right? It's a key inside the JSON document in this column, order info. So now you add a computed column on that, and that expression can be any complex expression. You can nest other functions, call other SQL functions. In this example, we are converting the value into a specific decimal type. And then you create a regular B-tree index on that. So now when you have a query as shown here, the query optimizer will automatically match this expression to the computed column expression, and we are able to use the index in this case. So this is an example of how you would index JSON documents. So now let's look at a scenario where you want to take data from SQL tables and then convert them into JSON documents. So this can happen for many reasons, like you have a new application connecting to the database, you are leveraging some of the new formats, and you want to use JSON as the data interchange format. So one way you can do that is take a relational data and use the JSON object, JSON array, or the JSON aggregates to basically transform relational data into JSON on the fly. So here is an example of a query where you're joining an orders table with accounts table, and you can nest and use any of these functions. You can basically generate any arbitrary or complex structure that you want, and then this whole expression in this case returns a JSON document. So this is an example of how you can take existing data and convert it to JSON. And also recently we added a feature in SQL database to call into a REST API endpoint, right? And in this scenario, I mean, you can send and receive payloads either in JSON, XML, or text format. So here, if you specifically look at the format of using JSON, then you can use the same functions which I showed earlier to either look at some specific properties. You can take some relational data, construct it, and then send it to the endpoint. So for example, you have Azure OpenAI and you've deployed your own model there. Then you can construct a JSON document out of the relational data and then send it to Azure OpenAI. Similarly, you may write your own Python function which receives data from SQL as JSON, and then it can do some actions on it and return back the response as JSON. So this is another way where you will leverage the JSON functionality in SQL database along with the existing SQL functionality. Now, one of the other common scenarios is basically taking data from a file and importing it into a SQL table, right? So today you can use OpenRowset, for example, to read data from various file formats like a CSV, custom text file, Parquet file, and so on. And since JSON is a very popular data interchange format, there may be a lot of scenarios where you have a data feed coming as a JSON file, and you want to take that file and convert it to some relational format, right? So here, one of the things you need to remember is typically JSON documents are UTF-8 encoded. So you should make sure that you are using a UTF-8 collation so that you can take the data and store it in, say, varchar, or deal with any other string functions, for example. So here is an example where you use open row set to read the JSON file in this case, and here the file has one JSON document, so we are reading it as a single character lob object. In this case, it will be returned as a varchar max column or a type. So since I said, like, many of the files are typically UTF-8 encoded, so you will have to specify the code page so that we know, okay, what is the encoding of the file, and then we can preserve the data when you read it into SQL. So this is an example. So in this case, we are taking the entire JSON document and returning it as a single value. Now, in the same scenario, you may have a JSON document, but you are interested in maybe extracting certain properties out of it, or converting it into a relational data, right? Meaning each property in a JSON document is a column in a result set. So here you can again use open row set to read the file, but then you join it with open JSON operator, as I described earlier, and now you can extract the individual properties out of the JSON document into a relational data set. As part of this, you can do conversions of data types, right? Like, for example, JSON does not have datetime types. I mean, string is pretty much how you would store timestamp values. So now you can convert that to an optimized SQL type and return it in the result set. So this is an example of how you would do it. The JSON path itself is optional if the name of the column happens to match the property at the leaf level, or the first level of the JSON document. Here I've basically shown you just as an example how you would use it. So these are some of the scenarios how you can use JSON with SQL and combine both data sets, or take a relational data set, convert to JSON, and so on. So now let's go ahead and take a look at some of the functionality. Okay, so first I'm going to show you how you can use the JSON data type. So I'll drop the rig table just to make sure it's not there. So you can create a column and a table with the JSON data type. You just need to say JSON. I mean, it's pretty straightforward, like any other types, and it's seamless. I mean, you can declare variables and so on. The constraints you can put is only either null or not null. Additionally, if you want to add, like, for example, the JSON path exists, you can do that here. So you may want to say, okay, I want to ensure that a particular path is there in the JSON document. So in this case, I will pick order number, right? So I can then do this. So this is an example of how you would use the check constraint along with the other columns. So now what happens when I create or load a data into this JSON into this JSON type in the JSON column here in the order info, then you will basically be able to take the JSON document and convert it to a JSON type in this case. And as part of that, the database engine will also verify that order number is specified in the JSON document. If it is not that, you will get an error like a check constraint error. So now here is an example of how the JSON document is stored. As you can see, even though it's stored in binary format, the clients will see it as a UTF-8 string, and they're able to format and show the document here. So here I've kind of shown the size of the JSON document when stored in binary format versus an nvarchar column versus varchar column. So here you can actually see when you compare it to nvarchar where every character is stored with 2 bytes, the JSON binary type can be smaller, right? So in this case you get some savings. For varchar, there is not much savings. But the same document, as you add more properties and arrays with repeated keys and elements and so on, then you'll get more compression savings. Just to show you an idea of how it looks. Okay, so then now once you stored the document in a JSON type, there'll be many scenarios where you want to basically query the property, right? Either it's a specific property, multiple properties, and then do something with it in SQL. So the first function you would typically use is what a JSON value, which takes a JSON type or value, whether it's a variable, column, and then you specify a path, and that's about it. So it gives you back the text in that path. Now once you have this, I mean, it's not really useful just by itself. In many cases you would combine it with other SQL functions or aggregates and so on, right? So here I've shown an example of how you would use the aggregates with these JSON value functions. So here I've extracted 2 properties out of the JSON document, and then we are converting it to like float or int here, and then you do a simple sum on that. So this is an example of how it's very easy to go look at individual properties, extract them, convert them to SQL types, use any built-in SQL function. So this was a quick overview of how you can use the JSON type. Right? Next, we'll look at the scenario where you maybe have a relational data and you want to basically convert them to JSON, right? So first let's populate these tables. So this is a accounts table with some account number and 3 columns to represent phone numbers. Then I have an orders table which has similar columns like the document which we showed earlier. So now one of the functions I'm going to show you is how to take a JSON document. Say for example, in this case, say you have a stored procedure and you're getting the JSON document from the application as basically the input, right? So in this case, the web service or the application is sending JSON as opposed to individual SQL values. So here is this example where I have an array with 2 objects. So what we're going to do is see how you can take this JSON document and then transform it into a relational data so I can insert it into the orders table. So currently in the preview, you need to include the cache. So I put that here, but that won't be necessary in the future. So in this sample here in this query, what I'm doing is using the open JSON operator, and the input is the JSON document. So now you take that, and like I showed earlier in the slides, you use the with clause in the open JSON to specify the columns and SQL types, and you can query them. So let's run this query. There you go. So in this query, basically I inserted, and then I'm also using the output clause to show the inserted values. So now we've taken a JSON document and transformed into a relational data. Now, once you have the data in relational format, well, like I said, you may want the application to get data as a JSON document. So that transformation can be done on the fly. So in this case, what I've done is I've constructed a JSON object with some properties. Some of the properties are objects by themselves, as you can see here, and they're nested. And the other properties are, one of the properties an array. So you can basically do an aggregate which combines all the rows into a single JSON document. So that's what you kind of see here. Now, same example with the orders and accounts table, and I want to return a single array with all the phone numbers of the account. So this is how you would do it. So it's a nested array where every element is again a bunch of phone numbers, and that's all. You just aggregate the data. So here we've seen like how easy it is to take relational data and combine them into JSON documents. This is similar to how you would use a string ag today, or sum, or count. So now let's look at a scenario where you would use the same JSON aggregates with grouping sets feature. So grouping sets allow you to take data and aggregate them by specifying various sets. Sets meaning like columns on which you want to group by. Typically in group by, you can specify only a set of columns. Once you do the grouping sets, you can specify many sets and then say, okay, I want to aggregate the data on all of these combinations and get the results. So here is how you would do it. So in this example, I've also shown how to use sum here. So this shows how easy it is to combine JSON aggregates with any other aggregate. So this is an example. So now let's take a look at how you can read a file from the file system and import it into the database. So first, this file basically contains a JSON document like shown here. I'll show both the scenarios where one is to read the entire file as a single column, so which is what we'll first run. As you come here. So this basically reads the entire column and the entire JSON document into a single value. And as you can see, the contents of the JSON document are here. And now you may want to join this with OpenJSON and basically extract just the properties you want. So what we're going to do here is we're going to take the open row set output and do a cross apply with OpenJSON. And we'll pass the JSON document from the file as input. So here, as you can see, the path itself is not mandatory. If the property happens to match at the first level, we will automatically use it. So that's what I've done here. And additionally, the location itself has, it's an object, the value, right? As you can see here, it's got two properties, X and Y. So you can actually go and extract them like this. So that's what I've done. And the languages is an array. I'm returning that value also directly. So let's actually go and run this. That's it. So here, basically, we've joined the roset function, which reads the entire document with the OpenJSON operator, and extracted the values into whatever format you need. I've shown like different ways of using it. Again, like I said earlier, you can transform the data on the fly too. Like I'm showing here, I'm using the JSON value function to get only the second element in the languages column, which is an array by itself, right? Like here. So the JSON array, the indexes start from 0. So 2 is actually this one. So that's what this run. Okay. So with that, I hope you got a very good understanding of how to use JSON with SQL, work with SQL data and JSON data using various functions and operators. Here are some resources where you can go and drill down on each of the functionality that I showed you. Please try it out. The JSON data type and the aggregates are currently in preview. Let us know how it works for you. And yeah, that's about what I had. And here is a link to the Microsoft Learning path and applied skill about how to develop data-driven applications. Thank you, everyone. I hope you have a good time and the rest of the conference, and you got to learn about SQL and JSON in this session. Thank you.
Thank you, UC. Thank you for bringing this to. Now, I don't know if you caught it. Now, developer, if you're watching this and you're like, wow, there was a lot of information right there. Did you catch it? What you caught was now JSON is stored not as a string, but as a binary so that we could interact with it in portions rather than the entire string at one time. That means you can have enormous documents and have incredible performance when you're interacting with them. There were a couple of comments and a couple of questions along the way, so I think it might make sense for us to talk together and go through some of these comments. Thank you for interacting with us. Obviously, we appreciate that. The handful from last time, first of all, Azabin, I have to just appreciate you're happy to be here. I'm happy that you're here as well. There's a lot going on here. We don't often have SQL-specific content tailored towards developers. This is a special day, this SQL Conf. It's not just about SQL content. It's about curated content just for you, making it so that it is appealing to the engineer and knowing what you guys get to deal with and get to understand and problems that you have to solve. All right, so thank you, Dave. Dear Jerry, is it able to provide any information about PowerShell? Well, you know what? This reminds me that, hey, we have an agenda. And the agenda looks like this, Dave. All the way down is PowerShell, a session dedicated to just PowerShell. You can see it right there. SQL and PowerShell for the win. James is going to provide that. He's an MVP who is a master of PowerShell. So if that's what you're wanting to do, well, you're just about to get it. Congratulations. All right. So the next thing is, thank you, Dave, again. All right. What about a presentation on Microsoft Fabric? Okay, well, that makes sense. Microsoft Fabric is a very important part of the strategy around Azure data and overall. Earlier, when we were talking to Moasma, she told us that the strategy goes from all the way down on-prem to in the cloud. That's Azure SQL database. So SQL Server to Azure SQL database, all the way up to Fabric. We want to give a unified developer experience all the way across capability-wise. So we have sessions dedicated to that as well. Okay, one quick question that was specific to what UC was talking about in JSON documents was whether or not thank you for that, was whether or not we can index documents based on specific properties or data. Now, interestingly, we could have always done that. That's interesting to say, right? Because what you would do is you would maintain your document as a JSON document, but you would extract it into a computed column that goes and uses JSON value to extract the property that you want, casting it to the correct data type and making it available inside your table as part of its schema. Then you can set that computed column to be, it's up to you whether or not it's persisted or not. If it's not persisted, then it executes every time you access it. If it is persisted, then it executes once and then stores that value until your document changes. Then you can have an index on that, just like you would have an index on any column inside SQL. And so instead of reinventing the wheel of how are you going to do things, we just make it so that you create an index the way you would expect to. Great question, by the way, and thanks for doing that. By the way, one of the things I think is worth at least pointing out is these capabilities can be done on the query, right? And so I can execute against all of my tables. And because it's now binary, I can interact with it as fast as possible. However, even a millisecond is a long time when you have hundreds of millions of rows. So it might actually make sense for you to pull out certain properties that you know you'll be querying or you'll have a predicate against so that you can have those in persisted computed columns as well. All right, so there you go. JSON capabilities are a big deal. Speaking of a big deal, is Hyperscale. Hyperscale is SQL Server. It is where all of the brain power of all of our engineering is going into now. And so if you're looking at the portal and you're thinking to yourself, which version of SQL should I create? It's Hyperscale. It is Hyperscale. We really want that to be the default SKU for all of you. Now, we, of course, I understand that if this is the free database, or if you're a student, or if you're a hobbyist and you're just playing around, you can pick anything. But from moving forward, when we think about capabilities, when we think about power, when we think about the future of SQL, it is all around Hyperscale. And so there's a funny conversation going on internally because the word hyperscale makes it sound like it can only be used when you have the entire universe in there, but that scale. But it's actually all the way down and all the way up. Now, the PM is Arvind. He's going to walk us through the 10 things that every developer needs to know about Hyperscale, and that includes you. And so let's go ahead and get started. Let's listen to Arvind's 10 things so you can realize how you can start to apply the capabilities of Hyperscale in your solution today.
Hello, everyone. Thank you for joining this session. As a developer, you must be developing new applications which rely heavily on data. And databases are still the preferred place to store a lot of that data. In this session, we are going to look at Azure SQL Hyperscale, which is a modern cloud-native database on the Azure platform. I'm going to take you through 10 facts you should know, and which will help you make the right decision, hopefully selecting Hyperscale as the database of choice to power your application. My name is Arvind Shyamsundar. I'm a principal product manager at Microsoft. And my day job, my main focus is on Azure SQL Hyperscale, which is the core focus of this topic. I also love developing little utilities and tools which help save time for me and for you. And you can see some of my work on GitHub. You can read about my background at LinkedIn and stay in touch via social media on Blue Sky. I could spend days talking to you about Hyperscale and why it should be the database of choice for your workloads. But to keep things simple for this talk, I've grouped the tips and recommendations that I have into 10 key themes. We will go through these at a brisk pace. Let's get right into it. First, let's talk about why Hyperscale is very familiar to you if you've been using databases or SQL Server. The Microsoft SQL family is extensive, lots of options there. In this talk, we're going to center firmly on the platform as a service option, which is called Azure SQL Database. Hyperscale is one of the additions within Azure SQL Database. No matter what you pick though, the knowledge base, the skills, the trainings that you have for SQL Server, for example, apply equally well to Azure SQL Database. It uses the same T-SQL programming language, runs on top of the same SQL Server engine, uses many of the same tools, can leverage same AI innovations that we have in the form of Copilots and AI, and is even integrated with Fabric for analytics. Let's look at more details. Hyperscale is one of the many additions within the Azure SQL Database family. It is the most current and the most innovative because it was built ground up for the cloud. Within Hyperscale, you can select two modes of deployment. One being the provisioned compute mode, where you know exactly how much compute and resources need to be allocated to the database. And the other one being an auto-scaling serverless mode. You'll see more about this as we go into this talk. Lastly, but not the least, you can have specialized deployment options. When you're deploying just a single database, you pick the most obvious option, which is just single database. If you have a group of databases, we have a very useful option called the elastic pool deployment option. We'll review some of these options towards the end of this talk. One common misnomer is people hear the term hyperscale and they think, oh, this is only for the big databases out there, and I shouldn't be using hyperscale if I'm just getting started. Believe me, that's not the right perception. We unfortunately have the name which suggests that it is it's only suitable for the most, the biggest databases out there. I highly encourage you to watch this video. There's a short URL at the end called AKMS HS for all, and it's by our friend John Saville. He does a great job of painting the picture end to end and showing you why hyperscale is not just for those massive big databases. Take a look at your own convenience. You will enjoy that, and you will see why hyperscale is not just for those big databases. Hyperscale offers a fully managed experience. What does that mean for us? Azure SQL Database is a fully managed offering. What that means for you is, in practical terms, you don't have to install anything on your laptop or on your desktop. You can get started using the portal and in a matter of minutes, get your first Hyperscale database up and running. Pro tip, when you're starting afresh and you have no prior experience with Azure SQL Database, I recommend that you consider using the serverless deployment model that we talked about a little while earlier. That allows you to auto-scale and find the right sweet spot for the workload requirements that you have. All these operations, creating a database, reconfiguring it, scaling it up and down, and so on and so forth, can be done using a variety of clients. You can do it from the GUI using the portal. You have command line options. And again, a pro tip there is to use the Azure Cloud Shell, which allows you to get up and running without having to install anything on your machines. Lots of other options, including SDKs, REST APIs, and even ARM templates and Terraform if you want to go infra as a code approach. Here's a quick demo of creating your first database with the Azure portal. You give it a name, and then in this case, we're going to pick a pre-populated template, which is called the production template, that gives us hyperscale as the default choice. You then pick how many vCores, and in this example, we're picking the provisioned compute model, just with the assumption that we know exactly how many vCores we want. Once you've given it the name, pick the number of vCores you want, you just click create, and within a matter of minutes, your database will be created for you. You don't have to worry about provisioning storage because, as you see, we will automatically start small and scale the storage as we go along. More on that later. I just want to spend a minute or two on how flexible Azure SQL Database Hyperscale is. When you think about databases, you're thinking about tables and highly relational, highly structured data. The good news with Hyperscale is that it's a lot more than that. You have a variety of different data models and data types that you can support, right from JSON to spatial to graph. You have some highly innovative security features like the ledger. You have query intelligence using a bleeding edge query optimizer that SQL Server provides. And then you have all these integrations with external services, whether it's calling into endpoint from OpenAI or having a front end which serves the database as a set of GraphQL interfaces. Oh, there's a lot that Azure SQL offers to you, and Hyperscale specifically supports all of that. For a deeper set of insights into all these amazing capabilities, which go beyond just the traditional relational tables and allow you to integrate with things like AI, GraphRAG, Semantic Kernel, and JSON data, and so on, I highly encourage you to take a look at some of these other sessions at this conference itself. I briefly talked about some of the ways in which you can work with Azure SQL Database from a provisioning perspective. We talked about how you can use the portal, CLI tools, and so on. But from the programming perspective, when you want to work with the objects inside the database, the data that is actually stored within your tables and so on, there's so many tools to work with. Whatever language you're working with, whatever platform you are running on, whether Windows or Mac, there is a variety of choices when it comes to connecting and querying Hyperscale. Now, programmatically, you have a number of choices like C#, Java, Python, they all have native connectivity options in the form of drivers and libraries to connect to Hyperscale. From a programming perspective, you might be using VS Code, which is fully supported, connects to Hyperscale. You can write stored procedures, you can write queries, you can have database projects inside VS Code. And then a more traditional interface is through SQL Server Management Studio, SSMS, a very famous tool widely used in the Windows world. And that is one of the things you should be aware of. SSMS is Windows only. VS Code, of course, is multi-platform. To know more about these options and the choices that you can make, I highly recommend some of these alternate sessions at this conference by my colleagues Erin, Drew, and Carlos. They do a great job detailing all these developer tools and options that you have when it comes to working with Hyperscale. Now we're getting into the fun part, where we start talking about how Hyperscale works under the covers. The Hyperscale architecture is built ground up using cloud-native principles and best practices. It leverages, to start with, the separation of compute from storage. This allows you to right-size the compute allocated to the database without any dependency on how much database storage is allocated. It also allows us to do extremely high-performance caching at multiple layers. The compute caches data in memory, in RAM, and it also caches a second level of cache in the local SSD associated with the compute. To add to that, we have another high-performance storage cache layer, which is what we call page servers. These communicate with the compute to be constantly in sync, and because page servers are distributed and sharded behind the scenes, they allow you and your Hyperscale database to grow seamlessly from 10 gigabytes all the way up to 128 terabytes at this point in time. Behind the scenes, all data is also persisted to durable, long-term, stable Azure storage, so that if there's a disaster and you need to get a recovery of your database, it's always going to come back from that durable storage. So this is Hyperscale architecture in a nutshell. Here's a quick demo to showcase one of the latest innovations that we launched in Hyperscale last November. It is the ability to ingest data into Hyperscale databases at a mind-blowing 150 megabytes per second. That's a lot of data being ingested into the database. To show this, we are using a tool called Database Watcher, which is tightly integrated with Hyperscale. And we're going to look at the chart showcasing the write throughput on the database. As you can see below, we have up to 150 megabytes per second in getting into the database. This is huge when you think about the increasing demands for recording things like vectors and other types of unstructured data within the database. You can pump all that data quickly into Azure SQL Hyperscale. As I mentioned earlier, the name Hyperscale may imply that this database is only for really big workloads, really big storage sizes, but that's not the case. The scale in Hyperscale actually refers to scalability, and that means you can go from 0 to 100 when you need it, or scale back down to, let's say, 30 when you don't need all of that capacity and throughput. So to recap, the architecture, compute and storage are decoupled. What this allows us to do is to scale the compute up and down and even in and out. I'll tell you what that means in a minute. Whenever you need it, independent of how much data is stored in the database. Let's take a quick look at how this architectural innovation allows us to scale databases in place. So here we have a Hyperscale database that's configured with this so-called standard series hardware, and it has 10 vCores in it. It is configured to be zone redundant, which means it's highly available. And we are now going to switch it to use premium series hardware, which is available in most Azure regions and actually costs the same as Azure's as standard series hardware. We're going to go and scale this database from 10 vCores to 8 vCores, and then we're going to hit apply. The timing associated with this database scaling operation is actually very, very quick. Scaling operations in Hyperscale are very quick. Typically, whether you scale up or you scale down, it's going to take around 3 minutes. As you saw earlier, we scaled from standard series hardware to premium series hardware from 10 vCores to 8 vCores. And typically, this is going to take us around a 2-minute timing factor. You can query the status of such scaling operations programmatically. This could be very useful if you are programmatically scaling the database up and down from your application. If you choose to do that, then you can rely on this very useful a view in the SQL Hyperscale database called sysdm operation status. What this allows you to do is to programmatically see the progress and the status of that operation through code. So again, seamless integration from a developer perspective. You can use a variety of means to actually interact with the Hyperscale database, APIs, TSQL, and so on. Hyperscale storage scales automatically as your requirements for data storage grow. Here's a chart in the Azure portal showing how this database grew from a starting point of 10 gigabytes, because that's the minimum you can start with, and grows in increments of 10 gigabytes all the way to its steady state out here. So again, Hyperscale is not just for all those big, huge, massive databases. You can have a database as small as 10 gigabytes to get started. Another very, very useful and interesting capability of Hyperscale is the ability to scale horizontally, to add more replicas to serve read-only workloads. We have these things called named replicas, which you can optionally configure for a given Hyperscale database. The diagram here shows multiple named replicas added on top of an existing Hyperscale database. Each Hyperscale database can have up to 30 named replicas. Each named replica can host read-only workloads, which are running on the same data, because this database storage behind the scenes is shared between the primary and all these named replicas of your database. You can leverage both the high availability replicas and the named replicas associated with a Hyperscale database to run read-only workloads. Here's a simple example of how to do that using an connection string attribute. To start with, we are connecting to the primary replica, which is in a read-write mode. I can now change the connection string attribute and specify that I have a read-only application. So I say application intent equal to read-only. When I do that, that connects to the replica of the database. You specify the name and then you hit connect. You're now connected to the read-only high availability replica associated with the database. There you go. Now you can run read-only queries on this database, thereby offloading them and taking some of the workload away from the primary copy of the database. Named replicas, which are associated with the Hyperscale database, can also be further customized in terms of their configuration. You can assign different amounts of vCores and hardware types, and you can even select serverless compute for those named replicas. So this is a demo of how to do that using the Azure portal. We go to the create replica page. We specify that we want to create a named replica. We give it a name that's auto-populated for us in this case, right here. And then, as you can see, we are creating a named replica, which allows offloading of read-only workloads. And then you hit create, give it the name, hit create, and then within a few seconds, it's going to be created for you. Named replicas can themselves have these things called high availability replicas. Each named replica can have up to 4 additional high availability replicas, leading to a truly astonishing, amazing capability when it comes to read scale. In this diagram, we see up to 30 named replicas created for the same database. Each one of them has 4 high availability replicas. That means for this one database, we have a total of 155 replicas, including the primary. That's huge amount of scalability if you need it. Again, this is just a demo. We don't want you to be going out there and creating these replicas because it's going to cost you money. But then if you need that capability, if you need that kind of scalability on the read scale, you can do so amazingly quickly with Hyperscale. Just if you're curious, I was able to create those 30 named replicas programmatically using Azure PowerShell. So again, just a reinforcement of what I said earlier, that all these APIs are available for you programmatically as a developer. You don't have to use the portal to all these administration operations. I covered quite a lot in the read scale capabilities that Hyperscale has. If you're still wondering how exactly this would be useful for you, I encourage you to take a look at this end-to-end walkthrough that my colleague Jerry Nixon has posted on YouTube. Here's a short URL which takes you to his video where he does a great end-to-end walkthrough of using Hyperscale to implement the CQRS pattern. Hyperscale can be used to run all kinds of workloads, whether they are operational OLTP-like workloads or more analytical HTAP or hybrid transaction analytical processing workloads. The key to running either OLTP or HTAP workloads on the same database is to use something called column store indexes. Column store indexes have been around for a while in SQL Server, and they're equally available to you in Hyperscale. They work great with Hyperscale given the huge scalability that Hyperscale has, and they help speed up expensive analytical queries. There are also query processing enhancements that work great on Hyperscale. And the key thing I want to leave you with as developers is that if you want to leverage these intelligent query processing features, the easiest way you can do that is to make sure you pick the latest compatibility level when you create your Hyperscale database. That will, in most cases, get you access to the latest and the greatest on the query processing side. Let's take a look at how column store indexes can some really intensive queries. To do that, we have a Hyperscale database that's been provisioned to use the memory optimized deployment option that gives us a lot more memory per vCore. It also has 80 vCores, and it's set up to use a high availability replica on which we're going to run our queries. So as you can see, the connection is to the read-only replica. And in that database, we have one table that is an orders T table. The T stands for trillion. Imagine that we have a trillion rows in a single table. Huge. Now we are going to actually run some meaningful queries, such as counting the rows in the table. To do that, I'm going to run some statistics IO just to track the statistics, and then I'm going to do a count of star on that table. I fast forwarded the demo just in the interest of time. That particular query took less than 30 seconds to run. And you can see it's a trillion rows in that table. Let's run a more meaningful query on the same read replica of the database. This query is running a group by, and for each group, it computes the minimum and the maximum of dates and the number of rows for that group. This query takes a little longer to run, but it's still well under a minute. It takes 52 seconds to run. And for each group, it actually has scanned 200 billion rows, and it has 5 of those. So again, a trillion row table, hugely performant with column store indexes and this internal thing called a batch mode execution. Column store indexes are an unbelievable tool which Azure SQL Hyperscale gives you. Take a look at it. I strongly recommend it used for HTAP workloads. Azure SQL Hyperscale supports all the essential security features that you would expect and are used to when it comes to securing your data. We believe in defense in depth, and Hyperscale allows you to do all the things that you would need to do, whether it is network security, Entra ID authentication so that you don't have to have secrets embedded anywhere in your code, threat protection using Azure Defender, things like transparent data encryption, always encrypted to make sure that nobody who's unauthorized gets access to your data. As developers, the most essential tip I want to leave you with is to use managed identities to authenticate to Hyperscale. A lot of services in Azure support using managed identities, which are a secret-free way. That means you don't have to have a password anywhere in the picture to authenticate to Hyperscale. To do this, all you need to do is to configure an identity associated with the resource that is accessing Hyperscale. So in this case, we have an app service, a web app, which is authenticating using an identity to Hyperscale. To do this, the first step is to create a user in the Hyperscale database, which is referencing the managed identity name. You then grant it the permission to work with the data, reading and writing in that database. And then from your application, in this case, this is a Python app using PyODBC to connect to SQL Hyperscale using the ODBC driver for SQL Server, which is installed on a web app. Again, the web app is running Debian, so it's Linux. Everything just works. The web app has an identity associated with it in Azure. All that you need to do is in the connection string, pass in Active Directory MSI, which tells the code to use that identity to authenticate to SQL Hyperscale, and then pass in a GUID, which is the managed identities unique identifier. And voila, you no longer have to deal with plain text passwords and worry about how to protect them. The managed identity ensures a seamless, secret-free authentication to Hyperscale. When you're developing apps in a cloud world, you have to be prepared for transient failures. So it is highly important that you know about some of the capabilities that Hyperscale has when it comes to database resiliency. The modern cloud-native architecture of Hyperscale allows us to prepare ourselves for high availability. We do that primarily by using this thing called zone-redundant configurations of Hyperscale databases. We also, behind the scenes, store the long-term data in zone-redundant Azure storage configurations. Hyperscale has a variety of options to get you set for success when it comes to availability and resiliency. The first thing you need to know is to select zone-redundant configurations. And these are done at both the storage level, as you can see below, we selected geo zone redundancy, and at the compute level, which is this configuration up here where we selected one high availability replica and a zone redundant configuration. The reason I emphasize this to you as developers is because when you create the database, when you deploy it, that's when you select these options. They can't be changed after the fact. So encourage your cloud ops, and if you're deploying the database yourself, make sure you select these kinds of configurations which are zone redundant and highly available to protect against failures proactively. As a developer, the other thing you need to know is to be able to have your application ready to tolerate failures and retries if needed. So there are a lot of patterns out there. Here's an example of using a resilient connection pattern, which looks for certain error messages. So if the database is unavailable for whatever reason in the cloud, the pattern here actually looks for these error messages and retries the connection if need be. As a developer, I also encourage you to keep failures in mind, and testing for failures should be part of your integration and unit tests. SQL Hyperscale provides 2 PowerShell commandlets, whether you're working with a single database or an elastic pool model, to simulate failure of the database. This could be a great tool in your toolbox when it comes to testing the readiness of your application and hyperscale database for the resiliency to failures. Here's a nice demo to show you resiliency in action. We have a hyperscale database which is created with just 2 vCores, so a little small, tiny little database. It's created in East US, and it's set up to use a high availability replica and has zone redundancy correctly configured. This piece of code uses the same retry logic that we described earlier, and it's connecting to the hyperscale databases from multiple threads. We can see from a dashboard that's monitoring the throughput that the response time of the application that's connecting to the database is around 2 seconds. We're then going to use the PowerShell commandlet that we showed you to simulate failure on this single database. This is a great tool in your toolbox for testing for failures. We can simulate the failure by using the PowerShell commandlet, and then later, after we have the application retry the connection to the database, you can see that it automatically retried, has a delay of around 14 seconds while that retry was happening. And in the application logs, you can actually see the retry attempt. So here, we'll highlight that in the screen output. You'll see it retried once, and then it was able to reconnect to SQL eventually, and then the application continued working as it would have. So again, key things to remember when it comes to resiliency are configuring for zone redundancy, building your application with retry mechanisms in mind, and testing for failure conditions using the PowerShell commandlets that I talked about. So wrap things up with the bottom line. And the bottom line in this case is value for money, costs in simple terms. And the other thing, and this really blows my mind, is that Hyperscale is the only license-free Azure SQL DB edition. The price is aligned with other open source database options out there. You just pay for compute, backup, and storage. Nothing else, no proprietary SQL Server licenses. This is huge, in so much that Hyperscale can actually be cheaper than some of these other database options out there. Do evaluate it. Your mileage may vary, but again, Hyperscale is the only license-free Azure SQL DB out there. Cloud costs are on the top of everyone's mind these days. I will give you 2 options that allow you to optimize both the performance sizing and the cost of your database. The first one, which we described briefly in the introduction to this talk, is to use serverless databases. With serverless databases, the database automatically scales the compute and memory allocated to your database in response to the workload that is currently executing. By doing this, the total cost of a workload of a database that's running a workload that's unpredictable and sporadic can be much lower than when you were running with a fully provisioned copy of the database. So keep in mind, serverless can be a great tool to price and performance optimize a single database. If you're going to be using a group of databases, I highly recommend that you evaluate hyperscale elastic pools. With individual databases, you have to size each database to potentially the maximum resource requirement that it may have. With a pool of databases, you end up sharing resources like CPU, memory, and disk I/O across that group of databases. By doing this, you translate these individually unpredictable workload patterns into a collectively stable workload requirement. And by sharing those resources across that collectively stable workload, you can have great performance and also at a great price point. Here's a hypothetical comparison which compares these two models. A single database model for 8 databases can be as expensive as $4,200 a month, but a pool potentially could be much cheaper, around $1,700 a month. This is a huge amount of savings. So as a developer working with a number of databases, you should be aware of hyperscale elastic pools, work with your cloud ops team, or if you are doing the deployments yourself, I highly encourage you to evaluate hyperscale elastic pools to do both price and performance optimization across a group of databases. I want to share with you a few resources. These are great links to get started. They will take you through a lot more linked resources as well. There's so much to capture. We can't just put everything on one slide. So do take a look. I also recommend you take a look at the new Microsoft Learning Path on developing data-driven applications using Azure SQL Database. Lots of good learning there. Highly recommended. Again, if you have the interest, do take a look. Hey, thanks so much for attending this session and making it through all the way. I hope you learned a little bit about hyperscale. Hope I've kindled some curiosity in you to learn more. To stay in touch, you can always find me on LinkedIn. That's the easiest way to get in touch. And once again, thank you so much. Have a great rest of the conference.
And thank you, Arvind. Thank you so much. In fact, it's great to see the feedback and to be able to interact with the audience here. And great information about hyperscale. All right. Engineers and developers listening, thank you for tuning in to KSQL straight from Denver, Colorado. That's where I am, at least. And it's not really a radio station, of course, but we're doing a lot of great things here, and we're really able to see really some of the neater things that are available and that you may not have been able to dive into deeply. So this is SQL Conf. We are a curated set of SQL content specifically for you, the developer. And what can I say? When SQL Conf occurs, good things happen. I mean, the markets are up, the sun is out. It's absolutely beautiful. In fact, let me show you what I am looking out outside my window. I work from home, obviously. This is not Seattle. It's a beautiful day in Colorado. So I wish you guys were here with me so we could enjoy it together. Now, one of the things we're about to move into is Data API Builder. Now, this is close to my heart. I definitely love Data API Builder. It makes it extremely easy to connect to, interact with, and reach all of the Azure databases that are running on-prem or in Azure. So that means Microsoft SQL, which is our way of combining SQL Server on-prem as well as Azure SQL Database. It also works we have capabilities that are integrated into Fabric as well. It works with Cosmos DB, Postgres, and MySQL as well. It's open source and free. That's one of the reasons it's so great. And it was written for you. It was written for the developer to be able to experience and enjoy. And so we have a session coming up dedicated to Data API Builder, obviously what I'm talking about. And it is truly spectacular. All right, let's go. We have a couple of more comments. Let me just make sure that we go through all of them. Vinny jumps in and just kind of shares, hey, thank you, Arvind. That is a lot of information all at one time. Sam, you're asking, are there any breaks between sessions? This is a virtual conference. So the good news is you can hit pause anytime you want, and you can run and do and take care of whatever it is that you need to. So I appreciate that. There was a quick question from Vinny asking whether or not SQL Database, Azure SQL Database, is the PaaS offering from Microsoft for SQL, and the answer is yes, absolutely right. You know what I appreciate? I appreciate Azubin and how polite he is. Thank you so much. You're absolutely right. Wandisha says the same thing. And I run in here. Here's B again, right? It's the sort of thing we're working on right now. Isn't it funny how that happens? Now you start talking about something only to realize it meets the need that you have, like at this moment. So really great. I want to just change the direction now to to Chris, who's going to be talking to us about Data API Builder. If you haven't already seen Data API Builder, have you lived under a rock? However, how do we go from using it and making it so that as developers, it makes us more productive and faster to develop our data APIs? Maybe you have data APIs as an upcoming milestone from your company, saying that we need to interact only through data APIs from this point forward and not talk directly to the database. If that's you, Data API Builder is for you. And so let me just jump right back into this one last time. Data API Builder, if you want to find out more information, it's aka ms/dab. And let's get started. Chris is going to walk us through some deployment options to make it so that this is an easy thing for you to do, so that you can orchestrate those containers that it runs in and make it so that this is just a brainless activity that you go through. That makes it sound like it's brainless, so that it is something you don't have to stress over and think too heavily about. Let's take it from Chris, walk through each piece step by step. Thank you, Chris.
Hey there. Welcome to this session of SQL Conf 2025. My name is Chris Wiederspan, and today I want to talk to you a little bit about this combination of Data API Builder and Azure Container Apps. As you know, Data API Builder is great for taking our databases and then exposing that data out through a set of APIs. And Data API Builder, or DAB as we call it, is really fantastic at making that super easy. I can kind of just declaratively say what data I want to expose, whether I want it to be read-only or read-write. I can declare permissions around that, and it really is fantastic. On the flip side, we've got Azure Container Apps. This is a platform as a service offering within Azure. It makes it super simple to take a container image, spin it up, expose it out to the world if that's my goal. And I don't have all that overhead of something like Kubernetes or the learning curve that comes with that. It really is meant to be easy, quick, simple to manage. And we take care of all the scalability aspects of that, the deployment aspects, blue-green deployments and things like that. So when you take both of those technologies and you kind of glue them together, you come up with a nice, compelling solution that makes it really easy to build and deploy APIs for your applications. Before we jump in, let me just introduce myself and tell you a little bit about my job. My name is Chris Wiederspan. I work here at Microsoft. I'm an Azure App Innovation Specialist. I always describe my job as helping customers build and run their apps in the cloud. I spend my days talking to customers about things like containers, Kubernetes, Azure Platform as a Service. We talk a lot about DevOps, platform engineering, infrastructure as code. We also spend time talking to our customers about developer productivity. How do you make your developers more productive with things like GitHub Copilot? How do you structure your teams to get maximum efficiency out of them and your processes? But that's enough about me. Let's jump in and get started. I've got the next 30 minutes broken up into these three topics. The first one, design and development. We're going to talk a little bit about using DAB locally. If you're familiar with this term, inner loop, that kind of refers to the work that I, as a developer, am doing locally on my own machine, that process of building out code, or in this case, building out my DAB config file, which makes up my data API builder APIs. But I need to be able to run that, test it, iterate on it, fix things, all that kind of stuff. So we'll talk about that. But I don't want to just talk about that in the context of local development. I really want to focus on this theme of containerization. How do I do that with containers? And specifically, we're going to use two different containers. One is a container that's running SQL Server. It's got a sample database loaded into it. That'll kind of serve as the API backdrop. So that'll have our data that we're going to expose. We'll be able to test it. And the other one is our actual data API builder application. So As we build that config file, we're going to put it inside of a container and test it out. And once we have that container, we'll do things like push it up to a container registry so we can use it on Azure. Speaking of Azure, we'll go ahead and deploy a SQL Azure database. We'll use that same sample database we used in our local container, and we will deploy the Azure container app. We'll give it a connection string to our database, and then we'll use our container image that we're going to download to actually run the application. Luckily, that's just about it in terms of the slides I have for you today. I do have a GitHub repo though, and pretty much everything I'm going to do today and show you is coming from this aka.ms/dab-aca URL. You can see the actual URL down below, but this is just a GitHub repo I have on my account. It's got all the files that we're going to use. It's got the commands that we're going to execute in the README file. So please go check that out, especially if you want to follow along and kind of do some of this on your own. So here I am in the repo inside the GitHub website. You'll notice this is not a overly sophisticated application or demo. There's really only a couple folders, a couple Docker related files, some configuration files. We will talk through all of that once we get this up and running. The one thing I do want to call out here is that I'm going to use GitHub Codespaces to run this. The one file that's relevant to that is in the .dev container folder, and then there's a dev container.json file. This really just lays out the groundwork for my containerized development environment. So in this case, I'm using kind of just the generic base image from GitHub. I'm also instructing it to load the Azure CLI, .NET I need in there for the DAB stuff. And then I'm telling it to pre-install a couple of extensions that may be useful along the way. But since I've got that, I can go ahead and click this big green button. And then within there, you can see I actually already have a code space running. All I need to do is click that and say, open up in Visual Studio Code. I'm going to do that in the desktop version of VS Code. Okay, so here I am in VS Code running this repo in my container. I'll probably keep saying locally, but when I say locally, I just mean inside of code spaces. Now, this is the README file that we saw before. You know, the idea here is that we've outlined several steps that we can take to kind of reproduce the development environment that we're looking for. And the idea is that we are looking to do things like iterate with our code locally. That's that inner loop that any good developer loves to maintain, an efficient process. You don't want to have to push code up to the cloud every time you want to test it. So that inner loop is important. And to get started with that, you do need to set up a couple environment variables. I'm not going to get into all of these. There's this sample.env file. You'll notice I have my own .env already copied over, and it's updated with a couple secrets. Most notably, I had to create a Docker pat token that connects me to my Docker Hub account, which is where ultimately we're going to push some images and pull some images from. So I need a security token for that. Everything else is kind of just made up, including like this dummy SA password. We'll talk about where that gets used. My tenant ID and subscription ID are just GUIDs. They're not really secrets, so nothing to hide there. But we need to have that env file. And once we do, we can come in here down to our terminal that's running in our code space. And we can just say source.env, and that loads up our environment variables. And just to kind of prove that out, if I do So I'm going to echo out what my location variable is. You can see I've got that set to West US 2. Okay, so now we're back in the README file. We've kind of taken on this prerequisites step, and we're good to go with our variables there. This is where we kind of get into that inner loop development process. We want to do that in a way that's friendly to the container theme that we're working on here. And so we're going to use some local Docker containers. That is Docker and Docker. If you're familiar with kind of code spaces and how you can run Docker within a Docker container, but that's subject for another day. But one thing we can do is we can start running some of these containers. And the two containers that I have of interest, and I'm going to pop open the Docker compose file. There are two containers defined in here. One is a SQL container. That is actually running SQL Server inside of a Linux container. You can come and check out another repo that I've got that shows where I build that image and how I restore the database. But it's going to restore the AdventureWorks LT database. That is a sample database that you can get online. You can download or restore it into SQL Server. It's just a jumping off point for us for illustrative purposes. But it's nice. It works with DAB fairly straightforwardly. Okay, so that is my SQL container. There's some health check stuff here. We're not going to get into that too much other than the health check simply makes sure that my database server is actually up and running, that my database has finished restoring, and that's when it gives the all clear that the health check is good. That matters because I don't want to start the second container until that first container is done. This depends on. And for clarity, my second container is the actual data API builder application. We'll talk about where that's coming from here in a minute. But for the time being, what I really want to do is I just want to kick off that SQL container. And so I can use this Docker compose command. And I can run that. That went quick because I've already run that before. You'll notice it exposes port 1433. Because I'm using code spaces, it uses a nice little proxy utility to expose that to my actual physical laptop that I'm running on. And if I want to, I can prove that out. I can come over here to I've already got my password saved in there, but I'm just connected to local port or my local machine, which is proxying up to GitHub code spaces. I can say connect. As you can see, I have that AdventureWorks database available, ready to go. It has a few tables in there and things that we can then connect our DAB implementation to. Okay, so now that we've got a SQL container up and running, this is the actual development work that we're talking about. So this is you as the developer being able to run the .NET tools like Data API Builder and initialize that. When I initialize that, it's going to create a file called dabconfig.json. Now, in our repo, we've got a file already called final-dab-config.json. That is essentially what you would get if you ran all of these commands. In fact, it should be identical to that output. So for the sake of time, I'm just going to rename this file here and get that final out of there. And then we can use this file moving forward. All right. Now that we have that file, let's go ahead and run the rest of our application. So you remember our Docker compose file. I've already got this container running just to show you that. If I do a Docker PS, I can see that I'm running that AdventureWorks Docker file. So let's go ahead and add the next piece of that. And we'll let it build our Docker file. and run our container. So that was pretty quick. You'll notice it's exposing port 5000. But let's go look at what that Docker file actually is. This is really kind of the key point of this whole session, is that this is not hard to run a data API builder application inside of a container. It is literally 2 lines of code inside of a Docker file. The first one is just using the kind of official Microsoft data API builder image that we publish. And then I am just jamming my dab config file into the app folder there. And then again, for my Docker compose file, this is that application. You can see I'm exposing port 5000. I'm executing the Docker build. So this dot here just gives it the context, which resolves to this Docker file. And then I do have to pass in a database connection string. So this is the connection string that my application container will use to connect to my database container. You'll notice the server name for this is just SQL, which maps up to this label for that image. And if I come over here, let's just pop open another terminal window, Docker PS again, you will see that I am running 2 different containers. So that is how those 2 will talk to each other. That is how the DAB container will reference the SQL server that's connecting to that same database that we've been talking about, the AdventureWorks LT. And this is one of those environment variables that I had in my .env file. So you can see I set the password on the SQL container, and then I embed that password inside of an environment variable, which is getting set into the application container. And that's how I can do all of this stuff without, for example, checking in a secret into my connection string. Now, if I want to test this, there's this cool utility in VS Code. It's one of the extensions. It's called the REST client. It's really great for helping you test out your local APIs, or any APIs for that matter. In my case, I've got to connect to localhost port 5000. That's that port that we're exposing. Because our code spaces is using that proxy to expose port 5000, we should be able to get to that. And then this .http file that we're looking at, it has the capability to do things like variable substitutions. It's got a nice little templating syntax, and it lets me do things like send a request to my local application and get back data. So I'm actually here kind of doing a test against the entire application that's running locally inside of my environment. No cloud resources at this point. Everything's just happening right here within the code space. So at this point, we've kind of built out a local inner loop development process. We've talked about how our Docker file makes this possible to containerize our application. We've talked about using the Docker compose file to kind of stitch that together into an entire working local version. Now let's go ahead and put this container up in the cloud. So I'm going to come back over to my README file. We're kind of moving on to this topic 2, containerization. I need to switch my thing back. I'll go ahead and close out my Docker compose, let those containers unwind. Okay, so that's done. Clear that up. So here's what we're going to do next. We're going to log into, in my case, I'm using Docker Hub. There's certainly more probably sophisticated and secure ways to do this. In my case, I don't really care if these images are up there publicly available. There's no secrets in there. They're just for illustrative purposes and makes the demo a little bit easier. So I've logged into Docker. And my next step is, again, I'm going to use that Docker file and I'm going to build this container image. That went fast. I already had all the parts there for that. And if I, Docker image list, you can see now that I've got a Wiederspan, AdventureWorks, DAB, latest tag. That's the one I just built. It says 6 minutes ago. It's just because that's byte for byte the same image that we already have. So it's essentially just relabeling it. And just for completeness, you'll notice this bigger image is that SQL image that I was running. It's a little bigger. It's been around for 6 days when I started working on this. And it is already local. Okay. Final step here is I want to get this Docker image up to my Docker Hub account. So I'm pushing it up there. Pretty much, again, already exists just because I've done this before. Show you my repositories. You'll notice that image, same one we just pushed up 1 minute ago, is now up in the cloud. And what we want to do now is we want to be able to deploy some Azure resources and actually load that container up, run it inside an environment, have an Azure-based SQL instance of our database. That would equate to our prod instance, for example. And the way we're going to do that is we're going to look at this bicep file. Bicep is just Azure's native infrastructure as code language. It's kind of layered on top of ARM templates, if you're familiar with that. But it makes it a little bit easier, kind of roughly akin to the way Terraform works. So I've got 4 different variables I can pass in, or parameters I can pass into my bicep file. The first thing I'm going to create is a managed user identity. That managed user identity will be used to run the container app. So the container app will run in the context of that user, and will also assign that user the admin permissions, the SQL admin permissions on our database. We'll see that here in just a second. Second thing we're going to do, we got a few kind of infrastructure-y things. We're going to use the Log Analytics workspace. We're going to use App Insights. Those are things that our Azure Container app will actually wire up to, but for the sake of today's discussion, I'm just going to breeze over those. Here's where we're going to actually install the SQL Server, or set up the SQL Server. So we're using the location that we've designated. We pass that variable all the way through from our .env file up to our commands that are going to execute the bicep. You'll notice I am, from a security standpoint, I'm using Active Directory as my authentication mechanism for that SQL Server. And I am gluing it to that managed identity that I created above, which in effect is making that the SQL admin over the entire database. I'm not using real best practices here. I'm not clamping down on firewall rules. I'm not using virtual networks like I should. In the real world, obviously, I'd have a lot more security baked into this. Here's my database itself. So this part of the reason we're using this AdventureWorks LT database is because in SQL Azure, that's one of the databases that I can use as a sample. And just by setting this property this way, it will automatically restore that same database that we used locally, or I shouldn't say the same database. It will restore an identical copy of that database into the SQL Azure database. And then we get into the actual container environment. I'm not going to get too much into the Azure Container App overview, other than if you're familiar with ACA or Azure Container Apps, there's an environment that's kind of your platform as a whole that you're creating inside of Azure. We're doing things like connecting that log analytics workspace. We're connecting the application insights. Those are for observability's sake. And then this is the actual application itself that's getting installed on that platform or spun up on that platform with our container. Again, from a security standpoint, this is where we're connecting that to our managed user identity. So this container app will run as that user, which inherently means that it is going to have access to the SQL server. Again, target port 5000. That's what we need to access this app to expose it out. And as you would expect, we are also setting that database connection string environment variable. This time we are wiring up the server to our SQL server that we created up above. And we're just using the bicep mechanism to put that SQL server inside the connection string. We're telling you which database to connect to. In this case, that's that AdventureWorks LT. We are telling it that our user ID is that managed user identity. But you'll notice nowhere in here is there any password. That is the beauty of the managed identities. They don't require passwords. Azure takes care of all that under the covers, and you don't risk storing passwords in connection strings or checking them into your repo or just having them get out there in the world. So really nice security in that sake. The only thing I will call out is I've got an output URL. This is where I'm actually going to output the URL for the container app that we're using. We'll use that to then plug back into our test file and actually run that. So let's get going on this. So I'm back here in my README file. I'm already logged in. I don't need to do that again. I will go ahead and create a group. So this is creating the resource group inside of Azure. So that's done. So now you'll see I've got an empty resource group, nothing in there because I haven't done my bicep file yet. Let's go do that now. This is the command, the AZ deployment group create, where I'm passing in my bicep file. And then I'm passing along those variables that we've kind of talked about throughout. Let's grab that. This will take a minute. So we'll kick that off. All right, so you can see that that finished. If we come over here to back to my Azure portal, you'll see I've now got all those resources in there. And I can find that output, which is this thing here. I can copy that. And if we come back to our testing file again, and I just replace my old value in there with the new value. So this will allow me to test against this newly deployed infrastructure that's running up in Azure. It's going to just run the health check, get a nice 200 there. If I query my customers, I get, as expected, all that customer data. Same thing with all of my other queries that I can run. So we're in good shape. We now have built a container. We've built our DAB configuration. We've pushed all that up to Azure, and we now have our application up and running. I do want to call out one more file in this repo. It's in the GitHub folder under the workflows folder called pipeline.yaml. This is a GitHub action file. It really just ties everything together. So references a few variables and secrets. It does the Docker push. It does the Azure bicep deployment, effectively deploying your app to Azure. And it just pieces everything together. There is some documentation here in the README file under this topic 4 that gives you what you need to set up your secrets and your variables using the GitHub CLI. We talk about where you get the Azure credentials and how those fit in. And then when you're done, just use this cleanup section to tidy up and remove all the resources that you created as part of the demo. Well, time flies when you're having fun, as the old saying goes. Here are a couple links that you can use to dig in a little bit deeper to the technologies that we talked through today. I had a great time making this and learning all of this stuff on my side. So I hope there's some tidbits you can take away as you work through these on your own. I also want to mention that the Microsoft Learn website has some great free resources that you can use to learn about SQL-related technologies and really anything else Microsoft related. Again, it's free. Please take advantage. There's a ton of great content there. But that's it for me. I'm out of time. I really appreciate you spending your time here, and I hope you enjoy the rest of the sessions.
Thank you, Chris. I appreciate that. Thank you for this content. Definitely, Data API Builder is a game changer for developers who are trying to interact with their database in the most simple way possible. Maybe you have a development team, an engineering team, that they are perhaps new to interacting with a database, but they're not new to interacting with an HTTP endpoint. They know already how to interact and manipulate JSON, even if they don't yet know how to interact with a result set or a data set that may come back. This is the answer for you. You get capabilities right out of the box, just like you would have written them. Exotic capabilities, but not exotic code. This is open source, so you can go and look at the code yourself and see this is how you would have written your own data API. But why spend the time? Why not look at your code base and think about it as maybe a third of it can be removed, because the data API itself can be replaced with an engine. This isn't code generation. It's not anything that is super off the wall and weird. It is simply a pre-written engine that gives you a data API over your database inside a container that executes and is configured by a single JSON file that allows you to point the data API to your database and then describe which tables, which views, which stored procedures you're going to expose, what the security on each of those is going to be, whether or not you have caching, what the different security is going to be, whether or not you have an access policy in place as well, all the things you would hope to have and probably would write yourself. But why spend all of that and deal with all chasing the bugs? We all do the same thing. We want to create an API. We go back to a previous project where we already did it and we did a good job. Copy that code in, make some changes to it, and it's just the same repetitive code over and over again. Now I need unit tests for those. Now I need to implement them inside my CI/CD pipeline. Why not erase all of that and make it so the Data API Builder just gives you your data API that is robust, feature-rich, and totally secure? So check it out. It's an open source project that is written by Microsoft that is for you. It runs in AWS. It runs in Google Cloud. It runs in Azure. It runs on-prem. It's open source and free. So it's totally up to you how you want to use it. And so check it out if you haven't already seen it. Now's your chance to take your API game to the next level. All right, so what have we just talked about? Data API Builder. What are we going to talk about? More app development. So you've already heard about it. It's .NET's prescriptive guidance on how to build distributed, reliable applications. It's .NET Aspire. .NET Aspire, integrated both into Visual Studio and VS Code, gives you a full suite and complement of tooling that allows you to interact with containerized solutions. So maybe you're an engineer out there thinking to yourself, I haven't really gotten into containers. Well, lucky you. So much around containers now has been abstracted and simplified to make it even easier. That's what .NET Aspire is really about. So just like Chris showed in the previous session, we can go and we can configure our Docker container with a Docker run file, or we can start looking at .NET Aspire that allows you to do the same sort of thing, a sophisticated interaction and orchestration of all of your different containers in C# instead of in YAML. So that's an exciting next step. So let's back up and just talk about a couple of things really fast. The first is when you're ready to learn about Data API Builder, it's AKMS/DAB. When you're ready to get the credential, to the applied skill for develop data-driven applications, which covers what we're talking about today and make sure that you are able to not just learn it, but also show your proficiency professionally, you can go to akms/SQL/dev/path. All right, so we're headed into the next session, number 5 here, SQL-first development with .NET Aspire. This is going to be with Erin, you've probably already seen him present many times. He is a prolific and excellent presenter, and a very compelling story here around .NET Aspire, and a beautiful story and handshake between the narrative of .NET Aspire and container orchestration and SQL Server. Maybe you already know, maybe you don't know that SQL Server runs inside a container. That's right. We have a Windows, it runs on Windows. We also have it running on Linux inside a container as well, so that you can have it in your local development environment, as well as deployed in places wherever a container can be deployed also. So that's a really neat capability that we've had for some time now inside SQL. This is one of the things that Erin's going to talk about. So let me go ahead and get us started.
Hello,
this
everyone.
Is Erin.
My name's Aaron Powell. I'm a principal cloud advocate here at Microsoft. And today I want to show you how we can use .NET Aspire to improve the local development of an application with our databases. So how we can have that kind of database first view of application development, but still use the power of .NET Aspire to make sure that we can get that really nice developer in a loop. Now, I don't have any slides for this. Instead, we're going to jump straight over to Visual Studio, start looking at a problem that we're most likely have all come across in building applications, and take it from there into building out our application and leverage .NET Aspire. So I've got an application here. It's got a ASP.NET Minimal API backend. It then has a Blazor front end and a couple of projects with some data models that uses Entity Framework to then talk to a SQL Server database that I have on my machine. Now, I've already provisioned that database. You'll see that it's here. Inside of Data Studio, I can see my database. I've created a table for it. It's a simple application, so I've only got a single table inside of there. But like I said, this is just running entirely locally. If I come back over to Visual Studio, we can launch up our application. It's going to start up both the API project and it's going to start up our front-end project. And we'll see those. Here we go. Just pop that over onto this part of the screen. And we'll see that we've got about 500 database entries that I've got in here of just seeding out a bunch of sample information. I've got a little search feature, so I can say search for solar, because I know there's solar flashlights. And there we go. That's all of our data that's there. Now, this is obviously a very common thing that we have, APIs talking to databases and things like that. But the challenges start becoming when we want to make sure that we can work on this collaboratively within a team. What are we going to do with that database? Well, I could share an export of that database to other team members, and then we just have to make sure that we keep those in sync. Maybe we're going to put the schema into source control so that we can restore that. And if a new developer joins the team, well, they can just restore from the schema that we've got within inside of the database, and then maybe we'll provide a thing that'll scaffold out some data for them and all that kind of stuff. But this can be a little bit clunky, obviously, because there's a bit of manual steps, and we've got to make sure that the database is provisioned, or they're running the Docker container for SQL Server, or whatever the case may be. So let's start off by adding, we're going to add a new project to this application. We're going to use the SQL Server Data Tools project in Visual Studio. I'm going to use the SDK style, and we'll call this product database. Okay, there we go. We've added that one in. And now I need to create a new SQL file. So we'll use all templates, and I'm just going to create a schema. We're going to select, we'll call this products. Oops. I'll call that products. Pop that in there, and cool. We've got our sorry, I should have used the table. But to speed this up, let's just come into here, and we're going to export out our table, because I think this is probably the process that we'd go through to do this anyway. So we're going to export that out, and we're going to grab just this create table chunk. Back over to Visual Studio. There we go. Cool. And now I can go ahead and say, deploy this. I can publish this off to one of my databases that I've got somewhere. Sorry, I just generated the DAC pack for that. And then I can say, where do I want to deploy it to? So I can come into here and connect to my local database, which is just running. I've actually got that running in a Docker container locally. And we can provision that. I won't go through the process of doing that because I think we're probably all familiar with that sort of a process here. How we can use the SQL data tools to then go ahead and generate our database. This is the first step along the way, right? So we have this here now. So we have our database. And the last thing I want to do is I want to have a way that I can seed out those products. So we're going to add a new item. I'm going to add a post-deployment script this time. And we'll call this leave it as post-deployment one because I'm a little bit lazy when it comes to naming things. This is also it's a demo. I can leave things named as I want. And I'm going to come in and we're going to grab our DB initializer, and you'll see that this file, this is where I'm generating out all that. But I'm doing this in C# code, and I kind of want to shift this off to the database and have that seeded there because that's something that we might only want to run locally. I don't want this code accidentally getting shipped to production. So I'm going to have a little bit of a cheat here. I'm going to use GitHub Copilot, and I say, take the code from we're in DB initializer and generate a SQL script to seed the database. And this should go ahead and generate me all those insert statements for our tables. So there we go. Give this a moment while Copilot thinks up what it looks like. Cool. That looks pretty good. Copy that code block, and then we'll come over here and we'll just paste it in here. Sweet, there we go. That's going to generate me out the exact same amount of data. And then say come into here, and then I can actually get rid of this DB initializer entirely. So inside of, where is the DB initializer used? That's right. Sorry, it's a class that just gets called on initialization anyway. So we'll just comment out that code, leave it in there, come back and have a look at it in the future if you need it. So, okay, now that's going to seed out our database, like I said. So we could go publish, and that's going to then generate the DAC pack file. We can then insert that into our database and have that published as we're wanting. Awesome. But we still have these manual steps that I got to go through, as we saw. Right click, publish. We generate our DAC packs, but it is a little bit simpler than it was before, where we had potentially backup files that were passing back and forth, so that we could have the same amount of seed data that we have on everyone's machine. So the next step we want to do here is we want to improve this by actually leveraging some .NET Aspire features. So for anyone that's unfamiliar with .NET Aspire, it's a tool for building distributed applications. So we can add, whether it's microservices or distributed monolith, or even if it is an application as simple as this, which is just an API and a backend, we can use it to improve the local development experience by having it help manage the orchestration of all the components that are going to be moving. In this application, for example, we're going to have our API and we have our Blazor front end, but we also have a database. That's another component within inside of our application infrastructure that we need to get managed. So let's start by inserting .NET Aspire, or orchestrating this application with .NET Aspire. I'm going to come here and I'm going to right click on the products, and then I'm going to come to add .NET Aspire orchestration support. So we're going to say that I want to name, I'm going to use the prefix eShop, and it's going to generate me out two projects. One, eShop app host, which is where the orchestration is going to happen, where we define all of the components or our resources within inside of our application. And then we have our service defaults, which is a bunch of things that we can add to .NET projects that ensure consistency, things like resilience, logging, so on and so forth. So let's go ahead and generate our Aspire orchestration. It's going to, like I said, it's going to insert those projects. We're going to add a new couple of NuGet packages that are going to be in the project. We get a bit of an overview, talks a bit about what .NET Aspire is and how we can use it. And there we go. We see our eShop app host, our eShop defaults. We also see that our products solution has been updated. It's going to be referencing our data, our service defaults. It was already referencing our data entities because that's where our entity framework is defined. But we're now using our service defaults, and it's come in here and it's inserted the add service defaults that if we were to jump into, we'll see that it's doing things like I said, configuring open telemetry. So we get some nice rich telemetry and logging and things like that. We'll see those shortly when we actually launch our application. Health checks, some service discovery, and a bunch of other things that get in here, as well as some things that it can suggest you to also include if you want later on. All right, so let's have a look at what's happening with inside of our app host project, because this is really where the kind of the magic is happening here. We'll see that we're getting our distributed application builder, and we're adding the project of products to it. All right, the next thing I want to do is I want to also add orchestration support into our store. So I'm going to come in here. I'm going to say add orchestration support. It'll detect that .NET Aspire is already orchestrating part of this application. So it's just going to add it to that existing orchestrator rather than generating a new one. And again, it's done the same sort of things. It's come into here, added our service defaults and some default HTTP endpoints. So things like health checks, they're now available. And we can see that that's all connected. They're both available there. But we want to connect these applications up a little bit. So what I'm going to do is I'm going to say that I have this is my API project, and I'm going to say that my store project is going to have a reference to our API. I'm also going to wait for the API project to be ready, because until that project is ready, I can't really use our store frontend. The last thing I'm going to do inside of my application here is that you'll see that I have a hard-coded endpoint for the backend for our product service. This is where it lives. It's going to live at this, it thinks it lives at HTTP localhost 7130. But what happens if I change the port that it's running on, or I deploy this into a production environment? Well, it's not going to live there. It's not going to live on localhost. So I'm going to change this to use the service discovery feature. I'm going to do plus HTTP products, because that is the name of our resource that we've defined here. Now, if we we're changed to launch the app host project instead of our individual API backend and everything. If we launch this, fingers crossed that this live demo is working, everything should just keep working exactly as it was before. We're just going to ignore the error about SQL Server data project. I'm just running some preview builds of that inside of my machine, so chances are that has caused an error, and nothing like a proper live demo where I'm going to be having to kill my Visual Studio instance. So let's just kill this all off, get this back up and running in a moment. Let's launch Visual Studio again. Here we go. Okay, launch our eShot demo application. All right, should be back and running. Let's hit restart. Fingers crossed it goes better the second time round. All right, there we go. Compilation is looking good. No errors, and if we give it a moment. So what it's doing behind the scenes is it's launching up the app host for .NET Aspire, which is then going to launch this Aspire dashboard. There we go. We'll see that we have our store and our products both available, which is what we're expecting. Those are the two services that we had running. If we were to have a look, say, at some information about this one here, we'll see that we have our endpoint down here for the products. And we'll see that those are the two endpoints that are available from the products API. And if we were to launch that up, I should still be able to get a list of products. We'll give that a moment. There we go. Excellent. So our application is still up and running. We've brought in .NET Aspire. We haven't done anything yet with our database side of things. So generally speaking, our application is working as we want, but we want to do this. The point is to improve our database experience. Because at the moment, we're still having to run our SQL Server locally. So the next step that I want to do is I want to add in the database features for .NET Aspire. So I'm going to come to my app host, and then I'm going to add a Aspire package. Now for this, I'm going to search for SQL, and we're going to search for, yep, there's our SQL. And you can notice that there are a bunch of different hosting packages that we've got here. So we've got hosting packages for things like Postgres, MySQL. We've also got Azure SQL, but we're just currently worrying about local development. So I'm going to use the Aspire Hosting SQL Server package. I'm going to install that in there. So because I'm in my app host, I'm working with a hosting package. So this is the thing that's going to start a service that we're going to depend on. So there is our SQL Server added. And now I can come back into my app host and I can say SQL, I want to do builder.add SQL Server. And let's just call that SQL. And then on SQL, I can add a database. And we'll call this a products. There we go. So now we've got some very explicit descriptors of what's happening within inside of our application. The next thing I want to do is I want the API to have a reference. So I'm going to use the with reference again, and I'm going to say that I want to capture, actually I should do that as a single set of statements. So I'm going to say that I want the SQL reference here. And then again, we're also going to wait for the SQL server to be ready. Well, more accurately, this database within inside of the SQL server to be ready. So that's all up and running. And so assuming that gets up and running, things should start working together. So let's just launch this, see what happens, and see how or if that changes what's happening inside of our application. Let's just see. Looks like the process was still running. May have. Okay, I still had the old debug instance running, I think. So let's just relaunch the application. Nope, it's still running. Processes are running somewhere. And nothing like live-ish demos. Let's grab that process ID and let's terminate a process. There it is. End task. There we go. Okay, third time's a charm. I'd say that I get this in editing, but I want to prove that this is live. Okay. Oops, I accidentally gave it the same resource name. So I gave the database the name of products, and I also gave my API the name of products. Kind of can't do it that way. So I'm going to change this one to API, and then I will come and update my code down here. So we're going to connect to the API, just so it's a bit more obvious about what it is. I could have called that, maybe I should have called that product API. I will. Launch it up, and let's see. This is up and running. We'll get our dashboard, and we'll see that we actually have our new resource added into our dashboard. Notice here that we have our SQL Server. Now this is going to run the SQL Server container image. So what it's going to do is it's going to pull that image if you don't have it locally. So this is going to require Docker or Podman if you want to use a container or manager other than Docker. Podman is the alternatively supported one. So it's going to pull down the container image based off of the one that it says to use with inside of the hosting package that we've pulled. So this is going to be pulling the latest of the SQL Server 2022. And then once that is pulled, it's then going to start running the database. So they're all up and running. And this time, if we have a look at our products database here, sorry, our products API, and I'm going to come down, you'll see that it's inserted a connection string called products. And if we have a look at this, there is our products database. It's going to be running on a random port because it's randomly assigned a port here. It's got a it's generated, it's using the SA user, and it's generating a random password that every time I restart that password, it's going to generate me a new password. So let's just clean that up. And realize I'm using some incorrect NuGet packages. I was using preview build NuGet packages, but we're using .NET Aspire 9.0. There we go, clean that up, and that will just make sure I'm not getting any warnings or mistakes from using preview packages. All right, so we're able to set up our database, but we're not getting, there's no information inside of that database. We're not provisioning it with that schema that we've got. Now, we have that inside of our code base here. We have that product database. So I'm going to add another package to our app host. So I'm going to add a new Aspire package. This time, I'm going to use one from the community toolkit. I'm going to search for SQL again. And inside the community toolkit, so this is a community project, outside of Microsoft, that is producing a bunch of extensions to .NET Aspire to then work with other things that we might want to do, such as SQL database projects. I'm going to grab the latest preview build of this package because it's got a few new features around working with database projects. I'm going to add that in. So that's now available. And inside of here, I'm going to add so the next thing I need to do is I need to add a reference of add the product database to the app host as a project reference. So I just drag that in and we'll see that that is now available here. I'll save that. And then I'm going to generate my, we'll say the products DB project, just because that's a good enough name for it. We're going to build a.add SQL project. We'll go projects.product database. And we'll call this products DB project. Again, just because naming things is a little bit hard to give names on the fly. And there we go. So now we've added the database project. And then what I'm going to do is I'm going to add that here. And we're going to say wait for completion of our SQL database project. But where are we at? But one other thing that we still need to do with this is, well, we need to tell where to publish that database to. So we're going to say with reference. And this time I need to provide it with a connection, either a resource with a connection string, or I can provide it with a SQL Server database resource, which if we have a look up here, that is what SQL is. So I'm going to say, I'm going to add that with SQL. And we're also going to say, wait for SQL to be ready. So when the SQL Server is ready and the database is available with inside of that, we're going to then deploy this product DB. We're going to wait till it's not wait for completion. I want to just wait for, because once that is running, we can then deploy our SQL database into there. And then that is then going to be provided as a reference to our product project up here. Now, the last thing I want to add is for my products API project, I'm going to add a Aspire package for SQL Server with Entity Framework so that it is capable of finding it. So at the moment, we're kind of like, how do we find the connection string? Well, we've had to add that to like my app settings, and we need to know the username and password, but we're generating a new password every single time. We're generating a new port, an endpoint for the SQL Server. So if we add this Aspire Microsoft Entity Framework SQL Server package, what it's going to do is it is going to then use what Aspire is providing it. So it looks up at some of the logic that Aspire understands, finds that, and then knows how to get that connection string. Connection string that's been generated for us. So inside of here, instead of saying add DB context and then use SQL Server, let's comment that out. We'll do builder.add SQL Server DB context, and we'll say context. And we need to tell it what it's called. So this one is going to be called it's products. So what is the name of the resource defined inside of our app host, which is our products. There we go. So that should be there. Now let's hit F5, launch our application. And this time it's going to get the SQL Server, image from Docker, or this time it should run it locally because I've already got that image available. And then it is going to make sure that there is a products database inside of that. When that's done, the SQL Server SQL Server project is then going to run and set up the database schema inside of that, and then seed it with our sample data. It is then going to make that available to our API project. We can see our database is up and running. We can see that this is publishing. We can have a look at our logs. We'll see what's happening. Seeing that it's waited for the resource to become a running state. It's now initializing the deployment of our database project. I could also just provide this with like a direct backpack if I wanted to do that, or I could even pull one straight from NuGet if that was my more preferred approach. So there we go. That should all be done. Okay, it's finished. So now that's finished. Now our API is up and running. And if we were to say, let's just have a look at the product endpoint here. There we go. We have a whole bunch of SQL data that has been provisioned in here. I could come into my front end, come into products. Give this a moment. There we go. It's pulled back all of the products out of that database, which is now running entirely inside of that container. When I stop this database, it would then delete that container, delete the volumes, clean up all of that data, and make sure that I don't have any of that lingering left over anywhere. Now, obviously, you might not want to destroy the database every single time. So we could do things like so I could add on the SQL server, not on the database. So we add a volume, there we go, with a data volume. I could also say that I want this container to be, so I can change the container lifetime. So so with lifetime, I could say that I want this container to be persistent, so it doesn't actually stop the container. Obviously, it would mean that we're not having to create a new database every single time. We're not needing to redeploy the database schema every time, so on and so forth. So you've got ways that you can control that a little bit more fine-grained. Now, the last thing I want to demo off with this, I'm actually going to switch to a new branch that has a few more features inside of it. So just I'm going to store all these changes, and we're going to jump over to another project because I want to show you how we can use multiple databases simultaneously within inside of a single Aspire application. So let's just create a git commit point, add -a git commit demo, and then we're going to jump over to a demo with AI because, well, I'd be remiss by not including AI as part of a demo at some point inside of here. All right. So what I've done now is, or what's happening inside of this application, and let's just hide my Solution Explorer a little bit, is this time I want to have a vector database stored with vectors of all the products. But instead of putting that inside of my SQL Server, let's say that the SQL Server is deployed on premise and I don't have the vector support with inside of that, or maybe I don't want to modify my production SQL Server database to then add SQL vector support or anything like that. I want to push vectors into something else, maybe something that's a bit more optimized for it. In this case, I'm going to be using SQLite. I just want a super lightweight vector database. So I'm going to be using SQLite here. I'm using a extension for SQLite called SQLite Vector. And then I'm saying that I want to use this. It's going to be available via a NuGet package, which I actually have already referenced within inside of this project. The SQLite vector is going to be in a binary called vec0. And then depending on if I'm running this on Windows versus Linux versus Mac, it's going to load the right one using the right file extension. And then I'm also inserting this into a SQL. I'm also using the SQLite web UI so that I can have a look at what's in that vector database. Now, with we still have our product database and our reference to our SQLDB project. So we're still scaffolding all that up the same, but I need to populate the vectors here. Do that, I have created a command, a custom command that can be run on my API project to then go ahead and seed that. So this is called seed vectors, and then it's going to find the endpoint to our API project and then call an endpoint that it exposes to seed our vector database. Let's go ahead and launch this using the app host and kind of see all the moving parts that are going ahead with this. I've also within inside of my app host here, I have defined Olama. So I'm running Olama with our AI models that are going to be running locally in them. Because it's topical at the moment, I decided I was going to use DeepSeek, so I'm running that locally. I also have an embeddings model, which is just a very small embeddings model, which is running locally. But now you'll see that my application has become a lot more complex. I have a bunch of containers that are starting. Olama's web UI. I have SQL, which is also running inside of a container. I have SQLite Web, which is the web UI for SQLite. I have my models, projects, our SQLite database, our products database. All these things are all going to be running. And this is now something that I could clone directly from the Git repo, stand up. It's then going to scaffold out, when I launch this, all the right databases, the right schemas within inside of the databases, the tables that they need, and all that kind of stuff. So I've only got about 2 minutes left. Let's hope this gets all up and running. Okay, looks like that's there. We can say, let's have a look at SQLite Web. we'll see that I don't have any tables within the side of here because I need to come into my products API. I can use that command that I've added. So this command is obviously running against my products database to then go ahead and seed data. We could say take that that script that I had that was seeding the products database with sample data, and instead of using that locally and using that within inside of the database project, I could have that as a command that gets run on side of on my products project. I could have added to my SQL. I could add commands in here to say clean the SQL database out, delete all tables, delete all data out of the tables if I wanted a way to reset the database, things like that. Let's have a look at our products database, and we'll see that there we go. It's inserting a whole bunch of records. Like this is going across to our vectors. We can have a look at this in our structured logs. We can see here, we'll see that there's a trace that's happening. We can have a look at this trace within inside of my Aspire dashboard. We see all the things that are happening here. I see that it's talking to the product database, and this is going out here. It's also talking to my API for Olama to get that back to then insert it into the database. So we can start getting some analysis. I'll just zoom that back out to 100% so we can see this a bit easier. We can see all that's happening here, all these cascades, and I say it's eventually inserting into. It'll actually insert that into my SQLite database. There's like 500 of these, so it's going to be quite a long little thing that we go right down to the bottom. All right, no, it's not quite done. Still sitting at our database. there's a lot of sample data that we've got to insert here. All right, let's have a look at our console logs for it because it's easy to have a look here. All right, where's products? Okay, where we're up to record 400. I should have really reduced the amount of this. And obviously this is like taking a little bit longer because I'm now running it locally with a whole bunch of containers while also running the recording. And we can see that it's definitely giving my machine a good test of wills. But there we go. Okay, so all that all the memory records should be created now. So that means that I could jump over to my web API, a web UI here, and if I was to come into search, and let's say I want let's go sunny. Sunny should semantically be similar to solar. Let's see what happens here. Looks like I might not have all the vectors set up yet. Let's just do one last quick test, and why did I click away? Oh no. Anyway, I know that I'm out of time. But that is kind of the end of what I've got time for today. I see that we went through the process of starting off in Visual Studio. We started off with a project that didn't have anything within inside of this solution that understood our database. We added a SQL database project. From the SQL database project, we then added .NET Aspire. With .NET Aspire, I moved away from having a SQL server that was deployed onto my machine to then having that as a resource that I was defining inside of my app host. So I defined my SQL server and the database that was going to be needed within inside of it. I then added my database project as a resource to that Aspire application and specified a database that will be deployed into. I then added those as references across to my API project. My API project then knows how to find my SQL Server connection string because it's got an Aspire package for ND Framework to load all of that up, so I don't need to worry about managing connection strings. And then finally, we added a additional database here with SQLite with some extensions loaded in for SQLite, plus a custom command inside of my Aspire application that is able to then seed out that database by calling an endpoint within inside of my products API. But this could also be calling our SQL server. It could be executing a SQL post-deployment script if I wanted to do it that way, rather than having that embedded inside of our database file and potentially deploying that as part of our DAC pack. Like I said, that brings me to the end of what I have time for today. If you want to learn more, you should check out the Aspire docs at aka.ms/.net/Aspire, and that walks through a whole bunch of scenarios that we can do with databases. And you also find the docs for the community toolkit, including how to use database projects inside of that. Thanks for joining us here at SQL Conf 2025, and we'll see you next time.
Thank you, Erin. Thank you for that presentation on .NET Aspire. There really is something to .NET Aspire being able to simplify a multi-container solution in such a straightforward way. I don't know if you noticed, but his app host file had right around 21 lines in it. And it is just, there's something to being able to simplify things. And I feel as if the technology that we're looking at today is finally reaching a place where we hoped it would be, where we can start to see the complexity of things starting to slowly be ratcheted down as we write wrappers and handlers around things to make sure that, one, they're done correctly, but two, they're done an easier way so that they can be approachable by basically every developer like you. Well, you are listening to SQL Conf 2025. This is SQL-specific content curated and tailored towards a developer audience like you. Hopefully, you're enjoying where we are. So far, we have been able to really cover a lot of the basics, going through the AI capabilities that are just around the corner for SQL, being able to talk through the new capabilities that JSON has. That's one of the things that was most important, is that now it's a binary format, so it's extremely high performance. We talked about hyperscale and the 10 things that developers need to understand on why this is the SKU that you're almost certainly going to be picking. We talked about data API builder. It's the obligatory data API builder mention. That's for me, AKMS/DAB, DAB. That's our way of adding a data API in front of a database that is or isn't a SQL server. So we got Tommaso. He's like, all right, data API builder loves containers and we love DAB. Yeah, same with me. Pretty good question here. Does it support any other database or only Azure SQL? It supports Postgres, it supports Cosmos, it supports MySQL, and it supports SQL Data Warehouse as well. More importantly, maybe not more importantly, but equally important, is the data API builder runs in Azure, it runs in AWS, it runs in the Google Cloud, it runs on your computer locally, it runs on-prem, and there's no license to say it needs to be one place or the other. So it's open source, free, and available to every developer to take advantage of it so that they can have a robust API. As Erin was talking about in this last session, we've been able to see that the integration of SQL Server becomes a common drumbeat across all of the tooling that Microsoft has and is providing to developers today. So that's good if you're a .NET developer. It's excellent if you're a JavaScript developer, if you're a Python developer, if you're a Java developer. Whatever you are, we have a way there as well. And so one of the things I'd like to just bring your attention to is to talk about Azure SQL Dev Corner. So this is our website that holds all of our blogs. It's a place where not only we announce different things that are available, but it's also where we walk through some capabilities from our engineering perspective. So our PMs, of course, work so close with our engineers, and we write blogs to make it so that you get to have the same sort of information we have. One of the blogs I'll just point to you here is .NET Aspire and Data API Builder with the Community Toolkit. So what Erin showed is how you can include SQL Server inside your Aspire application very easily. This blog would walk you through how you can also then overlay the database with a data API using Data API Builder and through the Community Toolkit. So that is the .NET Aspire Community Toolkit that allows you to just say builder.add data API builder, exactly the way you would hope it would be. So easy, passing around references and waiting for different containers, just like he demonstrated, but having data API builder in the mix as well. There's a lot of terrific information in our blog here. I just want to point you to it. And it's easy enough to find it. You could just, frankly, just search for it, Azure Dev Corner blog, and you'll find it straight away. All right, next is going to be around tooling. If you're a developer, you love your tools. Are you a Visual Studio developer? Then you love Visual Studio and all the things you can do. You can go into the SQL Server Object Explorer inside Visual Studio and have an incredible time of just going through building out your SQL projects or just interacting directly with the database. You can use there's so many extensions, but the EF Core Power tools are probably the most incredible ones that give you capabilities right there inside Visual Studio that allow you to do all kinds of things that you don't have to do by hand, and you can be confident that you can do it. So if you're a Entity Framework user, then you can use that same tool and it'll produce for you your data context and all these other pieces as well. But the tooling story around SQL is something that is changing. We just announced that we are moving away from Azure Data Studio and we are moving toward VS Code. That means if you're a fan of Azure Data Studio, well, congratulations. The features that you like there in ADS are going to show up in VS Code. That means you only need a single tool, and we'll expose that to you through the extension that we have. And so that extension, if you could see the roadmap that I've seen, it is the most aggressive and incredible roadmap you ever, just feature after feature after feature. And it's not a couple of features this quarter, another couple of features next quarter. It's features every month. And so it is really just cranking up the volume to make it so that the developer value is as high as we can possibly make it. Carlos is the PM, and he'll be talking about all of this to us. He'll walk us through what your experience is supposed to be and how you can take advantage of features that you have today in VS Code, but also in features that you will start to see coming in just a handful of months. Let's go ahead and get started. Thank you, Carlos. Looking forward to this.
Hello there. Welcome to SQL Conf. Very excited to be part of this brand new conference that is focused to share all these great things we have in Azure SQL for developers. The title of this session is Getting Started with SQL Development in VS Code. And in today's session, I'll be focusing on showing you the latest and greatest features that you can find in the MS SQL extension in VS Code. So I'll be covering the newest scenarios that we introduced back in October 2024 with the new UI and some other very exciting news that I would like to share. My name is Carlos Robles. I am a senior product manager in the Azure SQL data team, and I'm part of this team that is responsible for building the different tools, the different experiences, and also features that developers can use when building applications that happens to have a SQL Server, an Azure SQL, any flavor, or even SQL DB on Fabric databases as part of their backends. Okay, so let's jump into the session and let's start by defining what is the MS SQL extension for VS Code. All right, so from the VS Code marketplace, we can find the MS SQL extension here. So if we look at the description right off the bat, you can understand that the main goal for this extension is to help developers to seamlessly work with databases and making it easier for you to interact with those database schemas that makes part of your backend application. And we, as I mentioned at the intro of this video, introduced a new UI rich features, as we call them, back in October 2024, and we have been evolving these features since then. So I'll be covering all those things. I will be connecting to a database. I will be showing you how to run queries, how to design a table using the new table designer, and more. So for that, I created this application, and I will jump into that in a second. That is using what is called a dev container or a code space, so you can follow along. And I will jump into the repo and everything else. So if we want to start here with the extension, as I said, this covers the description. You can check on the VS Code marketplace, and you can browse here about all the different things that we include here as part of the extension. I guess the most important thing from here is to check the repo. From the repo, very important, here's where you can share your thoughts about the extension. If you want to, let's say, report a bug, or if you want to, let's say, or if you want to ask for a new feature, this is the place. Or maybe ask a question, the community can help you as well. So just click on here, new issue. Of course, you have to navigate to the repo before that. So you can find the repo as under Microsoft organization in GitHub, and the repo name is VS Code-MSQL. From here, as it said, simply click new issue and report a new bug, or maybe start with a blank issue because you want to share your voice, you want some new feature in the extension. So we want to hear that feedback from you. So feel free to contribute, be part of the project. And as I said, I'm very excited to show you the new things we have on this extension. So I'm going to jump into my repo. My repo is very simple. If you want to follow along, you can find this repo under my GitHub user. Here's the name, C Robles M, and the name of this repo is library-app. Super simple. I have only a backend and a front end. This is a Node.js plus a React application. As I said, super simple, nothing complex. I already have this environment running on CodeSpace. So the CodeSpace is basically a dev container running on the cloud. So GitHub provides us with these free tier where we can run some of our dev containers if we want, and I already did that. So I have my my dev container / CodeSpace running. So let me jump into that. And yeah, so this is VS Code, as you can see, is connecting to my CodeSpace. So I have my application. As that says, my application is super simple. Let's just navigate through the application really quick. I have a CRUD super basic API. And by the way, you can use whatever you want to create this API, even something like Data API Builder that can create the API for you just through the configuration file. You can explore that. Probably Gary Nixon, one of our senior PMs, will be talking about this topic during this conference. But anyway, so you see that I have a CRUD for a table called authors, and it's just the basic insert, the select and delete, and the same goes for a different table called books. So I am adding new records to this table and grabbing some information between a couple of relationships here, and that's it. So again, super simple. So this application was created with a database in mind for sure. So let's imagine I'm part of this team, and this application was already created. There is a database and there's a script I can use to create this empty shell, if you will, database. So how can I interact with my database in VS Code? So you have plenty of options for sure, but what I'm going to show you today is the MSQL extension. So we're going to start from the extensions marketplace, and from here I'm going to search for MSQL. And as you can see, I have these list of different extensions returned. But the one I want to use today is the SQL Server MSQL extension. And as you can see, for those that are familiar with the extension already, we have a new icon. So during the last release, we introduced a new icon. So as I said, we're making changes, and we are looking forward to hearing more from you so we can introduce even more features. But yeah, so the extension is here. Something very important to understand about the extension is that extension also includes other extensions as part of a pack. So it's like a bundle, if you will. So we have the extension, the core extension here, but on top of that, we get the data workspace, we get the SQL database projects and SQL bindings. That means that if I install this extension, these other satellite extensions that are a complement of my experience will be installed as well. Okay. And if you're familiar with SQL database projects for an SSDT, it's the same. So it's basically a way to create declarative database projects using an SDK style. So all that is part of the same experience. So In this case, I don't have the extension installed, so I can just go ahead and install it on my code space. Probably the experience will be a little bit different for you if you're running Visual Studio Code locally, but yeah, that's it. So there is something that is happening here very interesting. If you can tell, I got this prompt that says, okay, do you want to enable the new UI? So I can just say, yes, enable those experiences and reload VS Code for me. So once again, if I go with the default experience, that will be the old UI. But back in October last year, we introduced this new UI. So all it takes for you to use this new UI is to enable it using that prompt, or maybe later using the VS Code settings. But right now, it's all set for me. I got the extension here. And as I mentioned, it's a bundle. So it comes with SQL database projects. And as you can see here, because I have this project using a dev container, it's already identifying that there is a database project here. This makes sense because I didn't tell you that, but I'm using something else here to have this environment ready. There is something that's called dev containers, as I mentioned at the beginning. So if I go here, to the dev containers, and we check something really quick here. Let's do it from here, actually. Here. So you see that I can add a configuration file to my project, and that's because I have a dev container. And in my case, I am already using one of the Azure SQL dev containers. So this dev container includes all the libraries, all the different things, tools I need to get started with a Node or JavaScript and Azure SQL project. So that's why SQL database projects is already identifying that. But I don't have a database connection. And to be fair, I deleted the database connection because it comes with one out of the box when using a dev container, because I wanted to show you how it works. So let's start from the basics, and let's add a connection to my local database. I have a local container running with the database I need to interact with my application. So let's connect to that database. So just by clicking this button that says add connection, you see that I have this new UI. For those that are already familiar with the MS SQL extension, in the past, when you wanted to connect to a database, you need to use the command palette from Visual Studio Code, which was, I would say, a little bit cumbersome if you have if you made mistakes. But we listened to your feedback and we introduced this new nice connection dialog. So I'm going to give it a name. I'm going to connect to my local database. The name I want to give it is local dev. The server name is going to be my local host. I'm going to use a SQL login just for example purposes. Probably not the best practice, but it's running locally, so I just want to connect really quick. If I want, I can save the password here for future cases, or if I want to have a strong security measure, I don't want to do it, but this is local development. It's all good. I'm the only one using it. And so, yeah, I'm ready. I'm going to click connect. Oh, something happened here. Nah, I did that on purpose. So I wanted to show you this. If you can see, the connection dialog is telling me, yeah, there is an error. Or it's more warning than an error, to be honest. It's saying, yeah, you didn't check the trust server certificate. And that's always required when you want to establish this connection, secure connection between your client and your database. So that was one of the options here that I ignore on purpose. So I'm going to click on here and I'm going to connect. So it's secure by default. There are more options if you want to explore. So for example, if you want to explore some of the advanced capabilities, just by clicking, I did it too fast, just by clicking the advanced button right here, you can access to a different set of settings or advanced settings on the connection itself. So as you can see, I can change the default port. I can say, yeah, this is a multi-subnet failover, more about security and encryption, more about pooling. If you want to modify the packet size that is being sent between through the wire, you can do it. You can, in case you are using a database that it's only read-only or application intent equals read-only, you can set that by here. So plenty of options for those that wants to have a more advanced experience. For me, this is okay. I just need to connect to my local database and that's it. So a couple of things. You might be wondering, okay, I made a mistake or I want to like change the name of my profile. Can I do it? Yes. So if you click this pencil button right here, you can modify this profile as we call it. So I can give it a different name. You see on the right hand side, we have this nice panel that shows me saved connections, recent connections. So you can go from there. We're planning to introduce more features to help you have your connections organized. So stay tuned for that. Yeah, the other question. So I said, yeah, maybe 2 questions. The other question is, can I use the extension to connect outside my local, like my local environment, my local database? Yes, you can. As I mentioned in the introduction of this video, we introduced capabilities recently that you can connect to different target. So if I have an Azure SQL database, I can connect for sure. If I have a SQL database on Fabric, I can do it. That's the newest series option we have available in Azure Data. So yeah, you can. So let me show you. I already did a couple of things beforehand. So for time purposes, the first one is that I am using VS Code here to authenticate to GitHub Copilot, but also I can do it for Azure. So by using this extension, you can authenticate to Azure and you can also filter resources. That's very important when you have a subscription that has many, when your tenant has many subscriptions, you can filter the subscriptions by using these other extension. I already did that. I'm going to show you. I have plenty of subscriptions, so I am filtering my subscriptions to only one. So I did that already. I have my account added into VS Code, so I'm ready to use the MS SQL extension to connect to Azure. So if I want to connect to an Azure database, so what I have to do is, once again, I'm going to click on the connections. I'm going to give it a name. I'm going to go with Azure Browse here and take a look at what is going on right now. Is pulling the subscriptions, the resource groups, and everything I have already filtered by using this other extension, the Azure extension. So I'm going to go with my subscription here. I'm going to look for a specific resource group where I know I have my databases. So if I click here, I got the entire list of different resource group, or I can just type and there we go. That's the one I want to use. It's already like, if I have a resource group that has server, or in this case, it's an Azure SQL database or logical server, it already identified that. So I'm good. Here's my location. I'm going to trust the server certificate this time. And I am going to connect to this database called MED, or Microsoft Experience Day. I'm not going to use SQL login here because, as I said, we want to use a secure connection, and I'm using my Enter ID. So I'm all set. I'm going to click on sign in here just for to make sure everything works as expected, and I'm going to authenticate here off camera really quick, and I believe it's all set. I'm ready to go. So by clicking connect here, I should be able to connect to this other database that exists on Azure SQL, in an Azure SQL logical server. And that's it. So as you can see, I have 2 connections now. I have one to my local development environment, which has only one database called library. And I have this Azure SQL logical server that has different tables. It's a different database, right? So it's a Microsoft Experience Day, or MED as I call it. So all set. I'm all good. So I'm ready to start like working on my local environment. So I'm going to delete this connection because I don't need it anymore. So let's delete it, and all good. If I open the connection panel again, you see that my saved connections are limited just to what I have saved here on my workspace. So the other connection that I deleted from here, it's like gone. So it's all good. So it's secure. All right. So let's explore the database real quick. So as I said, we introduced new features. One of my favorite features is the object explorer filter. So in some cases, I happen to work with these databases that has thousands of tables. And it's very difficult when you want to focus on a single thing or just check something about a table and you have a very long list. So what you can do is filter. It's very simple, right? So right here, right off the bat, you can see that I can filter my objects. I can filter my tables. I can filter my views, my synonyms, my stored procedures, whatever I have. So we have filters built into every single node of different object lists into the extension. So let's try it. From here, let's say I want to filter all the tables that starts with the word authors. Let's do it. Or maybe auth. Let's try something. We'll get to back, right? So, okay. So author. Let's do author. And all good. So I get 2 tables listed here as I expected. But what happens if I want to go back and look at the books table? So all I have to do is to click on this icon to remove the filter, and that's it. Super simple. Very straightforward. There are more capabilities here, as you can see, that you can filter by schema, by create date, by who's the owner, and we have different operators for each one of the filter properties that contain certain text, does not contain the text, ends with something, started with something. So I would say the basics. Okay, so all good, really great. So let's move on and talk about a little bit about the tables. So let's say I am, as I told you before, I have this application, right? So we didn't go into that. So I have this application, and let's open a couple of things here. There we go. Okay, so I mentioned we have a CRUD operation going on for authors and also books, right? So I'm like doing all different things with these 2 tables. And if we jump into extension, we see that we have those tables here. So as a good developer, I am connecting to my database locally here to make changes, and I'm using an environment variable here just to connect. And I want to, let's say, verify the data. I want to check my backend, making sure it can talk to my database. So what I will do is to use curl just to do an HTTP request to one of my API endpoints. In this case, I'm going to use one of my favorite extensions in VS Code, and it's called, if you want to take a look, and this is a third party, by any means, it's open source, so I'm not doing any advertising here, but it's called REST Client. If you want to try it, I love it. So here I have, again, 2 tables, right? Authors and books. That's the CRUD operation. And by the way, CRUD means create, read, update, and delete. So that's what's happening here with my API. So I'm going to send a request really quick here to the authors endpoint. And as you can tell, I get my HTTP request back as an OK. And I got my JSON return. So I get all the data back for these endpoint that I'm checking. And I can do the same for books. So by clicking here, I got the same information from books. And this is a very long list. What happens if I want to do a cross check of this with my database? I can do that by using the extension really quick without leaving the VS Code environment. So that's very cool. So let's do it. Let's check the books table, and I can simply get a glance of what is on that table by doing a right click, select top 1000 here, and of course that's going to return the list of there we go, of books in this table. So the list is long, and there are different things that we introduced with the new UI as well. You can see that there's a filter button right here, and it allows me to change the sorting. If I want to change the order, I can do it descending, and now it's in descending order, or I can put it back to ascending. And if I want to only see one record, I can do it. And by the way, we are working on these features are still in public preview, so we're still refining some of these experiences. If you have any feedback about what you are seeing here, please don't hesitate to share it on the comment section or reach to me directly. So yeah, so as you can see, very powerful here, but I have a small problem. The way the results are displayed here are not very, I would say, helpful when you're comparing stuff like this, like side by side. Luckily, the extension introduced a few things that you can use. The first one is that you can open the results in a new tab. So as you can see, okay, now I have a new tab with the results. So it's no longer using the VS Code section where you have the terminal output and everything else. And it asked me, was probably too fast, if I want to set this behavior to be the default. So let's do it again. Let's run our query and let's pop up the results, and right here it says that, do you want to always display your query results this way? And you can say yes if you want. So we hear your feedback, because that was one of the most requested updates in the new UI, because we changed the way we display these results, and the community was probably not very excited about it. So we provide you options. So right here I have the option to continue using this this way. And what it makes this interesting, and let me zoom out, is that in the case I want to compare my results from my table to my API, I know my API probably is returning everything from my database correctly, but I just want to double check. Or what happens if you are using a JSON static file just to feed your API and you want to see how it looks. Whatever the case might be, you have this option. Okay, so really cool here that we can see the results side by side. And if we want to double check one, for example, let's take a look at this one, Journey to the Center of the Earth, and that's by Jules Verne. And if we look at the ID 2016 here, and I have exactly the same information. So it's a very easy way to check what is going on between your application and your database. But what happens if, okay, this looks good, but for some reason the performance you are getting when using your app is not the ideal? Okay, let's say users are complaining, you want to investigate what is going on, this query is not performing as it's supposed to be. So you want to understand a little bit more what is going on from the database side. You can understand by using something called the execution plan. So let's go again here and let's take a look at what happens here with this select star from select 1000 from my table. I have plenty of options here. If I hover this option, it says that reveal the query result panel. Remember, I have it like on the tab, but I can just click here to reveal. I can change my connection. I can run the query, excuse me. I can disconnect, I can change the database. But these two new icons are something we introduced back in, I believe, November. So for now, I can get an estimated plan. Remember, I said, probably I'm a developer that likes to like dive deep into the database internals. Probably this is not for everyone, but if you want to get an understanding of what is going on behind the scenes, by just clicking this button right here, it gives you an estimated execution plan. So it's going to explain you what is going on your database, what operations are being executed on the database engine. So by clicking the estimated, I got like, okay, this query is going to cost this amount of CPU, this is the path that it's going to take. But in some cases, the estimated is not equals to the through right here to the actual execution plan. So if I enable the actual execution plan, I need to rerun my query again, and you will see what happens here. My query was executed, right? So I got my results back, but I have this new panel that says query plan. And from here, if I want, I have those two options. I can zoom in Let's zoom in here a little bit. And yeah, by using these buttons here, I can zoom in, or I can see this in a new tab. So once again, I got the options to have these displayed side by side. Let's focus on, let's go back to original one. Let's run it again really quick. And from here, let's zoom in and understand what's going on. So from here, you see that there is a select top 1000 over my books table. It's using a cluster index scan. So remember from the previous comment, like maybe for some reason, this query for very specific user that is selecting an option is not performing well. Maybe there is a missing index. Maybe there is something going on. You can understand what is going on behind the scenes by using an execution plan. And if, let's say, you are not not too much into execution plans as me, I just understand the basics, but I want to I have a dedicated data person that can help me with that. I can just click on save here, and I have the opportunity here, the option to save this execution plan and share with somebody else that is an expert on performance tuning and can provide me some answers about what is going on. So very, very powerful. We get more information here in case you want to look at the query. But yeah, I don't want that. Let's do it again because I closed it. Local. There we go. Okay, we're back. And from here, there was one thing that I really like, and this is the properties. Yep, that's what I wanted to see. This gives you even more information about what is going on, what is the statement, what is the estimated number of rows that are going to be returned, and more. As I said, if you're into performance tuning, or you have somebody that can help you tune this query, you can use all this information provided by extension to help you out. Okay, so let's get back to our application, because again, we are building an application and we are interested to do more in this environment. I'm going to close my query and I'm going to come back here. So all good. So we learned that we have a new connection dialog. We have a new way to filter objects by using the Object Explorer. We have ways to move our query results into a tab experience. We have the capability to use this function to get me an estimated plan or an actual plan for a query, but we have even more. So let's say I have in my app, if you remember, my app is only, let's see, right now my backend is only performing actions for CRUD operations, for authors and also books. So let's say I have to create a new table called magazines. I want to create a new table. I have plenty of options. I can start by asking Copilot to assist me. I can use the SQL database projects from here to create a new table by using this declarative model. I just simply click add table. I give it a name. I work with the table name, and that's it. I'm not going to do that because I want to show you another option. Oh, the most important option. If you're a code-first developer and you like to use ORMs, let's say I'm using SQLize for this JavaScript project, I can also use ORM for sure. But if you want to, let's say you want to get more involved, if you want to learn a little bit more about T-SQL, you can also create a table by clicking on this button right here that we call the table designer. Okay, so let me get all these things out of the way really quick. And by the way, I just can close everything. But anyway, I'm all set. So let's click on here, and that will open the new table designer. As the name implies, this is a designer. It's a UI that allows you to interact with this wizard type of building a table. While you make changes, you will see the changes represented in T-SQL. So let's go ahead and do it. So from here, I have to give it a name. So let's say we said magazines, right? So let's take a look at something real quick. Yes, magazines. And you can choose the schema. For sure, I am using DBO, so I'll go with this. So from here, I don't have to think about the primary key. It's already there for me. It's like, okay, ID is a data type int. It's a primary key is identity. That means that it's going to auto increment, and you can control that. But right here, I see that the identity is going to increment, and it's going to start by 1, and it's going to increment by 1 as well. So my first record is going to be 1, my second is going to be 2, and then and so on. So all good, looks promising. What about if I want to add a column, and let's say the column name is going to be description. So I'm going to go with description here, and the type is going to be barcode. So barcode, it's enough. And I want to allow nulls. Why not? The default value for this is going to be, let's say 40. And I'm all set. Oh no, sorry, the default value, I was looking at something different. So the length, this is what I was looking for. The length for these column is going to be 40. So all set, I have my description. As you can see, I have these column properties. So if I want to do more, for example, if I want to add a description to this description column, this is the description column, I can do it. If I want to control the default value, remember I mentioned that before, I don't want to do that for this one, so I'm all good. What else? And if I want to specify the identity, this is not identity, but let's take a look at what happens with ID. For ID, it says is identity, the seed is 1, and the increment is 1. So we're all good. All good. So far so good. I think that's all I need here. But what happens if I want to add a foreign key? So if I navigate here, you see that I have my magazines. My primary key for the magazines table is the ID. You can control the name. If you want to add, for example, let's say the schema name, you can do it. Let's hear your feedback. How you would like to see the name here. It will be interesting to understand more from you. So yeah, if we want to add a foreign key, I can do it. So I'm going to add a foreign key here really quick. And the name is given by default, is to telling me, okay, which one is going to be the foreign table? It's going to be, let's say, authors. So what we're going to do now, it's going to add a new column mapping. And by the way, I forgot to add the column. So let's say it's going to be ID authors. Int, all good. So let's jump into a foreign key here again. And it's going to be authors and all set. So I had to do a mapping between the columns I want to build this relationship. So from my, this table, the child table is going to be ID authors, and this is from the parent table. So this is ID from the authors table. And that's it. I have created this new magazines table. This line 11 is probably when I click on the, it's the description right there. When I click on the description, so it add a description as a metadata. So I'm all good. So I have a couple options. I can open this onto the editor and execute this script from here. I can also copy the script in case as I said, I want to just learn about T-SQL and I want to share this with somebody else, or maybe somebody else asks me for help. And this person asks me, hey, can you help me create this table? And I'm like, probably not an expert in T-SQL, but I can use tools like this to help me with that. But yeah, let's choose the obvious and easiest path. And here is just by clicking publish. By just clicking publish, this is going to push the changes for me. It's what it's called a migration, right? So it's a schema migration that's going to add that table for me. And I click that I accept the changes. This is calling DAC behind the scenes, DAC effects, sorry, the framework, and it's all done. So I can close the designer. And I can close this other query, and we can navigate to our Object Explorer again. And as you can see, I have the magazines table now. So all good, I didn't have to refresh. But what happens if I have to make changes? I can just simply click here, edit, and I can start by making changes to this table. And while I make changes, for example, I remove the description here. You see that my changes are also reflected here on this T-SQL portion of or section of the table designer experience. So it's really cool because you get to see what you are doing. So right now, just remove the description, and basically I'm all set. I can just push my changes again and update the database, and I'm all good. So if we open this again, we should not see the description, not even if I click on here. So all good. So yeah, it's very simple to use the MS SQL extension. As you can see, it helped me to connect to my databases, to run queries, to even teach me how to create tables by using this nice UI. And if you want to learn more about the extension, I encourage you to go to the repo again. That this is not repo here, and read about the different features we're introducing. You can look at the different releases and look at the different features and capabilities that we are adding by every new release. And as again, I encourage you to try it and share us some feedback. We are looking forward to introducing more and more features to focus to help developers to have a great experience while building these backend databases of their applications. And that's all I have. Thank you so much for listening in, and have a great SQL conference. See you next time. Bye.
Thank you, Carlos. Thanks for walking through what is perhaps the most important thing to a developer, the tool that they'll be using. And I know that's true with me. I love Visual Studio Code for the types of work that it's perfect for, and that's the reason I love to use it. I love Visual Studio for the type of work that it's perfect for. And I also, I have been using SQL for a long time, so SSMS has been a tool that I can use with my eyes closed. And to know that SSMS is getting the same kind of love that we're giving to Visual Studio Code, because developers are in one place or another. We're trying to make it so that we're not asking you to come to us, we're going to you. And so many of these capabilities, hopefully you can already see it. Carlos has a passion for the experience and that inner loop that we keep talking about the developers are in, so that it is fluid, so that it makes sense, and that you can intuit capabilities that you expect to be there, and then you find them where you want them to be. We take feedback from you all the time to make sure that that we're on the right track, right? And the application and tools are meeting your expectations. But the truth of the matter is the feedback that you give to us helps us satisfy demand all around the country and all around the world. Imagine writing a tool that you know will be used by thousands, if not millions, around the entire globe. And so that sort of impact is what your feedback helps us do. And also that level of impact is what we're trying to make as perfect as possible, so that developers don't tolerate writing applications against SQL. Developers love writing applications against SQL. So I hope you hear this story all the way across. We're adding features inside the SQL engine, things we know developers want to do. We're adding tools and we're adding capabilities. We're interacting with the entire ecosystem to make sure that the story of SQL across the entire Microsoft ecosystem makes sense, but also that we meet you wherever you happen to be, because you may prefer, let me give you an example. You may prefer to write in C#, but the company you work with or the team that you're on right now demands that it be in a different language. We want to make sure you still have the option to be able to use the world's fastest, the world's best, and the world's most productive SQL or database that there is, right? That's what we want you to be able to have at your fingertips all the time. So we also want to make it so that the on-ramp for developers who are new to databases, it's crazy. If I were to say, what do you think the top 5 languages are, or what are the first 3 languages a developer should learn? SQL should be in that list. Part of the reason SQL needs to be in that list is not because you'll ever write a query against the database. It's so that you can understand queries against databases, right? We have to be able to turn the lights on so that we can see and understand. We have the same experience right now when we're interacting and using some sort of Copilot or AI to help us in our coding experience. They are terrific at being able to produce really some good code, but also at producing bugs. We still need to have the foundation and fundamentals inside our head so that we understand how to turn the lights on and look through the code and understand what's going on. The same thing is true when we're interacting with our database. You may be using a tool like Data API Builder, where you're able to really offload a lot of the SQL writing, but that doesn't mean that you can't not know the language. So when I see features inside our tooling, like what Carlos is showing, things that allow us to build out a table with all of its capabilities, and you can have a table with a column name description that has description. The text in it says this is the description. I mean, is that not valuable? I'm saying that jokingly, but the truth is, being able to add all of those pieces together is kind of a trick. You need to understand the language. If you don't understand it, isn't it cool that we give you this like I don't know, baby step way of holding your hand into being able to use all of the core capabilities of SQL, and not say, there's a gatekeeper here that says you either know it all or you don't know anything. And so we want to be able to make it so that everything is at your disposal. All right, so what are we talking about next? Now we're going into logging, and now we're going into using Data API Builder inside a real application. Tom's going to be here to walk us through it. He has been an incredible asset to the community around Data API Builder already. He's a terrific person. I mean, honestly, he is. And so you'll enjoy this as much as I'm sure that he enjoyed putting it together, and it is spectacular. So hold on to your horses here. Grab your seats. Is that the right thing to say? Hold your horses? No, it just means like buckle down and get ready, because we're going to go through the next session of unlocking database conversations using the semantic kernel and Data API Builder in action. Take it away, Tom.
Hello, everyone, and welcome to this session. I'm Tommaso, and I'm going to talk about unlocking database conversation using semantic kernel and Data API Builder. First of all, what do we mean when we talk about database conversation? I'm talking about a scenario in which we chat with our database. You might be familiar with scenarios in which you chat with your data. So basically, use case for the LLM when you simply upload certain documents such as PDFs to a certain location, and then you have the LLM answer to user questions based upon only the knowledge contained inside those documents. So this is called retrieval augmented generation, because the LLM will have to retrieve information from the documents, from the knowledge base, and then use that knowledge to augment the way it generates the response for the user. That's why it's called retrieval augmented generation. I would like to implement something similar to that, but using the database as a data source for our information. So in this scenario, since we have a database, we need to be able to perform queries against the database using the LLM. And of course, why would you let the AI run queries against your database? Because it's a very tricky scenario, because the LLM doesn't know anything about your SQL database structure, which entities it contains or whatever. And you remember, you start from a simple question coming from the user, the end user, which might be something like retrieve offerings details from a SQL database. And even if we type something like write a SQL query to retrieve offering details from a SQL database, the LLM will go ahead and straight up invent or randomly guess the way the database is structured. So you might end up adding something like what you see here on the slide. Here was talking with ChatGPT, and it randomly generated a query, which of course was nowhere near the actual data, the actual field I've got in my database. And you might say, yeah, okay, no problem. I can simply go ahead and add the database structure to the system prompt of my agent, so that the LLM will actually know how the database is structured. And that's fine. Yeah, you're right. That might actually work. In this scenario, you can see that the LLM generated a query which is actually correct. It's even using the an inner join to go ahead and retrieve the details from the offering table, which contain the offering details table, which contains some details about a certain offer I made up in my database. So we are working with two different tables here. We've got the offerings, which contains the location, the period of validity of a certain offers, and it contains a foreign key for the details of that offerings. I'm figuring out I'm sort of a travel agency right now, okay? But that's not the point. But yeah, this works until you update your database. So every time you update your database and you add some entities to your database, you will have to go back to the system prompt of your agent and update that to actually use the new entities you have added to your database. That's not very good from a maintainability perspective, and you might end up having to do lots and lots of work every time you update your database, changing like relationships or tables or fields, whatever. So that's not the final way to go from my point of view. And it would be nice at this point if we had the possibility to actually expose our database as a REST API or as a modern API, to better state that. And by modern API, I mean both REST API and GraphQL API. So REST API, you're very, very familiar with that. Of course, REST API, you've got all the known behavior you might expect from an API. You have GET request, POST request, PUT, delete, whatever. GraphQL endpoint instead is actually a different way to perform queries using an API. So the QL stands for query language, and you're able to interrogate your API sending a query as a payload so that the API will actually perform the correct integration, will select the correct data from the source to actually return to you as a JSON. And this is what we want to use in this scenario, because the LLM can very, very easily write GraphQL request and retrieve the correct data, even performing join with our two different tables that we are handling right now. And the LLM can actually use an API, either a REST or a GraphQL, as we're going to see, has a plugin to actually a tool that can actually invoke to perform some action. So this is the correct way to go, but of course we still need something that will turn the database into this modern API we are talking about, and that's Data API Builder. Data API Builder is an open source project that actually takes this specific goal in mind, which is to turn the database into the modern API using either both GraphQL and REST API. It's very, very simple the way it works. Basically, you need to configure a JSON file that describes the database that you want to turn into an API. So you can use the CLI to do that, or you can write a JSON on your own, but you can simply have to describe all the entities inside the database and set the permissions for that entity. And then you go ahead, if you use the CLI, you will type .start on your terminal, and you will have a localhost 5000 that actually runs the server with Data API Builder inside. This is great because this is the first step we need for our database conversation scenario, okay? And these are all the supported database type that we have in DAP right now. So we've got SQL Server, Azure SQL, Cosmos DB for NoSQL, Postgres, and all the database listed here. From a perspective of security, of course, we can define tables, views, store procedures that we want to amplify, and then we can secure all the action that can be done or not done by certain roles. So we can instruct the API to understand, we can instruct Data API Builder to understand all the available roles, like reader, user, admin, whatever you might come up with as a name. And then for each role, you can define if you want them to be able to only run create, or read, or update, or delete, or execute. So you can be very, very specific about the way you want to implement security on your Data API, on your database APIs, basically. And you can also implement row level security so that you make sure that certain rows are not accessible to anyone. a few words about .NET Aspire. I need to add that inside this demo because when we work with Data API Builder locally, we don't only need Data API Builder, we also need a database, of course. So usually you might have your database running somewhere in the cloud or on a server, on-prem, whatever. But when you are developing your application, most of the times you might have your database running locally, such as a Docker container image maybe. So to do that, we can use .NET Aspire. .NET Aspire is a set of tools, packages, and resources that you can use to build the locally distributed application. So by distributed application, I mean application components of different components, such as, once again, the database or a Redis cache or the Data API Builder, by the way. And on top of .NET Aspire, you also have .NET Aspire integrations, which are pre-configured NuGet packages that you can use to simply add to your .NET Aspire project all the available resources that you might want to use inside your application. Everything starts from a simple .NET project called the app host, in which you have a program.cs where you build your distributed application. And then when you run everything, you will have a developer dashboard, which is very, very cool because in the developer dashboard, you can take a look at all the running resources inside your distributed application. You can take a look at the logs for each of that resource. And you also have metrics and traces. So let's take a step back. We are in a scenario in which we want the LLM to be able to perform queries on our database to retrieve some data and then generate an answer to a question based upon those data. And of course, monitoring is everything in this scenario because we might end up in a situation where the LLM go wrong and do something that we don't really figure out while we still building up our system prompt to make sure that everything works fine. And to figure everything out gets very, very difficult in a distributed scenario. So having an open telemetry endpoint with metrics and traces is fundamental for our success. So this is why I'm going to use not exactly the Data API Builder container resource I would be using normally, because by the way, in .NET Aspire, you have a very, very neat integration for Data API Builder in which you simply type add Data API Builder, you pass in the name of the resource, the path to the .config.json, and it will spin up a container with Data API Builder running on it. But I'm not going to be using that. I'm going to be use the executable Data API Builder because locally on my machine, I've got the release candidate of Data API Builder, which already implements OpenTelemetry. And this is why you see that here I'm using the add executable command of .NET Aspire. I'm passing deb as the name of the resource, deb as the name of the CLI tool I want to use, the working folder in which there is the .config file, and the command I want to run with the CLI, which is start. So when this execute, it will run .start on a certain folder in which there is already the config.json file that will run my Data API Builder instance. And this is the program.cs of .NET Aspire. I am creating here the database, so the SQL Server and the SQL database itself, which I'm calling agency. And I am setting the persistency of that container so that every time I stop my application and restart, I don't have to recreate the database from scratch, seeding all the data. It's already there for me every time I rerun my application. Here I'm seeding the database, and of course here I am initiating the Data API Builder resource. So the Data API Builder is taking a few references, and this is .NET Aspire at its most. The same way you would have with a Docker Compose, you can set some references to a certain resources, saying like, I want the Data API Builder resource to be able to reference the SQL database resource. And the end result will be that Aspire will inject an environment variable inside Data API Builder containing the connection string of the database. Then I'm setting the HTTP endpoint, and I am waiting for the SQL Server. I am waiting for the SQL Server because every time dub starts, it will first thing it will do, it will go against the database and check if the entities described in the .config.json are actually there. So this is why I need to wait for the SQL Server to be up and running every time. And of course, I am adding the OTLP exporter through an API here, because this will cause .NET Aspire to inject all the correct environment variables to use OpenTelemetry inside Data API Builder. So it will inject the endpoint, the headers containing the API keys, the protocol I need to use, which is going to be gRPC, and the name of the resource to be shown in the dashboard, which will be the same name as the resource itself. So it will be dub. And of course, I need to use that inside my dub.config JSON. So let's take a look at that. This may be the first time you take a look at a dub.config JSON or not, but you may find something new anyway. So you got the data source in here, which describes the actual database that Data API Builder is using to run in this scenario. And the connection string, as I mentioned, is a connection string, is an environment variable injected by .NET Aspire. And this is the convention .NET Aspire uses. So connection string __ name of the SQL database, which I remind you was agency. And then you got the runtime definition in which you enable the REST or the GraphQL endpoint, or both of them. And you define some host configuration, and we've got the telemetry part. So telemetry is not new to .NET, to Data API Builder. We already had telemetry for application insights. Now we also have telemetry for OpenTelemetry. So you can enable both of them. In this case, in this scenario, I have only enabled OpenTelemetry. So enable true, and for the endpoint, I'm using the environment variable coming from .NET Aspire. Same goes for the headers, the protocol, and the service name. So every time I spin everything up, .NET Aspire will create an OpenTelemetry endpoint with a certain API key, and it will inject the correct configuration that I need to use in my running instance of Data API Builder. So very scalable. And you also have the entities defined in here. So this is where Data API Builder gets actually configured from the database perspective. You've got the name of the entity, which is offerings in this case, and you simply identify the source. So in the database, this is going to be dbo.offerings, and it's of type table. And you can enable GraphQL and REST API for each entity. So even if you enabled REST API and GraphQL API for the entire dub resource, you might want to exclude a certain table from a certain API type. So in this case, I have left both of them enabled, and you have the permission here. In this case, I'm using role anonymous because I'm not going to perform a request against the Data API Builder by myself. I will let the LLM do that. Of course, I could implement some sort of authentication between the agent running in a .NET Minimal API instance and Data API Builder, but for simplicity and to have like a cleaner code on the agent side, I let run it by in anonymous. And then you set up the relationship. So setting everything up from the JSON perspective can be difficult sometimes. As you can see here, you got lots of things to type. But if you take a look at the CLI bash file I wrote here, this is, by the way, what I used to actually build that the dub.config JSON. It's very straightforward. So you simply dub init to the database, you dub add some entity, and you dub update the relationship between the entities. The only thing I had to add manually is the telemetry thing. So I didn't use the CLI to do that because I wanted to show you only right here. But you can, once again, always use the CLI to configure your dub.config JSON from every point of view. So once we had that and we run everything, we end up in a situation like this. We will take a look at the front end and the API later on in another demo. But right now we want to be focused on the dub executable resource, which of course, if we take a look at here in the details, we can see all the different environment variable injected. So the connection string agency coming from the SQL Server and SQL database we've got here. We've got the OpenTelemetry endpoint, the headers with a key, and everything that we need to actually run Data API Builder in our scenario. We can go ahead and take a look at the logs for this instance. And we can, of course, navigate to the endpoint, which is localhost random port assigned. And we can either go in the Swagger endpoint, and of course, we can also hit the correct endpoint, which is /API/name of the offerings, but having Swagger is better here. So you can take the offerings, try it out, and execute the query, and you've got all your data back. You can also use filters using OData expression when you perform this query. So you can filter out your data using REST API. Pretty cool, super useful. But we're going to be focused on GraphQL here. So in the GraphQL endpoint, so localhost random port /GraphQL, we've got the way we can build. We can see the way we can build a GraphQL request for our endpoint. So in this case, I'm running a query. So I'm querying data, I'm getting the offerings, all the items inside the offerings entity, and I'm only retrieving location valid from and valid to, and I am also retrieving the description, which can be found inside the offering details entity. And if you're not very familiar with how you can construct a query for GraphQL, you can use the query builder on the left here that will actually help you like adding or removing field from your query. And this is for testing purposes only. This is not what you will have exposed to the final user, but you can always come here and test if everything is working correctly. You can run your query and see that everything is doing as expected. So this is fine because we've got our first objective achieved thanks to Data API Builder. So basically we got our database and it is exposed as a modern API, REST endpoint, GraphQL endpoint. Lovely. Then we need to take the next step, which is add some LLM to our scenario. And to do that, I'm going to use Semantic Kernel. So Semantic Kernel is an orchestrator, is open source. So it's an orchestrator for the for agents and for the AI workflows. So using Semantic Kernel, you can create an agent, which is basically a system prompt and some plugins combined into a single entity that can use an LLM in the background to perform some action. And it supports both OpenAI and Azure OpenAI, and of course also Oyama and Hugging Face. And third, but not least, it's also available in C#, Python, and Java. This is very important because when you build an agent or an AI workflow, most of the times you might end up having to cooperate with your data scientist friends, and they of course prefer to write code in Python. And if you can work on Semantic Kernel, them in Python, you in .NET, it will be easier to cooperate from a code perspective, taking their work and bringing it inside your .NET application. Okay, so this is a very important feature from my point of view. So we're using Semantic Kernel, we are building an agent, and we are giving it a plugin, which is going to be Data API Builder. So Data API Builder will become a plugin for our agent. Let's see how that's actually implemented inside our code. This is the .NET Minimal API, a single endpoint, a post endpoint, API chat stream, and it handles the chat history with the LLM, and it handles their incoming requests using streaming. Nothing special here, but the actual agents, it's what I want you to focus on. So in here, I am creating a Semantic Kernel agent. I am giving it some instruction taken from a TXT file, and I am setting the prompt execution settings, like the tool call behavior. I want Semantic Kernel to be able to automatically invoke all the plugins that the LLMs will tell him to. So the way it works, the Semantic Kernel agent will ask the LLM, will send the LLM a payload saying, this is the answer, the question of the user, this is my system prompt, and these are my tools available. What do I need to do? And the LLM will go ahead and say, here's the tool you need to run to answer that question. And Semantic Kernel can actually auto-execute locally that tool, which is going to be, of course, an HTTP request towards Data API Builder in our scenario. And I am importing the plugin for Data API Builder using OpenAPI. So I'm importing the plugin from OpenAPI, but here's a slight twist because I'm not really using the REST API of Data API Builder. I'm using the GraphQL endpoint. I can only import plugin from OpenAPI in Semantic Kernel. So I'm doing something strange here. I am creating a fake OpenAPI descriptor for the GraphQL endpoint. So I'm using a placeholder for the server. I'm saying that there's a path called GraphQL that accepts post request, and it's a GraphQL endpoint. And in the instruction of the agent, I'm saying, okay, to access the data, you must use that post tool. And the post tool is a GraphQL endpoint. Do not guess any type of schema, relations, or data types, whatever. You always use introspection to understand the whole schema. This is cool about GraphQL because you can always ask a GraphQL endpoint to expose its own schema so that you can figure out what's inside, what you can do and what you can't do with all the entities it contains. And in this case, I'm letting the LLM do that so that the LLM all the time can actually figure out what's the schema of the GraphQL endpoint. And this serves our purpose because if I update the database, I only have to update the .config JSON. GraphQL will auto-reload with the new .config JSON on the server side, and the LLM all the time will have the updated schema of GraphQL and will always be up to date with the new updates made on the database. So I don't have to change the system prompt, never, once I wrote it for the first time. And once I do that, of course, I can simply invoke the streaming async chat with the agent to get the answer from the LLM. But let's see that in action because it's way better. So I've got my front end. I can go ahead and navigate to the front end. Let me take my, okay. This is a predefined prompt, like, are there any offers for London? Let's set the streaming chat and send the request. And now we can take a look from the trace perspective of what's happening here. So the API is getting the request from my front end with the question of the user, which is, are there any offerings for London? And it's sending it to the LLM. And this is what the LLM gets. So the role, the content, and the question of the user. And the LLM will go ahead and say, okay, to do that, you need to invoke you need to call a certain tool, which is called .post. And you need to run this query. This is the query that you can use to actually use introspection against a GraphQL endpoint. So first thing you want to do, call GraphQL endpoint using introspection. And then my local API will go ahead and call Data API Builder in the GraphQL endpoint, performing the introspection. Getting the schema, we'll get back to the LLM, and let's visualize that. It will send in the actual schema retrieved from the GraphQL endpoint, and the LLM will say, okay, based upon that, this is the query you need to run to retrieve all the offerings with the related details using that GraphQL endpoint. And of course, my API will go ahead and call Data API Builder to do that. And once again, I am not doing the call manually, but it's Semantic Kernel. Semantic Kernel is the agent that is performing the query against Data API Builder because I've set the tool call behavior as auto invoke. And last but not least, once again, my API will get back to the LLM, passing in the data retrieved from the GraphQL endpoint, and the LLM will generate the answer, the pretty answer to show to the user, which is this one. So if you go back to the front end, we can see that I found 2 offerings for London. This is the first, this is the second. Feel free to ask more questions. So this is super nice because first of all, we've got a solid scenario in which we can talk with our database and we can take a look and see what's happening behind under the hood. So if something gets wrong, we can always come back here and take a look at what's happening. Like if I get a wrong call against Data API Builder, I can always go ahead and say, okay, what did the LLM tell Semantic Kernel it should run as a query? So I can go ahead and debug that and maybe adjust my prompt like I did many times while I built this demo. And of course, you always have the metrics that you can go ahead, take a look at the metrics. You can see that you've got certain request duration, so you can see how long it took for Data API Builder to answer back because you have open telemetry. And this is a great way to debug such a scenario in your local machine. So that's all. So thank you for your time. I am leaving you some resources, starting from Data API Builder, .NET Aspire, and Semantic Kernel. So the three main tools we've seen today. So you can deep dive into the documentation for each one of those. I'm also leaving you a blog post I wrote about this explicit scenario on Dev2. And I also, of course, sending you the GitHub repository for my code. So you can go ahead, take a look around, and see how things were implemented if you need to take a double look at that. Before I leave you, let me remind you that we've got a new learning path, which is called Develop Data-Driven Application by using Microsoft Azure SQL Database. So please go ahead and take a look at that. Very, very interesting. That being said, thank you so much for your time. Hope you like it, and see you in the next one.
Thank you, Tom. So thank you for this presentation. That was Data API Builder, but more importantly, it was the semantic kernel, being able to use AI to help look at your data and formulate the GraphQL query that you would be executing against your endpoint so that you can get different pieces of data. Very creative use of AI, no doubt about it. All right, so where are we? Well, right now, let's pull up the agenda. We're currently just past Tommaso's, and so now we're at SQL Projects for Everyone VS Code. And I would bet if you know anything about SQL projects, you have already seen Drew presenting on it. He loves to evangelize and make sure the developer community is not only aware that it exists, but aware how to use it the easiest, right? How to really take advantage of some of the innovations that the team has been able to add to it. Again, it's just another piece of the overall story. It features inside SQL, the new SKUs of SQL, the new advances in all of the tooling, adding things like Data API Builder, and now adding nothing new, but certainly adding the SQL database project to be able to answer these common problems of how do I manage all of my drift in my schema? How do I manage all of the refactoring that's needed inside my database without developing my database directly against the database itself? I want to be able to do it instead the way I do C# and the way I do Python. I want it in files. I want it inside my source control. I want to have a pull request to make sure any sort of schema introduction or change goes through a process that I have, and more importantly, that I can automate the delivery and the verification of those schema changes inside the CI/CD pipeline that I already have configured. All I need to do is adapt it to it. So if you're doing that today, congratulations. However, if you're one of those developers on a team and every time you need to add a column or add a table or add an index, you find yourself logging into the database to make those changes, you're going to really enjoy this presentation. All right, so just a reminder that we have the comments are wide open if you have questions, and we can hand those off and I can make sure that all of your questions are going to get answered as well. Terrific, right? Terrific. All right, let's not wait any longer. We have Drew's presentation just queued up and ready to go. You're going to really enjoy it. You're listening to KSQL. It's Microsoft's All Data Radio. All right.
Welcome to SQL Projects for Everyone in VS Code. I'm Drew Skwiers-Koballa, and this is SQL Conference 2025. In this session, we're going to focus on getting to know SQL database projects in VS Code. So SQL database projects are this human-readable format for a database definition. And while they provide a bunch of local development environment capabilities, their true advantage starts to shine through when you start integrating with CI/CD. However, you definitely need that base of understanding how to edit and develop with them locally, so that's why we're going to focus on VS Code for the next 30 minutes. We're going to use a series of demos. We're going to spend a lot of time in VS Code to see how to use SQL projects in different ways so that you can fit SQL projects with your development process as well as your level of database experience. I am the product manager for SQL projects and the SQL package CLI and DAC effects .NET library for SQL DevOps. You can find me on LinkedIn and GitHub, but I spend a lot of time focusing on different ways that developers can create, modify, and iterate on their database objects. As I mentioned, we're going to spend a bunch of time in VS Code today. I am going to do a brief introduction on what SQL projects are, as well as we wrap up, touch on what is not quite yet in VS Code as far as SQL projects capabilities. When you think about SQL projects, you might already have a familiarity with them, you might already have some misconceptions, and that's completely okay because they're actually a pretty big beast of a bunch of different capabilities. But if we step back and think about why we might want to use SQL projects, that helps us understand them a little bit better. The first part about SQL projects that you might be considering is whether or not you're trying to track your database in source control. So how do you know what the state of your database is? How can you tell if someone changed something and when it was changed? Having your database in source control is oftentimes kind of this minimum bar where people are like, this is where SQL projects become really useful. Another place where SQL projects fit really nicely is when you're trying to quickly create development and test instances. SQL projects are really strong for creating development environments where you just need a copy of the objects themselves. You're not looking to do full database restores, or if you are doing a restore, you also need to apply certain changes based on that set of data. And so this is where SQL projects do a really nice job of allowing us to deploy databases or deploy changes really quickly. Speaking of database deployments with SQL projects, the tooling around SQL projects, there's a couple different ways where you kind of have this button. It's like a big red easy button for publishing or deploying changes. This is nice, but it does have some pitfalls because you want to understand the changes that are being applied. And so this is another big advantage of SQL projects where while you can hit a publish button or have an automated publish pipeline, you can also generate the change scripts themselves so you can review them. There's kind of a bunch of different ways to use SQL projects and turn them upside down and let them fit your workflow. This does also include if you're using an ORM like EF Core. Sometimes people kind of understand that their ORM is helping them out by doing the early database object definitions, as well as already has facilities to apply database migrations. You can layer SQL projects on top of that, so you can get a better understanding of what the database object definitions are as more of a declarative thing that you can review in source control, as well as if you are generating database change scripts, these are something that DBAs and other people responsible for how the database functions over time can be a little bit more comfortable with applying. If we step further into what's happening with the SQL project, I have this kind of prototypical example that steps us through the different life cycle stages. The SQL project itself, like I mentioned, is the definition for a SQL database. You have a bunch of different scripts that define an object each. So a SQL project may be really large. There could be thousands, tens of thousands of files that each define an object in the database. The SQL project example that we're using at the moment has a customer table in it amongst all of the other objects. And so that customer.sql file has the create table statement stored in it. As you are developing and working on these files, you would do a build. Now, as a .NET build, you don't need to be doing .NET development for the rest of your development. You don't even need to be an application developer to use SQL projects, but the library that we build them on top of is a .NET library, so you have to have the .NET SDK. That's all well and good because it gives you a lot of functionality. Because we're running a build process, it is taking a look at all of the objects in that SQL project, validating the T-SQL syntax is correct, and validating that the object references to each other are correct. So if I have a foreign key, I can't just reference something that doesn't exist. The build is going to throw an error and fail, so I understand that I'm trying to put something together that really is not going to work. So this is kind of helping put guardrails on our development. When the build succeeds, we get a build artifact, a DACPAC, D-A-C-P-A-C, DACPAC. The DACPAC model file It's really just a zip file with a bunch of XML in it, but it is the database definition. So it has taken all of these different references and what columns belong to which tables and which stored procedures reference different things and put them all together in this artifact that the rest of the tooling can understand. This is particularly important because around SQL projects, while we're going to focus on VS Code today, there is a bunch of different tooling, including the SQL package CLI. This is definitely one that we rely on quite a bit because it allows us to take our processes into CI/CD environments. Whenever you're doing a publish from VS Code or within SQL package, that deploy process, that publish command, is going to take a look at the DAC pack and the database definition in there, as well as the database and what its definition is, and figure out what the difference is. This is kind of your schema compare. This is running behind the scenes to figure out what is the difference. Then SQL package puts together a deployment plan of what steps need to happen to make this look like this. In the case of our example that we have going on right now, the DAC pack contains a customer table with 3 columns in it: first name, last name, and region. We didn't know this, but evidently the customer table already exists on the database and the first name and last name columns already are there. So the region column is really what is new. We had no idea. We were not keeping track of this. We don't know all of our different environments. I personally do not have every database memorized. However, that's okay. That's what the tooling is here to help us with. So when SQL package figure out the deployment plan, it was, oh, I need to have a step where the table is altered and the column is added, and it generates the T-SQL syntax to make that happen. Depending on what you're running, whether it's a publish where it immediately applies this, or if you're generating that deployment script where it's going to give you this command to run in your own time, then you're going to get that output. But this is the process. This is the development process that gets created around SQL projects. Now, I like this graphic because it summarizes kind of the prototypical development process, but I don't love this graphic because the arrows are all headed in one direction. They're headed to the right, where you build your SQL project and publish it to a database. If you're hanging with me for the rest of the 30 minutes, you're going to see that this is not the only direction that we can take our changes. The tooling around SQL projects allows us to take a database definition back into a DAC pack or back into a SQL project even. So again, even if you're using an ORM or you're doing your development against a live database and then you want to work with a SQL project, that's totally fine. Those processes will all work with SQL projects. So before we go any further, let's start diving right into VS Code and getting our development environment set up. Starting from VS Code and making sure we've got it set up all right, we can double check our extensions. If you've installed the SQL extension, this is the one that brings you the Object Explorer and the ability to run queries. It brings by default as well the SQL Database Projects extension. The SQL Database Projects extension gives you the project view, which is really helpful for all of its extra functionality around SQL projects. From the command line, we can set up a few more things. So we'll need the SQL projects templates if we want to have an easier time creating new projects, but this is not a requirement. So I'll do a .NET new install Microsoft build SQL templates. This means I can create a new SQL project as well as new code analysis rules a little bit more easily. I definitely want to install SQL package, so I'll do the .NET tool install for Microsoft.SQL package. This is a really easy way to install SQL package cross-platform, and it'll be the same everywhere, and then it's immediately available on your path at SQL package. I already have a container deployed locally with the database that we're going to start our development from. So even though I don't have any database projects yet, I can create one really quickly from an existing database by using that menu option, selecting the existing connection, and I'm going to call this the Core AdventureWorks project. These objects we're going to assume are created by another team or maybe a third-party vendor, and we're developing on top of them and beyond them. We're not working in a bubble here. So we've created this as our Core AdventureWorks project, and we can manage those objects from that specific project. And from the database projects vein, we've got a nice context menu that gives us the ability to build and publish quickly. So if I select build, unsurprisingly, our T-SQL syntax and all the references will be valid and our build succeeds. So as we look at doing more forward development, we can develop objects in addition to the ones that were provided in the core of AdventureWorks by adding another project that we'll call Shipping AdventureWorks. Today, as we work through our example, we're representing a team of developers that are creating functionality for the warehouse or shipping group at AdventureWorks, especially around adding images for products so we make sure we're picking the right things off the shelf. Let's go ahead and create our Shipping AdventureWorks secondary SQL project. We'll do this with the .NET New templates from the command line. So if we do .NET New SQL Project -N for the name Shipping AdventureWorks, this is creating a blank SQL project, unlike the first time we created a SQL project where it added all those objects from the sales LT and DBO schemas. Now we have that empty SQL project with no SQL files in our folder. Now, the one thing we haven't set is the target platform. When we created core AdventureWorks, it was from a database, so it came in by default as SQL 2022. The target platform is an important setting for the SQL project because it allows us to define what set of T-SQL syntax is valid to be used. This also opens up SQL projects as a nice way to test what different platforms your SQL development is compatible with. So if you're curious if your database is compatible with Azure SQL Database, you can use that SQL project, change the target platform, and try out your build, and it'll let you know if you used any syntax that wasn't compatible. Now, both projects defaulted to SQL 2022, so we're ready to keep developing since that's my local container environment. We could add new items to Shipping AdventureWorks through the context menu here that has all those templates. But I'm going to hop back over to the File Explorer because I can do things there as well. Same in either direction. I'm going to start creating my utils schema. This is where I'm going to keep some store procedures that I use as helpful from time to time, and I'll create my utils schema file. So I've started adding objects to Shipping AdventureWorks, but I don't need to copy everything from the core AdventureWorks project into Shipping AdventureWorks. I can make these two projects related to each other. So all of these sales LT and DBO objects can become part of Shipping AdventureWorks through a concept of database references. Now, the Shipping AdventureWorks project can become related through database references seen there in the database projects pane. So if I add a database reference, I can select from the different kinds of database references, project, DAC and a package or a new package. We'll start with project. So we're just going to reference directly to the core AdventureWorks project, and we're going to do same database. We're not going to do different database. We're not going to do different server. We're going to start with the same database because we want it to become all part of the same database when we eventually go to publish it. So stepping out of VS Code for just a second. So we can have project relationships either to other projects, to a DAC pack, so that compiled artifact, as well as to a package reference or a packed up DAC pack. We set up the SQL project database reference, and we can try out the other types as well, but there are different ways that we can relate our project to another one. If I start creating with multiple objects, I do need to be mindful of how this impacts the performance of my build. We're working with really small projects here, and the core AdventureWorks builds and then Shipping AdventureWorks builds because I have the database reference to that project. So the combined time there is 1.8 seconds and 1.2 seconds. Let's go back a little bit and we'll comment out our project reference. So we no longer have the relationship to those objects. We do still want those objects, so we'll try a different database reference type. Instead of doing a project reference, let's take a look. We've got the DAC pack from the core AdventureWorks build. If this is being developed more slowly, we don't need to be building it as often. It's not going to change unless those objects are changed. Let's add a database reference to the DAC pack itself. It's still the same database reference. We're not looking to have three-part naming or anything. And we'll locate that DAC pack in Core AdventureWorks bin and debug. We are going to let the errors come through if we have unresolved references. We like those guardrails. And now we have the artifact reference to the DAC pack. We're now responsible for copying the DAC pack around to all of our build environments, so that includes into source control. But the benefit can be significant because the build time is now reduced based on not needing to build a core AdventureWorks project in addition to shipping AdventureWorks. For larger projects where your build time is 5 minutes, this is a bit of benefit to know about. Let's keep developing on our shipping database. I want to add a stored procedure in our util schema for getting the active connections. This is going to be a stored procedure that calls into a DMV, lists DM exec connections, and pulls some columns out of it so I can get that information. Turns out that DMV is actually not in the user database, it's in the master database. So when I run our build here, we're going to get some warnings that the reference that we're trying to find we can't resolve yet. That's too bad. We don't like getting warnings when we're building SQL projects. We want to make sure that we are truly referencing things correctly. So what about those package references? We've published all of the system databases to NuGet.org, so you can add package references to any of the system databases to really easily ensure that you can resolve relationships to columns and things like those system DMVs. Now in our shipping AdventureWorks, we can see that database reference for master, and if I run .NET build now, it's going to resolve both our DAC pack reference as well as the package reference to master, and our build succeeds without any warnings because all the columns in that stored procedure were able to be fully validated. Now creating a package of your own can be done by running .NET Pack. We've just run .NET Pack on the core AdventureWorks project to get a NuGet package. If I were to publish this to a package feed, I wouldn't need to be moving that DAC pack around for the artifact reference all the time, and this would really allow me that efficiency of not needing to copy it into all of our CI pipelines. That'll be a nice benefit for the future. Let's go ahead and publish our SQL project to a dev database just to make sure that we're headed in the right track and we've got everything correct with our SQL project references. So on the SQL projects extension, I can use that context menu and select the publish option here if I'm looking to do a kind of development level deployment. The existing SQL server, the container that I have, is the one that I'm going to use. And I will create a new database that I'll call dev-A, just for creating a totally new database at this point. I'm going to go ahead and do the publish because I am looking to create a fully new development environment. I'm not looking to examine the changes before I make them. I did save a publish profile in case I need to do it later. This would be how I would use more advanced publish settings if I need to access them. The publish kind of goes off real quick, and now I've got the container with the extra database dev-A that I made. We can see all of the objects from our core project were included in this publish, so they were part of the deployment because the include composite objects publish option was set to true by default in the SQL database projects extension. If I continue developing our shipping solution, I'm going to add a warehouse schema where I'll be able to keep some of our user tables. So if I create schema warehouse, that'll set us up, and then I can go ahead and add a table for the product photos. Now, one of the nice things about working in VS Code is that GitHub Copilot can help me out. So if I give it that comment, Copilot or whatever assistive AI you use is going to give you a hint on this is what it thinks you should have for your object definition. With the SQL project, it has the visibility to the different objects in your folder, so it can kind of increase its chances of being correct. But you are still responsible for writing good code. And when I run .NET build this time, I'm starting to get errors because I have an unresolved reference. The product table is not in the warehouse schema, it's in the sales LT schema, so I've got to correct that out. But once my build succeeds, I still have an error because I have some case differences in the column names. So as I start sorting all those out and taking my time as a developer to try to bring better quality to my development environment, I'm going to have to fight with the warnings a little bit to make sure I get them all. But this is part of your responsibility. As much as AI can help us, it's not going to be able to do everything for us just yet. However, there is another way that SQL projects can help us by turning on code analysis. Now, I've set this in the Shipping AdventureWorks SQL project, so it's only going to analyze the objects in there. So run irun.net build, it still succeeds. But if I start adding additional objects, like a stored procedure for add product image, where I will have the insert to the table done, and then I select identity to get that value back. When I run build, all of a sudden I'm getting warnings from code analysis. Now I have another case error that I can sort out, but I also have the misuse of identity. I really should be using scope identity here. And so if I clean this up, using the code analysis as a tool to ensure that I'm doing a little bit better development, I'll be able to get my build to succeed again without warnings. So working in VS Code, it's great that you got Copilot there to help you. It can definitely make creating objects faster, but at the same time, you also want to leverage things like code analysis to help you kind of clean up the development as it goes along before it gets shipped out to the database, and then you've got things to clean up down the road due to performance and other issues. Now we have a new table for our development project. And when we deploy this, we're going to sometimes want to have data inserted into this table just as kind of development sample data. We'll use a post-deployment script. So this isn't something that becomes part of the model proper, but it does get run with it, and it'll run every single time after a publish is done. So if I add an insert statement to this post-deployment script, this would run every single time I run publish. Now, I don't actually want to insert every publish. I only want to do it sometimes, and that's where SQL CMD variables come in handy. They allow us to decide or change things about the deployment at deployment time. They're variables that live inside the project and in the DAC pack. So if I add a dev setup SQL CMD variable, I can put an if statement in this post-deployment script that looks at the value of the variable. So the variable will get set when we run the deployment. And then if it is set to, we'll use true just to make it a little bit logical. If that is set to true, then the insert statement will be run. But if not, then it's not going to run the insert statement. SQL CMD variables can be used for object defaults and a few other things as well. So they're definitely helpful. If we have an AdventureWorks database here that has just the same as our core project, but it has data in the different tables, so we've got data existing in the product table, we want to go ahead and run our deployment of our warehouse schema with that new table, but we also want the sample data be inserted. Run that post-deployment script. Let's go ahead and do another publish. And the existence of the SQL CMD variable is going to be detected, and VS Code's going to ask us, do we want to set a value to that variable? We'll choose dev setup, and we'll set it to true for this specific publish. As our deployment runs, the deployment plan to add the additional objects is being determined. It's not going to try to recreate all the tables that already exist, but it will create the stored procedure and the warehouse product image table. Now the post-deployment script will also run because we set the SQL CMD variable to true. And with that, we will have values in the product image table that was just created, and we can see those rows there. So it's nice to see that our publish completed, as well as we were able to control the behavior of the publish, or what pieces of that post-deployment script ran because of that SQL CMD value. Earlier in this session, I mentioned that SQL projects don't always have to go in one direction. And so while we created a SQL project from a database through the UI earlier, we can also do this with the SQL package command line, and we can extract it to a folder. We'll call the folder SQL package extract. We do this by setting extract target to schema and object type, or basically any value other than DACPack. And all of a sudden now we have a SQL package extract folder with a bunch of SQL files in it. I can turn this into a SQL project using those same SQL project templates we used earlier. So if I do .NET new SQL project and I name it the same as the folder, it's going to create a SQL proj file in that folder, and all of a sudden I have another SQL project. So we can kind of use this to reverse engineer very quickly, and maybe even with like a shell script that we keep in our project. Now, we've noticed that since we extracted from a database that had references to master DACPack, we're getting warnings. And just for the sake of the example, I'm going to go ahead and really quickly remind you how easy it is to add a database reference. We'll even use a system database reference from this dialog, and we can specify that we want to do package references so we don't have to worry about copying DACPacks around. And then we will be able to build our newly automatically generated SQL project without any warnings, all from a few clicks. So whilst VS Code has a bunch of great functionality for developing with SQL projects, there are some pieces of functionality that are currently only available in Azure Data Studio but are in the works for VS Code. The first of which is the schema compare interface that you can get to from both the SQL projects extension as well as Object Explorer. What's special about Schema Compare, especially for database projects, is that you can compare into a SQL project. So I'm comparing from a database to a SQL project, and we're going to see some objects that are present in the database that aren't present in the project. And we could hit that apply button to go ahead and bring those changes into the project and keep the project up to date. This is another way that you can keep a project up to date as you're actively developing in a database. The other important interface that's present in the Azure Data Studio version of SQL projects is the table designer. So for some developers that like this visual interface that allows you to specify your table definition, this is also something that's just not quite yet available in VS Code for SQL projects development. We just took a whirlwind tour of VS Code for SQL projects, and I hope you got the sense that there's a lot of capabilities within VS Code as well as with that supplemental terminal for CLI capabilities that you basically can do just about any kind of SQL development you'd like, where you've got a definition of the database that you can keep in source control as well as then couple with CI/CD to better automate your deployment as well as keeping code quality up. There's another session involved in this conference on automation for your database development. But in addition to that, there is also a number of resources around SQL projects at aka.ms/SQL projects and samples that are associated with that. I'd also like to give a shout out to the Aspire SQL projects integration that is part of the community toolkit for Aspire. You can learn more about developing with SQL databases on the new Learning Path by Microsoft for Develop Data-Driven Applications. Go give that a try today and learn your new skill badge. Thank you so much for joining. Again, I'm Drew Skwiers-Koballa, and I hope you're able to give SQL projects out a try because they are for everyone.
Every single person, Drew. You're absolutely right. If you're not using SQL projects today, I would like to know why, because there is a real gap in the way that you can maintain your code, maintain your schema, and work as a team. It's also a terrific way to roll back in time to be able to deploy a schema the way that it was last June, to deploy a schema the way that it was when a bug was reported. And all of the features are right there in Mature. We have that capability in Visual Studio. We have that capability in Visual Studio Code. And, well, frankly, we have the same similar capability inside Visual Studio or inside the CLI. So a lot of things there that are just meant to make your life easier. All right, you are at the SQL Conf. That's here, 2025. It's our developer marathon. It's SQL-oriented sessions curated specifically for developers just like you. Thanks for being here. We have more on our agenda coming up, a lot of things that are really cool. But first, we stick with tooling. So maybe you are that developer that uses Visual Studio Code, or maybe even Azure Data Studio, and you're migrating to Visual Studio Code. God bless you. I mean, there's just so much good coming for you. At the same time, maybe you're an SSMS user. There is so much love going into SSMS right now. Erin is the PM, and it's just, there's something great, right? When you go to a conference and you hear somebody talking about tooling, or you go and you hear somebody talking about a feature, that can be neat, but it is nothing like when you are actually hearing the PM, the one who has put the sweat and tears into these different features, knowing that it'll help you as a developer, knowing that it'll make your life easier, and just hoping that you're able to find it, stumble on it, start to use it, and fall in love with it as well. That's who you've got with Erin. Erin is one of the PMs for SSMS, and she understands especially the new capabilities around Copilot that are coming into SSMS for us as well. Copilot is changing everything for procedural code, and when we write C# and Python and things like that, it's also changing everything around SQL development as well. That's because, listen, there's only so many of us in the world, far too few of us engineers, and we need to be more productive than we are because we're not growing on trees. And so to have tools like this that make it so that we have SQL projects that make it so we can be more effective and not introduce so many regressions as we make alterations and refactorings inside our database. But then we go the other side and we can have tooling that makes it so that we're even faster and more productive and more reliable in the way that we are producing the code at the same time. I hope you see the entire picture. I hope you see that it is features inside of SQL. I hope you see that it is advancements in tooling. And I hope, frankly, that you see that all the libraries and engines are all there for you, the engineer, to make it so that whatever it is you're doing, whatever language and framework you're in, whatever tool set that you want to work with, we're coming to you. We want to make sure that your SQL experience is not one that you can just manage, but one that you can be in love with, and we mean that. One of the things I want to share with you just for a second, though, is another piece of the developer puzzle that we are trying to improve. So right now, I just can tell you there's a lot of really, really good work going into Microsoft Learn. So MS Learn is where all of our docs are. I have the Data API Builder docs up now, but all of the thoroughness and the accuracy and the intent to make it so that you can discover all of the features that are sitting there waiting for you are inside MS Learn, learn.microsoft.com. You can start searching for these capabilities and start seeing all of the things that are happening. So when you feel like, wow, the SQL team is really giving us a lot of love in the tooling business and really meeting us where we need to be in the CLI. And wow, these features they're adding to SQL, and they're matching it with the effort that their documentation as well. We want to have the world-class documentation that everybody else is copying from us. And so that's where we think we are. That's where we're definitely heading. We realize that this is a big puzzle with a lot of pieces, and we're trying to address every single one of them as best as we can. All right, so now we have Erin coming along. Erin is really the one that is going to be able to show you how this is going to be transformational. It's a developer's guide to using Copilot in SSMS. Take it away, Erin.
Hey, welcome to a developer's guide to using Copilot in SSMS. My name is Erin Stellato. I'm a program manager at Microsoft, and specifically I'm the PM for both SSMS, one of the PMs for SSMS, as well as the PM for Copilot in SSMS. And I'm really excited to talk to you about Copilot today. And I want to level set with a couple thoughts that I keep in mind when I'm thinking about Copilot. The primary goal of Copilot in SSMS is to make your life simpler. How can we make you more efficient? Copilot's not going to replace you. It's not going to do your job. It is finding tiny bits of improvement throughout your day that in the end add up. Whether it's an hour a day, which becomes 5 hours a week, which becomes whatever you do the math, right? That is really what Copilot is about. So I'd love for you to kind of keep that premise, thought in mind as we go through this session. Now, we obviously are targeting specific folks with Copilot and SSMS, like database administrators. We want to help them troubleshoot, tune, do their database administration tasks, back up all of that faster, easier. And we also want to help developers, right? How do we help you write T-SQL, design objects, improve query performance through rewrites, understand what's going on with a query, why it might not be performing well. And then we also want to help the folks who maybe aren't senior DBAs or senior developers who fall more into that accidental DBA, involuntary DBA, developer, new to SQL. We want to help those folks as well. So Copilot is for anyone and everyone. We include everybody because we know that there are tons of folks who use SSMS, and I truly believe it can help you regardless of where you are in your journey. The great thing is that it knows nothing about you. It treats everybody the same, and it meets you exactly where you are based upon the questions that you ask of it. Now, there's a few principles that I want to talk about first. And if you've seen any session related to Copilots for Microsoft, you may find some of this information kind of familiar. So forgive me if that's the case. But one of the first principles for Copilot and SSMS, and one reason why I think that it's so good, like quite frankly, is that the responses are grounded in your connection. So we understand that you're connected to a particular flavor or version. A flavor is the word that I tend to use, or offering, right, for a SQL Server, whether that's Azure SQL Database, whether that's Azure Managed Instance, whether that's a particular release of SQL Server. Those are all database engines that we support. And the powerful thing here is that when you're connected, we understand what you're connected to, and we understand information about your database. So when I say that your responses are grounded in that database environment, that's really what I mean. We have this connection and database context that we leverage when you're submitting your prompts. And then it's really important to be clear that Copilot only has access to what you can do. It can only do what you can do. So if you ask it to write a statement to drop a database and you say, run this query, if you don't have permissions to drop the database, then Copilot can't drop the database for you. There's no way for it to circumvent the permissions that you have based upon your login, right? We're respecting those that have been assigned to you. And then the last thing that's really, really important, and this relates to privacy, and I cannot be clear enough in some ways about this, is that your data is your data, and we have no interest in retaining, using it in any way, shape, or form. So to be explicit, the prompts that you submit, the responses that get sent back, any metadata queries that we're running, again, to understand that context, we're not keeping any of that. We're not retaining it. We're not storing it. We are not using it to train or retrain an existing model or a new model. Your data is yours. I used to be a consultant. I don't want to see your data. I just want to help you. So I hope that is how you think of Copilot and SSMS. This will be very clearly documented. But again, we're not keeping that. We're not using that data in any way. The architecture for Copilot in SSMS is a RAG-based semantic kernel implementation. So what that means is RAG, if you're not familiar with that, response augmented. So we are running metadata queries behind the scene based upon whatever prompt you've submitted, and then taking that information and wrapping it around the prompt and sending that over to the model so that we can get a curated response, a response that's specific to the version of SQL you're connected to, your database, the objects in your database. So when we're talking about the grounded, right, meaning we're leveraging that connection and information about your database with this RAG-based implementation to give you a really good response within Copilot and SSMS. And then the architecture is a bring your own endpoint. And I'll talk a little bit more about that, but right now, as it stands, we support endpoints in Azure OpenAI. And right now, Copilot in SSMS is in a private preview, so please don't go looking for it in SSMS 21 or an earlier version of SSMS 20. It is only available through private preview. You have to be signed up for that. And again, right now, the architecture limits you to an endpoint that exists in Azure OpenAI. And then the cost for Copilot is going to be dependent upon the endpoint, the deployment that you have, the model that you choose, and then the volume of use. What types of questions are you asking? Not types of questions really, but kind of how big is that prompt and how much are you sending across? It's related to the tokens. Now, the endpoint model that I mentioned, Copilot in SSMS is going to be, or is being, tested and tuned against the GPT-4o model. The thing with Azure OpenAI is that you can select whatever model you want. The thing is that the responses may vary if you select something other than the GPT-4o, because that's the one that we're working against. We need something that's consistent, and therefore that's the model that we're going to recommend. Eventually, we would love to have, or we're planning, I look forward to when this happens, but we're planning to support small language models, or the ones that you might develop internally. So for air-gapped customers, air-gapped cloud customers, for those of you who don't feel comfortable connecting to a model out on the internet, ideally in the future here, I don't have a timeline as to when, we're going to support those small language or in-house models that you may have. And that's probably enough of slides, right? Let's go to a demo. So we're going to go ahead and start here within SSMS, and we're in SSMS 21 actually, and you'll see that the Copilot is a pane. If you're familiar with Object Explorer, Template Explorer, those are panes. They can be dragged around, even put on a separate monitor, which isn't going to happen here. And then you can pin and unpin that sidecar chat. So I'll often say the sidecar chat. And we're going to start with what I would think maybe is a regular kind of development task, which is I need to create a database. We're going to call ours General Hospital. Props to you if you get that reference. And we're saying I want to create this with a couple data files because my DBA said that was what I needed to do, and they needed to be pre-sized. So it gives me back this script, which is, okay, here you go. Here's your 2 data files and your log file. And we've set them, the pre-size to 100 megs, and it says review and adjust the file paths and sizes. So it's not just giving me the script, but it's also giving me some helpful information. And in this case, I'm like, oh, you know what? I actually need to put this database in the C databases General Hospital folder. So rather than update the script myself, I'm just going to ask Copilot to do it. This is that little bit of efficiency, right, that we're asking for here. Like, don't do the extra work. Ask Copilot to do that. Really quickly here, it gave me 3 data files. I said, no, I only want 2. So I went back and asked it to change that, and it did. Now I've created that database. And now what we're doing is I'm going to say, okay, we're designing this database for this hospital. They're similar to any hospital in that we have to track patient info, doctor info, appointments, diagnosis, test results. Suggest some tables for me. And it's going to browse a website and display information. Make sure my tables have a clustered index and a primary key. And it spits all of that out for me. So it lists every table that we have here that I asked for, patients, diagnoses, doctors, test results. And every single one of those has a clustered index on it. It also put foreign keys on there. I haven't zoomed in on that, but it gave me each of these as a separate script. And I'm like, I don't like that. Can you put all of those in one giant script? And so it's basically going to be like, sure, I'll do that for you. It's going to go grab all of those and put them into one script that I can then copy and paste. Now, I'm going to point out a couple things here. This is why you are still very important, right? Copilot is an assistant. It's here to help you. But it's making some guesses about your data and the data types, and you're going to definitely want to validate that. Maybe these are not all of the columns that you want. Maybe you want a few more. Maybe last name should be 100 instead of 50 for an NVAR car, right? People have longer last names. So this is really to get you started and saves you a ton of time from having to go figure out your create table statements. But in the end, it is your decision, right? What to keep, what to not keep, modify, etc. So I'm just doing a little bit of that here. And I'll also call out here that right now, this implementation is the sidecar chat where the script displays, and then I have to copy it over to the editor. Some of you are like, hey, that's not at all like what I've seen in GitHub Copilot. I get it. We are working on an inline editor. So multiple phases of development here. Phase 1, I'm sure you all are familiar with that, right, as developers. Phase 1 was, hey, let's get the sidecar working. Next phase is, okay, we're going to go ahead and make that inline editor available. Now I zoomed in here on master, and I want you to note that I'm changing the database connection to the general hospital database that I just created, because I want to create these tables in that general hospital database, not in master. Raise your hand if you've accidentally done that. Now that I've changed connection, Copilot actually does a reset there to note that the connection has changed. Remember, this context is important here. And so my next question is, how am I going to view these tables in my database? And it comes back with some information. It gives me a query that I can run to see these queries in my database. So we'll go ahead here and copy that. And again, this copy and paste, I understand it's a two-step process right now. This is something that we're going to make improvements to. But think about here what we're asking Copilot to do and how this is saving us time. So I have a query here that goes against systables and schemas so I can see the tables that were created. Now I want to generate some data because I want to write some queries, and it's nice to have some data returned. I'm going to ask it for sample data. Variability is more important than a short script. Give me a combination of 100 first names, 100 last names, use birth dates. Right? I'm basically asking it to give me sample data for the patient's table. You will find that the more descriptive you are here, the better output or maybe the better variability that you will get in data. I specifically said first names and last names. There have been times when I've asked for that and it's just generating a random string. Feel free to be specific. Feel free to refine your prompt. But this went ahead and gave me 1,000 rows in here, and I inserted those. It wasn't set-based. It wasn't the most efficient thing ever. So I could have asked it to do a set-based insert. But now if I query against patients, you can see that I've got 1,000 rows in here. And some of these things are exactly the same, right? The address is the same, the phone number. But for the purposes of our initial development testing, that's okay. Sometimes I just want to make sure I'm getting back data, right? Now, I'm going to go ahead and do this for the rest of the tables. I'm not going to show you all of that because I don't have a ton of time. But trust me, I went and created a bunch of scripts, or asked it to create a bunch of scripts that would fill in all of this data. So the last one that I ran was for the appointments table. So in that black screen there, I completely obviously paused the video, pushed all of that data in. And so now we're going to pick up and we're going to take a look to see a little bit of that data just to validate to you that I have that in place. So I'm going to just say, give me a query to view the top 100 rows for the tables in this database. I'm not going to, I could write that. I can write select top 100 from table. But again, typing that in there and asking it to do that for me, that's not the way that I would have written it, by the way, but that's fine. In this example, it gives me what I need. I can run my select top 100 from all of these tables, and there we go. You can see that I've populated the data in there. Also, oh, real quick before I forget, I'm exporting this. So we have this ability, which I actually love, to export the conversation out to a markdown file. So we're calling it, what am I calling it? General hospital data or something like that. And it's just a markdown file that you can then basically have as your history of what you did. So you can go back and reuse that as needed. So what I want to do now is I'm going to increase the size of these tables, right? It's great to have data in there. Sometimes you want to have more than just 100 rows or 1,000 rows. We actually want to increase the size of those by, an order of 10. So I'm asking it for the script to basically duplicate the data within here. And then I'm doing something a little different here where I've said, run that script now, right? I want it to run the script for me. And important to note, it says I'm running in a read-only mode. I can't execute scripts for you, but you can run it in SSMS. Well, in Copilot, we've added a couple different modes. The default is read-only, But we also have one called a read-write, and we also have one which is a read-write with approval. I'm just going to go into read-write. I'm feeling really good about what Copilot is doing for me. And so I'm going to go into read-write mode. Now it resets the chat history here. So all the conversations that we've had are gone, but I'm going to just bring up this last prompt, which is I need to increase the size of these tables, generate the script for me, right? Duplicate the data. And so it comes back with that. And again, I'm now in a read-write mode, and I'm going to ask it to run those queries on my behalf. And it's just doing an insert. It's a insert and selecting from what's there already. Can I write this? Sure, but it writes it for me. And so I'm going to say, okay, I want you to run the script, but back up the database before you do so. This is me being safe. I'm going to let Copilot run this, and this is just the beginning of my database. So if things get really messed up, I saved out all my scripts to that MD file. I could recreate the database if I needed. But just to show you, you can tell Copilot to back up the database. And so it did. It's like, okay, I've backed it up to see backups. And now I'm going to go ahead and duplicate the data. And it says, I've done that. Great. Trust but verify, because I'm a DBA at heart, really. You don't want me as your developer. But it says, okay, there's your backup. Like I just went and checked. It's there. And again, I asked it to duplicate all of that data. It did that after backing up the database. So I've cleared chat history again. And again, I'm still in the context of my general hospital database here. And so now we're going to say, okay, give me a query that's going to get the count of the rows in each of the tables. So again, I can write a select count statement. If I only have 5 tables, it probably wouldn't take me that long. But where can you get Copilot to do the work for you? And this is where it's really a shift in your mindset. I know it can be tricky. It's a change in your workflow. And while new improvements are great, like sometimes remembering what you got to do, it can be tricky. So here we go. We inflated the test results, the appointments, and all of that. So now what I'm going to say is, okay, I need you to write some queries. So I re-prompted with some of the original text that I had when I was asking for tables. But now I'm saying, what kind of queries do you need? I might already know that. You might already know what kinds of queries you're going to write. But sometimes it's kind of interesting to ask because maybe there's something you didn't consider. Maybe it writes it a slightly different way. So it comes back with some basic selects. It comes back with some administrative queries, it calls it as well. And then I'm going to say, can you provide a few more complex queries, right? I just don't want one table, but like give me listing the patients for each doctor based on their diagnosis or the number of appointments that a patient had. So now I'm saying, okay, I have an idea of what I want for the queries. Go write them for me. And it comes back with a whole bunch of these, with the 3 that I asked for, actually. Now I'm going to go one step further and say, take that query, and I'm going to actually copy the text of the query, and I want it to put it into a stored procedure where the input is the patient's first and last name. So I grabbed one of the queries that it had written and basically said, put that into a stored procedure where the stored procedure input is patient first name and last name. So it's checking all the T-SQL that has been passed into it, and then it gives me the create procedure script right here. So if we paste this in, you can see that I have first name and last name that it's passing in, and then it has the query, which gets the appointment, the diagnosis for that patient based on input. And I can repeat this. I'm going to go ahead and ask again for a procedure for another query where the input is also not in this case. Let's see, I'm doing doctor information here. So I want physician first and last name. So now in this case, I could have told it to create the stored procedure, but we're doing 2 things at once here, right? So on the left, I made a slight change to that script because it didn't grab the right varchar length. It grabbed a 50 instead of 100. So I ran that script on the left. Over on the right, Copilot is still doing its thing. It comes back here with this procedure. Oh, sorry, this was get patient test results. So I can go through and do that over and over again, which I did in the background. And so now I've said, okay, I've created these stored procedures, what indexes do I need for those stored procedures? It's great that I've created the queries. I know that I have my clustered index on there. I know that I have some foreign keys, but we just created some other queries that are going to look at first and last name. And so it says, well, there's no missing index recommendations. What do you want me to do? I need to be a little bit more specific here, right? I'm saying use the code in the stored procedures to figure out the indexes for that. Otherwise, it could go and it could look at the workload as it's running right now and identify missing index recommendations. It can also, you can direct it to look through Query Store for that as well. If you've ever had to look for missing index recommendations, it can be kind of a complex query. Copilot can help you write that. Copilot can help you find it. And so now it's coming back with a whole bunch of indexes that it suggests. And I'm going to say, great, go ahead, put all of those into one script. Now, in general, I'll tell you, I don't just willy-nilly go and create lots of indexes without some level of validation. Again, I about said I grew up as a DBA. I spent a lot of time doing performance tuning and database administration. And so there's no magic number of the right indexes. There's a sweet spot of how many indexes do you need that will satisfy all of your queries, but also not interrupt load performance updates, etc. So it recommended an index on patients, a few on appointments, on diagnosis. Now, what I notice when I look at these is that these are all really just single column indexes. Those are probably going to evolve over time, but potentially a good start. Now, I've switched databases here. I may not have noted that, but I'm connected now to the Wide World Importers database because I can run a load against this one. My general hospital I've got all set up, and now I can start running a load. But I already have the scripts to do that for Wide World Importers, so we're going to look at that. And I'm going to say, can you look at performance in this database for the last hour? I've been running a workload for Wide World Importers while we were doing all this other stuff for General Hospital. It says, sure. And it comes back, and I have Query Store enabled, which is one of the best features ever in my opinion. And I know that I'm biased, but that's okay. And it gives me the top resource consuming queries from Query Store for the last hour. And it's doing that based on average duration. I could ask it to look at CPU. I could ask it to look at I/O, memory. It's defaulting to duration, which is pretty typical. And then I said, have any of those had significant changes in CPU in the last hour? And so it comes back and it says, okay, these have shown a decent change in CPU in the last hour compared to the previous 24 hours. And so then I'm like, well, okay. How can I look at this in a little bit more detail, right? How can I see these specifically in the SSMS UI? And it's great because it tells me, right? It's going to be like, okay, open SSMS, connect to your database, navigate to Query Store, view the performance report, analyze specific queries. So not only is it going to write T-SQL, not only is it going to help me answer questions for me, but it can tell me how to do something within SSMS. So sure enough, I come over here, I look at the top resource consuming queries. I look at this first query here, which has a couple plans, which maybe that's potentially concerning to me. I can slice and dice this data different ways within SSMS. I'm going to change here to look at CPU, and I'm going to look at average CPU because sometimes that's really interesting. And I've got a pretty big change here between the plan 9032 at the bottom and plan 14106 and 14105. And now I'm going to ask Copilot for a little bit of help here. I may or may not be familiar, or you may or not be familiar with how to read an execution plan. So I'm going to ask Copilot to compare the plans for me, right? So I'm giving it the specific plan IDs from Query Store, and I'm saying these are in Query Store, and tell me what is different. Now, reminder, you have to have the Query Store feature enabled for your database to leverage this. It's definitely a huge value add in my opinion. And I canceled the response because I typed the plan ID incorrectly. And so I'm going to ask it again and say, tell me what is different between these two plans. and it's thinking about it, which is fine. And I can show you here, and I know because this is data that I've worked with for a long time, right? The primary difference between these two plans is that one of them does a clustered index scan, and one of them does an index seek with the key lookup, which feeds into a nested loop. And there are different scenarios where those are necessary. And I can do a compare plan within SSMS right from Query Store, and I can look at those differences. But even though you may be able to identify, oh, this has a nested loop, this has a clustered index scan, sometimes it's still like, what do I do with that information, right? And so Copilot can help you. And it does a little bit of a summary over here on the right side where it summarizes the two different plans, and then it says, here are the key differences, right? One of them uses parallelism, one does not. One has a lower compile, one has a higher, right? Execution plan. Here's the clustered index scan versus the nested loops. And so it says that one plan is optimized for parallel execution. The other is for simpler non-parallel, and it's actually for smaller data that's going to be returned. And so I'm like, okay, what is the main data set that these access when they're looking at the clustered index scan versus the key lookup? I can dig into that in the properties, but I can also just ask Copilot. And it says, well, for the clustered index seek, it goes against customer transaction. It goes against that for the key lookup as well. And so they access the same table and indexes, but one is doing a seek and one is doing a scan. Right? So it's explaining all of this. Again, you can save this out, right? If this is the kind of thing where you look at it and you're like, I kind of understand, but maybe I want to come back to it later, save the chat out as an MD file. The last thing I'm going to ask it here is I'm going to say, is there any way to improve performance of this query based on the plans, right? So is there anything in the plans that can help you figure out how to make this better? And it's, again, entire chat history here is relevant. And it's like, okay, here are my recommendations. Both plans have a missing index recommendation, which is definitely something to pay attention to. It talks about some other things I could do. I can look at the parallelism for the plan. It mentions down below updating statistics. The order that they're in, don't always assume priority unless you asked for a priority order. But the clustered index, the non-clustered index recommendation, because it appears in both plans, is worth investigating a little bit further. And it gives me the steps to either create the index, to update statistics, to potentially look at using a query hint. This is another one. This is an interesting scenario where maybe I understand a fair bit about indexes, but I haven't done a ton with query hints. And so I'm going to say, what are the drawbacks of using this query hint of option recompile? And it's going to go through and it's going to list out for me the potential drawbacks of using this. Increase CPU, increase compile time. You end up not having that plan stored in cache because it has to recompile every single time you execute it. If that's a query that you execute a ton, that's probably not something you want to do. That's why it drives CPU. And so it gives some examples of when you want to use it, when you have a parameter sensitivity issue, which is what's happening here, for variable data, etc. And I love this conclusion that it gives, right? It can be useful, but it's generally better to address the root cause. And in this case, I can tell you that the non-clustered index is really how to address the root cause. A few slides to wrap up with here. Thanks for, I know that those demos were really, really quick, but hopefully you found a ton of value and they've really piqued your interest in what you can do with Copilot in SSMS. Coming to a theater near you. In all seriousness, let's talk about the roadmap for a second. It will be available at some point in the future, and it will be available with SSMS 21 as an optional workload, which means it's not installed by default. The bits don't go on your machine by default. You control whether you have it installed or not. As I said several times during the demo, we will be bringing that inline editor to SSMS. I don't have a timeline on that, but the team's actively working on that. And then you'll be able to do fix doc explain from right within the editor. A few questions that we frequently get asked, which I've thrown up here onto an FAQ slide. The first one, when will it be publicly available? Spoiler, I don't have a date. It depends. We're very much focused on quality over a specific date that it will be available. And I'm sure a lot of you can appreciate that. In terms of cost, I mentioned before, that's really dependent upon the deployment, the endpoint, and the model and the use. The offerings that we support right now, Azure SQL Database, Azure SQL Managed Instance, and then SQL Server, we will support 2025 and earlier, probably back to what is currently supported for SQL Server, which I think is 2014. And in terms of enabling, disabling, again, I want to make this very clear. This is a workload that is optional when you install SSMS 21. So it's not part of SSMS by default. You opt in. If you don't want it, you uninstall it, you remove that workload. And then in terms of copilots for other offerings, Copilot for Azure SQL is out there, and we know that there's some other offerings available. Stay tuned for more updates on that. A few tips when you're using Copilot in SSMS. The context matters, so make sure you're in the database that you're interested in or connected to that database. How quickly it's going to respond really depends on what you've asked it to do. Sometimes when you're asking for a summary, that can take longer than if you're just saying, hey, what's the compat mode for my database? Use it when you need help. Anytime you might typically hop over to your favorite search engine to ask a question, ask Copilot first. It's a change in your workflow, but I promise you that if you can stick with it, it will reduce the amount of time you have to spend on certain tasks and definitely on mundane tasks. And then one thing I don't have on here is don't treat the sidecar chat like the editor, like the results grid, right? You really want to ask typically for a query and then run the query versus asking Copilot to give you all of that information. I think that when folks start writing T-SQL within the editor, when we have that capability available, that will be a much more natural fit. Thanks for tuning in, for attending this conference. I really appreciate it, and catch you next time.
Catch you next time. No doubt about it. Thank you so much, Erin. That was fantastic. I mean, honestly, it's going to be a game changer as we start to see Copilot integrate more and more into our tooling. And it's great to see that we're putting so much thought and so much work into making sure it's integrated into the tool that honestly most people use when they interact with SQL. SSMS is unbelievably popular. And so as we've started making changes and started enhancing it, bringing it to be really a terrific tool again, right? For a while there, we kind of rested on its laurels, and we don't do that anymore. It is an incredible tool with a bright future. There's a lot going on in the chat room today. Let's go through that. A couple of questions that are at least worth bringing to everybody's attention in case you're not looking at the chat yourself. One of the questions is whether or not this is in public preview. It's not. It's in private preview for now, and public preview is on the way. Thank you for that question, though. Tim asks, can Copilot help me in the designer? Most of the work we do is in the designer. And Erin, who is on the line, she has answered that already, saying that no, it doesn't help you in the designer today, but that's not the first time she's been asked that question. And so this is some serious consideration to figure out just how it can fit into each of the aspects of the tool. LD, who has now turned into be one of my favorite people in the world, has said, this is an amazing conference. Obviously, you have impeccable taste. I hope we get recordings for us folks in Europe. Absolutely, we will. Every single session is going to be recorded and released after this conference. Thanks for asking that. Sam says, I'm glad to see Copilot coming along, and this is definitely reviving SSMS functionality and usability. Great work, Erin. Well, first of all, yeah, great work, Erin, no doubt about it. She makes the point, though, that SSMS 21, which is 22 is what we're working on now. 21 in general also revived SSMS functionality, specifically with 64-bit, Git integration, and every developer's favorite, the dark theme. Tim's figured it out. General Hospital's Luke and Laura's wedding. Luke Spencer, I believe. All right, and let's see. Thank you, Bishop, for asking this question. Does it give us index recommendations and indicate the performance bottlenecks? And it does. That was part of the demo. I'm glad that we were able to see that. And That's just one of the many aspects that I think we're going to find that that's where we go first, right? Oh, does it do index recommendations? That, as important as that is, and as key as that is to performance, especially of large databases and complex queries, that's just the tip of the iceberg for what Copilot's going to be helping us with as we move forward. No doubt about it. Yeah, from Asuna here said, just joined. Something I have a lot of trouble is understanding how to read statistics. You're not the only one. I have the same problem. Is Copilot going to be able to help with that? Let's actually back up and ask the question, what will Copilot not be able to help us with? It's really exciting. And Wendisha just points out the fact that this is going to be a real game changer, not just for SSMS, but for across the entire tool set of SQL, where you're going to see all kinds of capabilities like this unlock what developers are able to do, and basically be able to take a junior developer and let them behave like a mid-level developer, and let a mid-level developer behave like a senior developer. All right, so we're moving right along here. Let's see. Right now we are just getting past, let me pull that back real quick. We're just getting past on our agenda Erin's work here around a developer's guide to using Copilot in SSMS. Very exciting. Thanks for that again, Erin. Next up is going to be GraphQL meets SQL. We've already had some questions around Microsoft Fabric and whether or not we have sessions. Here we are going in. Ed is the PM for the GraphQL endpoint inside Microsoft Fabric. Interesting and fun little tidbit, shared code base with Data API Builder. So if you're wondering if DAB can handle large payloads, well, the answer is yes. And if nothing else, Fabric has forced that to be true. Now, don't forget that it was SQL projects that Drew was talking about. That ability to be able to take your schema, take your queries and all of your DDL and be able to treat it like source code and be able to integrate it into your CI/CD pipeline using not just SQL projects, but SQL package as well, which is able to do the deployments for you from the CLI. Data API Builder is available for you for free. It's open source. It's AKMS/DAB. And just like we talked at the very beginning with Mawasma, Azure SQL Database now is free. So you can go and get up to 10 free databases for every subscription. This is the lifetime of your subscription. It comes with 32 gigabytes of storage and 100,000 vCore seconds of compute every month. So with 10, I guess you could think of it as 1,000,000 vCore seconds every month, as crazy as that sounds. Each one of our presenters keeps landing on this, the new applied skill that we have and its companion Microsoft learning path for develop data-driven applications. This is a specific learning path to make sure that you understand the new capabilities of SQL Server, but also that you are able to demonstrate that and receive a credentialed applied skill that you can add to LinkedIn to show that you don't just know it, but you also know how to use it. All right, so here we are, ready to go. I'm excited to hear what Ed has to say. There's a lot going on. I can see how active the chat is right now. This is really great. So go ahead and ask your questions. We're of course welcome all of those. Some of the PMs are monitoring the Q&A right now, and anything that isn't asked, I'll make sure it gets to the right person so that you can have that as well. So you are right now at SQL Conf 2025. It's a developer marathon of SQL-oriented content curated and tailored just towards you, the developer and the engineer. So let's turn our attention now to Ed. Let's talk about Fabric and the GraphQL endpoint. And before I even do that, let me just remind you that Data API Builder provides both a REST endpoint and a GraphQL endpoint on your data sources. It does not provide an endpoint over your Fabric data sources, and that's what Ed's going to talk about here. It's a paradigm shifter in so many ways to be able to use the compound complexity and capabilities of GraphQL. Take it away, Ed,
Hello
and thanks
welcome.
for doing this.
My name is Ed Lima, and this is GraphQL meets SQL, modern data access for SQL developers in Microsoft Fabric. Very excited to be here. I hope you're having a great day so far, and let's get started. first of all, a little bit about myself. I don't know if technologist is still a good word, but I'm very passionate about technology. I've been working with technology for many, many years, with lots of experience in application development, data, product management, and also cloud. Been working cloud for a very long time. Currently, I'm a principal product manager at Microsoft Fabric, working specifically on Fabric API for GraphQL. And today we're going to talk about exactly that, GraphQL. What is GraphQL, right? Of course, here, this is a SQL conference. We are all familiar with SQL, which is a great technology. But how GraphQL can empower SQL applications and actually help to expose data to a wider audience through different kinds of applications. We're also going to talk about what's offered in Fabric and how we make super easy to use GraphQL and SQL together in Fabric. We'll end up with a little demo, and you see how we can basically set up a GraphQL API to expose SQL data to your application in about less than 5 minutes. Let's get started. So GraphQL is an API query language and a runtime to fulfill those queries. You describe your data using a schema with types and specific fields. Client applications or API clients can just request what they need and allows you to get predictable results using a very simple and flexible language. So, of course, one of the biggest selling points is applications request the data they need, right? It's a strongly typed system where a schema defines the data. And again, that logic comes out of the box if you need strongly typed code in your application. You have GraphQL expose a single endpoint, no need for paths or anything like that. And you access data through that single endpoint, and you can get data from multiple data sources, again, sometimes using a single API call. And you can aggregate data from again, multiple sources through that single API response. So GraphQL API is defined in the GraphQL schema, which is a schema definition language where the main components are types. And types has multiple fields. You can draw a parallel with databases where types you can relate to a table, and the fields will be the columns of that table. There are specific operations in GraphQL, queries to read data, mutations to write data. And in your schema, you can also define relationships between the types that you have. A quick comparison here on GraphQL and SQL. So as I mentioned before, GraphQL is a query language for APIs and a runtime to fulfill those queries with the existing data. So it's very much on the front-end side of things where you want to expose data. It can be on the back-end side of things if you have a back-end API. It's totally fine to use that as well. So SQL is a query language for relational databases. It's again the use is more focused on specifically on the database side. GraphQL is best used for fetching data from APIs efficiently, and SQL used for managing and querying structured data in databases. Data retrieval in GraphQL is very simple. We're using the GraphQL client, and the clients basically define the data that they need. In SQL, you use predefined queries to retrieve data like selects, joins, inserts, so on and so forth. GraphQL is very flexible, allowing multiple data sources to provide data in a single request. You don't have to make multiple API calls. So it makes it very efficient in that way. You can get more data with less API calls. SQL, it's more rigid, of course, and you have to define your data also in a schema and define the relationships with keys and primary keys, foreign keys, and things like that. GraphQL is technology agnostic. We can, while our focus here is on SQL as a backend, GraphQL supports anything. It can be SQL, NoSQL, REST APIs as a backend. So it abstracts all the backend technology from the API client side of things. SQL is more focused on relational databases. GraphQL, as mentioned, very efficient. You get the data that you need, no overfetching, no underfetching. And SQL, of course, you can optimize your database with indexing, caching, store procedures. Both of them, as already mentioned, they use a schema. They are strongly typed systems. Learning curve, so GraphQL is very familiar with API and front-end developers. And in SQL, of course, you need some knowledge of relational algebra, SQL syntax, relational databases, and things like that. So it's much more data-centric, database-centric backend use case. That's not to say that GraphQL cannot be used on the backend. It can, of course. So use cases for GraphQL, it can be used for front-end applications, for back-end APIs, microservices, and basically consolidate data from multiple data sources. SQL, widely used for data storage, business intelligence, reporting, transactional apps. So let's get started, again, drawing some comparisons and parallels between SQL and GraphQL. And you see they're actually pretty similar. Of course, again, here we are all very familiar with SQL. It's a SQL conference, but you might not be that familiar with GraphQL. Querying data with SQL, of course, you use a select statement. There is that concept of select star, where you get all the data. In GraphQL, there's no such concept. You have to specifically define the data you need. And that's on purpose because, again, we are telling the API clients, you tell me what you need, and I'm just going to provide that. If you don't need specific data about currency or capital, then I'm not going to send that to you. But again, as you can see, very simple syntax. You just need to define type or multiple types and the fields that you want to get data from. So GraphQL query, the main thing, of course, it's very heavily based on JSON. You define operation, right? Query to read, mutations to write, and then you just need to provide a specific type. You can draw a comparison again. The type could be a table in your SQL database, and you have a selection set. The selection set is the fields that you want to retrieve, and that would be the column selection from the database. In a single query, you can basically request data from multiple types. And you see in our demo also, you can create relationships between those types very easily and basically consolidate the data even more. Filtering data. So how you can basically just tell that runtime or that backend just specific data that you need. Right, that's the bread and butter of GraphQL, and of course with SQL also you can do that. You use a where clause where you define a specific filter of data based on conditions. GraphQL very similar. Basically, you can define filters or you can use arguments to define what you want. You can also select add multiple arguments. You can have and or logic as well. and use comparisons on your filter and your arguments as well. For instance, here, just retrieving whatever code language it's in English. Inserting and updating data in SQL, again, we all know the insert statement, delete and update. Basically, you cover all the CRUD use cases here: create, read, update, delete, list. We talked about querying before, but here's basically how you're writing data, right? In GraphQL, of course, in SQL you have multiple operations, but in GraphQL there's only two: queries to read data, mutations to write data. And GraphQL mutations are very similar because you just provide arguments, right? And those arguments in your mutation code, you just need to provide the value of the data that you want to insert or update. Usually, as best practices in the GraphQL schema, you define a specific mutation to create, a specific mutation to list, a specific query to list, a specific query to read, and a specific mutation to insert, delete, or update. So you can have different logic depending on the operation you want to use. I think now you're all experts in GraphQL. Again, it's a very simple and powerful API technology. However, if you want to implement your own GraphQL backend, your own GraphQL server, there are lots of things you need to worry about. And it can take from weeks to months to have GraphQL API in production. Of course, you have to define your server, configure the server, define the schema, configure the resolvers. So resolvers are built-in functions in GraphQL that resolve the data from your schema, from your types or queries or mutations fields with the data from the data source. Right, so there are specific functions to access the data source and provide the data that you need. So you need to actually code all those resolvers manually as well and add your specific logic there. After this is all done, you have to think about performance, monitoring, tuning, and also securing your API with authorization authentication layers. So again, lots of work to do. And how are we solving this problem in Fabric? Well, we're basically taking care of all of that for you with API for GraphQL. So we take care of schema generation, resolvers generation, security, and monitoring, and all of that for you. So basically, you take advantage of all the Fabric goodness. So API for GraphQL is Fabric native with security, governance, capacity consumption model following all the other Fabric workloads. Provides a very simple, flexible, SaaSified experience with a single intelligent endpoint for all the data of your application. So it's basically API for GraphQL is the data API for Fabric. And again, taking another look at how GraphQL in general works and how specifically API for GraphQL in Fabric works. So API clients, basically they're authorized. So there is no public API for GraphQL. You have to provide some sort of authorization to access your data, authorization authentication. So the GraphQL API receives an authorized request and then automatically sends that request depending on the data that's requested to the different data sources. And then it consolidates all the responses from different data sources
in a single JSON payload that's then sent back to the API client. So it allows to basically get more data with a single API call. If you compare to other API technologies, you have a separate API for each one of the data sources you have to make 4 or more API calls to retrieve the same amount of data. In GraphQL, single API call. And of course, it abstracts all the backend complexity here, right? You don't write any SQL code in your application client. And of course, it protects your data against things like SQL injections and things like that. So it's very recommended to use an API as a layer of security and don't actually run SQL statements in your client application. So GraphQL is here to help basically provide that sort of capability to protect your SQL data and expose the SQL data to applications. So once you set up your API for GraphQL in Fabric, exposing your data, you prototype your queries, you know what you want to expose. All you need to do is very simple. You just need to click a button in our portal, copy the API endpoint. Then you need to go to Microsoft Entra and basically create an app registration. You provide the endpoint, some specific information about the client ID, the authority where you're authenticating your Entra application, and the GraphQL endpoint, and you're good to go. So you can basically start querying and exposing your data to the application. It's very simple and very easy. What about security? So how we actually securing the data and blocking unauthorized access. So here we have client applications that they can be internal applications, external applications, web, mobile, line of business, anything that you need, right? Maybe you're developing a dashboard and you can expose that using GraphQL. You have your API for GraphQL endpoint in Fabric, and you want to expose Fabric data, right? Of course, the most simple use case is you have a user in Fabric, right? As I mentioned, we authorize the access of the user with Entra, registering an application in Entra. So that user can then use single sign-on to access your Fabric data. That means that your database user or data warehouse or lakehouse user is also an API user, right? And that's fine for specific internal applications. That might be some of the requirements, right? So you can provide that sort of facility to access your data. But sometimes maybe you don't want you have an external application and your user is not in Fabric or not in Active Directory. So you can use service principal. So you can basically have a service principal, a service, of course, a backend service that can provide access to your API, and you add some specific logic to authorize specific users that can be on any other identity provider that you use in your business. So that's very a common use case for external applications, can be mobile web applications. And you can add the service principal as a database or data source user. So you could use also the same pass-through capability, SSO capability. Or if you don't want your user of the API user to be a database user, you can use a saved credential that is basically shared by all the connections. So it allows for better scalability, and depending on the use case, again, you don't want your database users to be your application users. That's perfectly fine. So that way we allow to basically protect your data and address different requirements and different use cases to expose your Fabric data. And we also have a new member in the Fabric family. It was announced in public preview very recently in November. We have now a Fabric native SQL database, where it's built on the foundation of Azure SQL, that everyone knows and love. Provides a very simple, powerful, flexible, performant experience. Again, in the ethos of Fabric, you want to simplify the experience, provide a SaaS experience. So it's integrated with all the Fabric goodness and Fabric components. It can be deployed in seconds. It's very fast, auto scale and performance. It's basically optimized. And basically, like I mentioned, integrate the Fabric services, OneLake integrated. So it's a great database, a great option to store your data in Fabric. So now, how you bring those things together? So how can you expose your SQL data application through a GraphQL API in Fabric in about 5 minutes? Well, let's take a look and see how you can do it. So we have here a SQL database already created, the Fabric SQL database already created in my workspace. I can access that. I just basically use sample data that's readily available when you create a database for the first time. You have your data about customers, sales, products. It's a very simple database. All you need to do is click a button in the ribbon and provide a name for your API. You provide a name and you click Create. After doing that, all you need to do is select the tables you want to expose. Right? I just want to expose that sales LT, the sales IT tables there. And that's pretty much it. You click load, GraphQL schema is automatically generated for you, all the resolvers, queries, mutations, and you're ready to query your data. Just like that. We have API editor and explorer where you can basically test and prototype your queries and understand how you want the queries to be presented in an application. We have full IntelliSense where you can easily just autocomplete the fields that you want to provide. So it's very easy to get started. See, here, we just want to query the customers table with specific columns, customer ID, phone, modified date. And there you go. You have your JSON data returned there. You can also create relationships between your data. So we have here the sales order header type. And they have the header can have many orders. So you're going to create a relationship, a one-to-many relationship between sales orders header and sales order detail, using sales order ID as the key, right? To create that relationship. Again, you create the relationship. The schema is refreshed automatically. And a new field is created under the type we selected. You can see there sales order detail is now created in the type. And let's now query sales orders and query the details of those orders, right? So again, the sales order header can have multiple order details. So we specify here specific fields, and they're going to go also include the specific quantity of an order and maybe a unit price there. Just need to run our query, and there we go. Very quickly, very performantly, we have basically the data, the sales order header, and all the order details with those specific fields that we specified. You can then test very, very easily. You generate code in Node.js or Python. We generate that code for you, and you just need to copy that. I have VS Code running locally. I'm just going to paste that code. And here I already have a Node.js project with the dependencies installed, just Azure Identity. It uses an interactive login. Basically, it's going to use my credentials and the browser to confirm my identity. Of course, I have access to that workspace. And after I am authenticated, it just returns the data there. You can see all that data returned by my Node.js local application. Of course, in the production, you wouldn't use an iterative authentication like that using the browser. You want to use Entra application registration, but that's a very quick and easy way to test locally using Node.js and Python. But there it goes, less than 5 minutes. You have your data in SQL and the Fabric SQL. You can expose to an API for GraphQL in a very secure, safe way, very performant way, and get the data available to your users and customers for line of business applications, for external web or mobile applications, and in whatever way you need to expose the data. Here's some resources for you to get started. We have a very great tutorial available where you can get started. It also uses Fabric SQL on the back end. You can go step by step, explore more the options that you can have with GraphQL and SQL and Fabric. We also have our documentation, and we recently announced general availability of API for GraphQL with exciting new features such as deployment pipeline, Git integration support, monitoring dashboard with request logging, and many more. Also support for Azure SQL directly if you don't want to use Fabric SQL. So yeah, take a look. I hope you enjoy, and I hope those resources are useful for you in your next project. Also, there's a new learning path. Take a look, develop data-driven applications using Microsoft Azure SQL database. Well, that's it from me. I hope that was useful. Thank you very much for your time, and I hope you have a great rest of the conference with many other exciting sessions out there.
Thank you, Ed. Appreciate that. Thanks for showing us how to build out a GraphQL endpoint and then interact with it inside Microsoft Fabric. We've got Brian up next. Brian's going to be talking about introducing GraphRAG. We're in a world where AI is the real deal, and we're in a brand new world where SQL makes it all happen. Brian's going to walk us through it step by step. If anybody knows it, Brian knows it. We're lucky to hear him talk about it. All right, Brian, take it away. Thanks again.
Achieve data synergy by optimizing your GraphRAG AI applications with the power of hierarchical relationships in Azure SQL. Hello, I'm Brian, a product manager in the Azure SQL database team here at Microsoft. Today, we're diving into the fascinating world of graph technologies and AI, specifically focusing on GraphRAG and graph features in Azure SQL. Whether you're a developer or just curious about cutting-edge database technologies, This video is for you. Let's get started. First, let's set the stage. Traditional relational databases have always been the backbone of data storage for decades, efficiently handling structured data through tables and relations. However, as data becomes more interconnected and complex, there's a growing need for more flexibility and efficient ways to represent and query relationships. Enter Graph in the Azure SQL database. Graph databases, like Azure SQL, use nodes, edges, and properties to represent and store data, making them ideal for applications where relationships are as important as the data itself. From social networks to recommendation engines, graph technologies are about transforming how we handle and think about interconnected data. Here's an example using the popular Adventure Work sample dataset. I have 3 tables: bike frames, bike accessories, and bike tires. In a traditional table structure, we could relate these tables with a foreign key. However, this approach might require creating multiple separate metadata columns or tables, resulting in a costly and difficult to manage data model. All this effort just to retain relationships between the bike frame and a tire or a particular accessory. For example, only a specialized set of tires might work on a specific frame, and that frame might only accommodate a custom water bottle due to its design. Foreign keys are simply not suited for this task. But what if I made these tables into nodes? And then I created meaningful relationships between the items in the table. This would provide a new level of synergy between our data that a foreign key just could not. Before moving on to AI and searching, we need to cover vectors and vector arrays. In mathematics, vectors are fundamental objects that represent both magnitude and direction. They are typically depicted as arrows in a coordinate system, where the length of the arrow indicates the vector's magnitude and the direction of the arrow shows its direction. In machine learning, a vector is a fundamental data structure used to represent data points. It is essentially an ordered list of numbers, which can be thought of as points in multidimensional space. Each number in the vector represents a feature or attribute of the data. Imagine you have a data set of users and movies they've rated. Each user can be represented as a vector where each element corresponds to a rating they have given a particular movie. In this example, you have 3 movies, therefore a user's vector might look like this, where user 1 has given the first movie 5 stars, the second movie 3 stars, and the third movie 3 stars. User 2 has given the first movie 1 star, the second movie 3 stars, and the third movie 4 stars. And you can see it's depicted here as a vector array. Now, a vector array, or vector embedding, is a technique used in AI and machine learning to transform data, may it be text, images, audio, and video, into numerical representations, or vectors, that capture the essential characteristics and relationships of the data. Each number is referred to as a dimension. Where are we going with all this? Well, Azure SQL now supports the vector data type, the ability to store these vector arrays natively in the database. Once in the database, we can use functions such as vector distance to compare arrays. And how can we use vector distance for similarity searching in the database? Looking at this chart, we have the embeddings for apple and banana. And we see they're closer together because they are fruit. We see we have the embeddings for dog and puppy. And we know they are related as well and are closer together on the chart. Now, using the vector distance function, we can relate apple to puppy. And we see there's a large distance there. When we relate it to dog to puppy, we see that the distance is much smaller. And how is this better than text searching alone? Using the search phrase, "I'm looking to buy a comfy red sofa," a text search would bring back exact matches to keywords it finds in a product name or description. In the first example table, red and red sofa were direct matches, and thus in the results you would get back. Now let's take a look at when we use a similarity search and use the distance between vector arrays. The results are expanded with the phrase matching maroon couch and crimson daybed. While these two colors are not red, they are similar, and the same with daybed and couch. They're related to sofa. Using a similarity search, we can extract meanings between our search terms and phrases that we cannot just with a text search. You can also have a hybrid search, combining text and similarity search into a single set of ranked results. Now you might be wondering, what is GraphRAG? GraphRAG stands for Graph Retrieval Augmented Generation. It's an advanced method that combines the strength of graph databases with Retrieval Augmented Generation, or RAG. Okay, but what is RAG? RAG is a technique in natural language processing where a language model retrieves relevant information from a knowledge base to generate accurate and contextually relevant responses. And by integrating graph databases into this process, GraphRAG enhances the retrieval process by leveraging the rich relational data stored in these graphs. This means more accurate, context-aware, and semantically meaningful results, especially in complex data environments where relationships are key. See how the pieces fall into place? We leverage the new vector type and functions in the Azure SQL database for similarity searches. We then augment the results of the similarity search with data that is related via the graph functionality, finding relationships between data that a foreign key cannot provide. We can visualize this using a GraphRAG and Azure SQL search flow. Going back to our node tables, we can add a vector data type column where we can store the vector embeddings that contain product information for similarity searching. Here's an example of using GraphRAG with the Azure SQL database. To start, a user issues a prompt, and that prompt is embedded using Azure OpenAI. Once we get those embeddings back, we can run a vector similarity search to get the best bike frame that matches the user's prompt. Then we can do a vector similarity search to get bike tires that best fit the user's prompt. We could then filter those tire results based upon the relationships we created in the graph. We can do another vector similarity search to get the best bike accessories that match the user's prompt. And then, as before, we can filter the accessory results based upon, again, the relationships we created in the graph. These results are then ranked and passed back to a large language model so that it could format the answer and give it back to the user. Let's now build this exact flow in the Azure SQL database. Using the Microsoft SQL extension for VS Code, we're going to start by creating the graph table structures in the database. Our graph will have 3 node tables and 2 edge tables. The first graph table will contain bike tires. It will also have a vector data type column called embeddings, where we will store the bike frame description as a vector array for similarity searches. You can also see in the syntax that we denote this table as a node simply by adding the as node at the end of the table create statement. Next, we have the bike frames graph table, again having an embeddings column for vector similarity searches. It is a node table as well. Finally, we have the bike accessories graph table, same structure as the previous 2 tables, and again, it is a node table. The last 2 tables we are going to create are the tires and accessory edge tables. These 2 tables will contain the relationships between bike frames and specific bike tires and accessories. After highlighting the table code, I can use the Run or Execute button to create our 5 graph tables in the database. Next, we are going to add data to the node tables. We're going to use the AdventureWorks dataset and flex our creative minds and build products and relationships that seem to work together. For example, mountain bike tires work well with mountain bike frames, where road tires are best for road riding bike frames. To start, I'm going to get product information for bike frames in categories 16, 18, and 20. These are the mountain, road, and touring product categories. We are then going to put these rows into a temp table. Now that we have our product data, we can use a while loop to get a product ID from the temp table and get key information to create embeddings. Here we are going to get a product name, color, category name, model name, and then the product description. This data comes from the product category, product model, product, and product description tables. Once we have all the necessary product data, we can embed it by passing the concatenated text to an Azure OpenAI REST endpoint for creating embeddings. Now, we insert the product ID, the category ID, and the vector array we just created with the embeddings endpoint into the bike frame node table. The last part of this code deletes the current product ID from our temp table and loops back using a new product ID. This continues until the temp table is empty. We now run the SQL and the data is inserted. We're going to do a similar process for the bike tires node. Again, we get the products we want to relate to the frames in two specific categories and insert them into a temp table. Then get key product information, create the embeddings, and then insert the data into the bike tires node table. And the third statement gets the accessory product data for the accessory node, just as we did for the previous two node tables. Now that the node tables have been filled with data, it's time to create the relationships between the products using the two edge tables. The next set of T-SQL statements use CTEs, or common table expressions, for getting the relevant product node data we are going to use for creating relationships. These three statements are creating a tires relationship between products in the frame and tire nodes using the tires edge table. Each statement deals with a different category, starting with mountain, then road, and finally touring. We use a similar set of statements for creating accessory relationships in the accessory edge table between bike frames and bike accessories. Now that we have all the data in the node and edge tables, as well as the relationship setup, it's time to use them in a stored procedure that can be later used as a GraphRAG API for recommending to a customer a bike build based on a prompt. Before we put the final code into a stored procedure, we can create and test the T-SQL using the VS Code query editor. We start with a sample prompt. The prompt is then embedded via an Azure OpenAI REST call, so that we can do a vector similarity search on the bike frame node to get the top match. Using the bike frame ID, we retrieve from the similarity search. We get the bike frame details and add it to a temp table, where we will store all the products retrieved that will eventually be sent over to an LLM for answer creation. In the next section, we use the embedded prompt text to find similar bike tires and filter the results to only product IDs that have a relationship to the bike frame using our nodes and edges. You can see the graph syntax here that says match all the bike frames that have a tires relationship to the bike tires, and further filter it based on the frame ID we previously retrieved. And once we have those matched tires, we insert the product information into the temp table. Just as we did with the tires, we do the same for the accessories, again leveraging the relationships that we previously created. We again filter the products based on the bike frame ID and insert the results into the temp table. The final product results are returned using a pivot query, which retrieves the top 4 items with the smallest vector distance for each category from the temp table. The results are then ordered by category name and distance. Let's take this step by step. The query starts with a CTE named ranked items. As a refresher, a CTE, or common table expression, is a temporary result set that you can reference within a select, insert, update, or delete statement. Inside the CTE, the query selects all columns from the temporary table. It also calculates a new column, RN, using the row number function. This function assigns a unique sequential integer to rows within a partition of the result set. The partition by category name clause divides the result set into partitions based on the category name column. And within each partition, rows are ordered by the distance column, which is the number calculated by the vector similarity search. The main query then selects all columns from ranked items where the row number, RN column, is less than or equal to 4. This means it keeps only the top 4 products for each category based on the vector distance. Finally, the result set is ordered by category name and then vector distance. Here are the products that we were able to retrieve using vector similarity searches and the relationships built into the database with the graph functionality. You can see all the products are for a mountain bike as requested from our simulated user prompt. And you can also see the results of the pivot query with the rankings. As a quick demo of this API in action, here's an application that uses Chainlit to create a chatbot-like experience. I use Data API Builder to wrap a stored procedure that contains the query we just built. The Chainlit app takes the user prompt, passes it back to the Azure SQL database, provides the results to an LLM, and creates an answer. As you can see, combining GraphRAG with Azure SQL's graph features offers numerous benefits. To start, enhance data insights. Gain deeper insights into data relationships, uncovering patterns and connections that traditional database might miss. Improve performance. Optimize graph queries, ensure faster data retrieval, even with complex relationships. Flexibility in modeling. Easily adapt to changing data structures without the rigidity of fixed table schemas and foreign keys. Existing knowledge. Leverage existing Azure SQL infrastructure and skills, reducing the learning curve and implementation time. And advanced AI integration. Enhance AI and machine learning models with rich relational data, leading to smarter and more grounded applications. Do you want to know more? Just go to aka.ms/SQLAI to see an entire page on building intelligent applications with guides, code repositories, and samples that you can use today. There is also a new learning path on developing data-driven applications. This learning path prepares you for the task of developing data-driven applications by using Microsoft Azure SQL Database. You'll learn how to create and configure an Azure SQL database, build and deploy database projects using GitHub Actions and Azure pipelines, and automate the publishing process. Additionally, you'll explore how to use Data API Builder with the Azure SQL database. Thank you for joining me today to explore the powerful synergy between Azure SQL and GraphRAG. By leveraging hierarchical data relationships, we can enhance similarity searches and unlock new potentials for our AI applications. To learn more, we have included links in the video description, and if you have any questions, please feel free to reach out.
Thank you, Brian. Thank you. There we go again. It's with a graph database showing what another mode or modality of SQL Server. SQL Server, a multimodal database, including a graph database. Why have a database that's dedicated to only graph when you can have a database that just simply includes graph and already is probably storing the data you have in your enterprise? Fantastic, Brian. Thank you. And thanks for walking us. Maybe I'm the only one, but when I heard you say, do you want to know more? I heard Starship Troopers. Maybe I'm the only one. Idris is next. Idris will be talking to us more about Fabric this time, and we'll be going through AI implementation with translytical apps. So translytical apps, he'll explain. That's a big fancy word that doesn't show up on every bingo card. All right, well, let's go ahead and get started. Idris can walk us through that. Once again, isn't it fantastic to hear it straight from the PM who loves the product, loves the feature, and gets to explain it to you. Go ahead, Idris, take it away.
Hey folks, I'm Idris, Principal Product Manager at the Microsoft's Azure SQL team. Join me in my session today to discover the future of data management and unlock new scenarios that drive your business forward. I'll showcase the first fully SaaS database experience in Microsoft Fabric. Let's get started. So what we're going to cover today is the SQL database in Fabric offering, how simple it is, how autonomous and secure, how optimized for AI. We'll have a bunch of demos and what's coming up next. So let's talk about SQL. You are here already familiar with different flavors of SQL. We have SQL, Azure SQL DB, we have SQL Managed Instance, we have SQL Server on-prem, we have new SQL Server 2025 we announced as private preview. And we have been hearing from our customers that creating an Azure SQL instance requires a lot of thought process and can be complex for some. So we wanted to democratize databases so that everyone can create some databases. And that's why we worked on simplifying the SQL database experience as a software as a service in Fabric Data and Analytics Platform that is AI and Copilot ready. So before we talk about why Fabric and why SQL in Fabric, there was research done which says that we work with the Forrester team, and in the next 5 years, there'll be around 1 billion AI apps which will be built, and 87% of the leaders believe AI will give their organization a competitive edge. So what is Microsoft Fabric? Microsoft Fabric is a unified data and analytics platform. It unifies all the required workloads for data science, data engineering kind of projects into one platform. You no longer have to stitch multiple services to build an end-to-end and a solution for your need. It provides under the hood something which is central to Fabric called OneLake to store your data, which is just like having your data in your OneDrive. All the workloads in Fabric provide Copilot experiences and purview for your governance and security for your data, which is located centrally. One most important thing to note about this platform is its billing model. You buy one capacity and you use any workload. So one of the things is we have now introduced, as you can see on the top, is databases, which is bringing in with starting off with SQL databases and Fabric. So let's drill a little bit more on that. So the newest workload, which is the Microsoft Fabric databases, streamlines AI application development with simple, autonomous databases that are natively available in Fabric and optimized for AI. So we are starting with SQL. These are the 3 key pillars that we have invested in. The next generation of AI applications require the entire data estate. The SQL databases in Microsoft Fabric is built upon the familiar SQL Server engine, which will enable customers to build insight-driven applications that unite both transactional and analytical data to build intelligent applications and experiences and smarter answers. And this has been optimized for auto optimizations, auto scaling. It can be provisioned in seconds and accelerate innovation with Visual Studio and GitHub integration, Copilot assistance, and CI/CD pipeline support. Data is also automatically replicated to OneLake with mirroring and making it instantly available to Fabric's analytical engines. So let's talk a little bit more about each of these pillars. A reason why we focused on was to, as we talked earlier, we heard feedback that the setting up of Azure SQL databases could be complex. So we wanted to provide a very simple and intuitive editor experience, make it easy to provision. A big part of what we do to focus on this product is to help you focus on building your apps. We know you're going to build a lot of apps, a lot of AI apps in the future. And we want you to do that by helping it as easy and efficient, but also performance and enterprise ready as we can. Now, what better way to do this than show you we are not going to beat around the bush and we'll go right into the Fabric website. So here I am going to show you how easy it is to get started. You can see I can go select a new item, and all we have to do is go down to the section and create a new database name. And once that's kicked off, give it a database name, and we'll take care of the provisioning and all the things underneath the hood, like auto scaling, getting you the connection string, setting up your authentication with Entra, and give you a database in seconds. And here we are. Once you're here, you can get started with the getting started data with options like importing sample data. Let's go click on it. Once the sample data is imported, you'll see a developer-friendly integrated type of experience where you can navigate things like the Object Explorer, see your different schemas. You can search in here, and you can also save your queries as well as take advantage of data previews, where you can preview the data without writing any query. Now, but hey, well, let's say you want to get right into a quick query using our query editor. It's so impressive that you just like you would do with any other SQL database. So one added thing which we have added here is the support for Copilot. And here I'm using comments to basically ask Copilot, what is it I want the SQL query code to be generated? And here it is. It generated the code for me. It can also do autocomplete too, and it'll make a guess at what I'm trying to do. So it's pretty impressive. Also, it can explain queries with AI and fix errors. So if you're running into errors with the queries, this feature would be super, super helpful. Now, let's just talk a little bit about, here I'm going to show you is, sorry, we already covered this, didn't we? All right. So here we have a sidecar Copilot, which you can also use. Which we already talked about. Here we're going to go to the settings for the databases. So you can see you can change the sensitivity labels. You can see if it's endorsed by your organization. Here's a connection string for your app developers right here. You can pick it up and you can put it into your application. These are the restore points for when it was earliest restored and where it was latest restored, and any kind of Copilot settings for completions as well. So one of the things is, we like to encourage you all to use the feedback button and provide us your feedback. We're always listening and learning from our users. Now, the other thing which we are seeing here is the integrations with like pipelines and templates, or opening your tool in your choice like Visual Studio Code or SSMS. You may want to create an API and as well, and there's also performance dashboards. We'll take a look at that. Let's go create an API that you want to interact with the data we just created. It's super simple with SQL database in Fabric. You give it a name and select the data which you want it to be exposed from that API and load it in. What you're going to see now is a GraphQL playground where you can write GraphQL queries and see how they work. You can also navigate your mutations if you like, and if you're lazy like me, I'm using Copilot again and generate queries. So I'm here asking for a GraphQL query, and when I'm happy with it, again, this is a multi-turn thing, so I can then bring it back to the editor and make sure I'm happy with the results. Here's the part I loved. You can pick your language of your choice. In this case, I'm picking Python, and able to. I'm going to go to VS Code, and you can now just run it. I have to just authenticate, so I'm going away from the screen, but it comes back, it just works. Now I have a code sample in Python where I'm connecting and running the queries that I've tested. I'm ready to use my application. So we also have this available for Node, and because we have REST API support, if you want to build PowerShell scripts or other scripts, you can go to manage a database using weak code, and you can do that as well. And since we are in VS Code, might as well show off some SQL Server extensions that we have built here, and the SQL database products. You can manage a database there as well. This is a glimpse at the VS Code and how, again, this where you would want to be as a developer. If this is where you live in, great, you have the database, and now you can get into developing the way you like it. One other thing that we were doing with Fabric all up is the kind of unification of all the data into one lake, where you'll have one copy of your source data that is being replicated in your real time. So replication to one lake was one of the key foundational things we built in as part of this capability. And this is where you get your transactional and analytical applications together, which we call the Translytical apps, which you can build it right from SQL databases in Fabric, which, by the way, SQL database in Fabric is actually a SQL database. You have your MDF, your LDF, and all the good stuff under the hood. But in addition, we also have mirroring or replication on by default to one lake, which means that near real time your data is landing in one lake, which helps you unify your operational analytics works in one data analytics platform. Now, what you'll see here is you'll see two things. One is a SQL analytics endpoint, which is generated for every lakehouse and exposes those delta tables from those lakehouse as SQL tables that can be queried using T-SQL language. And every delta table from a lakehouse is represented as one table in delta format. And You'll see this in the application. You'll be able to connect to both of these. And the semantic model is also created by default for you to create Power BI reports as well. Let's see this in action a little bit. So here I am, I'm created my database right here. I'm going to go to the replication tab and look at all the data which we have created as tables is already available. Now remember, this is the data which is all replicated into one lake. So I'm going to go into the editor on top and switch to the SQL Analytics endpoint. In this scenario, I'm looking at the read-only data which is replicated of your underlying SQL database, which is pretty cool. We can also bring in data from your lakehouse and your warehouse, and you can do some really cool stuff. Like you can now do cross-querying of your Contoso database in this scenario, your operation database, your warehouse data, which is read-only, your lakehouse, which could be coming in from various other streams, and you could do a joint query. Like in this case, we have a table called posts. The post types are a categorical table in data warehouse, and you have links related to that in lakehouse. You can all combine together, and you can do your analytical queries while you have your operational data at the same time. So this is pretty cool. Let's talk about the application life cycle management. So essentially, every database which you have available in SQLDB in Fabric is available in source control. The source control integration in Fabric, it's a web interface which has ability to integrate with GitHub and Azure DevOps. You can commit your database objects to Git repository, you can develop against a live database, track object changes. You can update database from code in Git repository. You can do database code editing in developer tooling. You can have SQL project support in VS Code and Visual Studio, as well as SQL projects validates object references, it catches any syntax specifically related to SQL databases in Fabric. Also, you have a SQL package command line tool, which provides the ability to database import and export with portable backpack format. You can do iterative deployments in your choice of your CI/CD environments as well. About SQL databases, the capacity model, the way it works, the Microsoft Fabric has unified your data, a product of all your different workloads into one. So you have your analytical workloads, you have your data workloads. That's why it's a data platform. And basically, there are the two variables which with how your bill is determined, or the amount of compute you provision on compute and the storage. And there's a shared pool of capacity that powers all the capabilities of compute. And the storage is a single place to store all the data. And the compute is based on purchase pay-as-you-go resource, and the storage is also the same as purchase as pay-you-go resource. And the different capacities and levels which you purchase in Fabric, and that's what determines your capabilities for how the capacity model is built. Let's talk a little bit about the third pillar, being autonomous and secure. Now, simplifying database administration with a very intuitive setup and autonomous management was something which we worked on, and the challenge was making the right choices, and managing databases is pretty complex. So we want folks to spend less time planning for spiky workloads with serverless, auto-scale, compute, and storage, and also have capabilities like auto-managing the high availability or disaster recovery for hands-free backups and high availability as well. Fabric supports zone redundant availability zone where available. With zone redundant availability, resources automatically replicate without the need for setup or configuration. So you can get fast and consistent app performance with resource optimization and intelligent auto indexing. So it really helps you bring SQL database and Fabric to get you the best security, availability, and performance configs. From a security perspective, as you all know, security has been Microsoft's top priority, and coming to Fabric, we wanted to make sure data and applications are secured by default. SQL Database in Fabric is offering a comprehensive portfolio of capabilities across every area of security. For example, we are enforcing Microsoft Entra authentication across the board to guarantee passwordless authentication and allow users to centrally manage their identities. Auditing will also be enabled by default to automatically collect critical security events like login attempts and security changes. Of course, it will also be customizable to help meet your exact financial requirements. Auditing is coming soon in the next 6 months. Finally, we are integrating with Microsoft Purview as well to deliver on a vision of central governance, similar to other Fabric items. Databases can be labeled also according to their sensitivity labels, while the service automatically applies centrally managed product protection services and policies. So with Autonomous, you can have auto HA with zone redundancy, auto scaling, compute and storage. All databases are automatically configured with HA and zone redundancy. You can leveraging our serverless and fleet manager technologies that can automatically scale compute and storage to respond to the incoming user workload and demands, providing elasticity without monitoring or user actions needed. Now, data is automatically replicated to one lake with the system fully managed mirroring. We saw that earlier as well. The database is also auto-optimized using the latest intelligent query processing enhancements like automatic plan correction that detects query plan regressions and automatically mitigates them by reverting to an earlier plan. Any missing indexes are also automatically detected and created to optimize your workloads. Backups are fully managed by the system, allowing you to restore the database at any point to recover for any system or user errors. Finally, you can be assured that your database is secured with the latest patches, as a service automatically applies them on time and without affecting the compatibility for your application. Since the database is now autonomous, we're also introducing a modern performance dashboard experience that allows you to go easily from insights to action. Let's see this in action. So let's go directly into the demo here. What you can see, let's take a look at this CPU consumption across my queries in the performance dashboard. I can see some red dots in the performance dashboards, right? Let's click in to see what's happening. The query on top is consuming the most CPU. Let's see what's behind that. And I can see the details in the page like execution history and compare performance, average and maximum durations, and the T-SQL on that as well. As you can see, we're showing only the CPU consumption today, but there are other cool stuff like you can see blocked queries. We can go back and see during the last 24 hours and see what's performing from a timeline perspective. But you can show things like user connections, requests per seconds, allocated size, and of course a list of automatic indexes that our system has created. You can use this dashboard with minimal knowledge of SQL. It'll help you quickly detect performance bottlenecks with your databases and solve them on your own. Now let's move on to something even more cooler. Optimize for AI. This is the third pillar of how we have focused on and provided the SQL database and Fabric capabilities in Fabric. So there are 4 areas here. We have built this for AI apps developers, vector and RAG support. RAG is essentially retrieval augment generation. Is a technique in AI that combines information retrieval with text generation. We retrieve the most semantically relevant data from a database and use it to ground LLMs for specific scenarios. We also use Azure OpenAI to generate embeddings that are stored as vectors. We store the vectors and the data together for consistency and search for the most relevant semantic data. Structured queries, it allows you to query your structured data as well as advantage of rich metadata and query optimization. And also it's integrated with popular frameworks like LangChain and Semantic Kernel. Now, SQL database and Fabric also works with data across Fabric experiences like notebooks, data pipelines, data flows, Power BI, and so on. Let's see this in action. So here I'm in Fabric. I can navigate to my lakehouse, and you can see there's a lot of product documentation with PDFs for hybrid and electric vehicles and their parts. These are pretty text-heavy PDFs with lots of written information. So let's see how we can bring this thing and chunk it and bring it into SQL DB and Fabric. So we're going to use an Azure OpenAI services and SQL database in Fabric to build a chat experience for asking questions on this data. First, we need to extract and chunk the data, and we can do that with Azure Document Intelligence. We can reference the PDFs in the lakehouse. Then we can use the function begin analyzed document, which we saw a little bit earlier. And then we extract the text from the PDF and break it into chunks. We clean it up and create a data frame or a table with columns like file name, chunk ID, and text, which you can see that in this query. Now you can see that the code has gone through all the PDF, extracted the text, and generated the chunks with unique IDs. So now next we're going to need to generate embeddings, which are numerical representation of text segments. We'll use OpenAI to help us do this. You can see for every file and chunk, we have a vector representation. And this is really, really important because now we can take this representation of vectors data and now move it into SQL databases and Fabric. So now that we have this, now that we have the embeddings, we can now use the native vector type support in Fabric, SQL database and Fabric to store the vectors directly in the database. Right. Here we have a simple program that will essentially generate the embeddings for a user search query. We can use the built-in vector index, vector distance functions to find the most similar chunks of text by comparing to the user query embedding. And here's an example where we can search for how to replace an oil filter. For example, hey, and in this, what it does, it finds the most similar segments which are returned based on all the chunkings and embeddings which we have done and stored in SQLDB in Fabric using the vector search SQL function. And we can further enhance this by leveraging LLMs to make it more conversational with completions. Let's look at how much code it takes to create a conversational experience. This is the API keys with OpenAI. We just given some functions you use. This is basically the code and your building blocks. So let's say here we have a user ask how to replace the oil filter on a CA hybrid utility truck, and they ask about the minimum tire load ratings and tire pressure for the CA3 model. The AI is able to segment out the request and gives two sections of results, one with details for oil filter replacement and one with load ratings and tire pressures based on the wheel diameters of the CA3. So as you can see now, it's bringing in all this data from all these different PDFs. It was chunked. It was using the vector capabilities, bringing in the value of the RAG patterns and bringing it all together. So you are able to quickly develop an AI app on SQL databases and Fabric as well. I know this is a lot of information, and it's a lot of demos and capabilities, but we also let us tell you what's coming next. We have in the next 6 months, we have a ton of capabilities coming up. We have shortcut support for SQL data, for SQLDB in Fabric, private links, support for business continuity, disaster recovery, auditing, customer managed keys, event stream, AI skills support, more capabilities for the support for AI app development, native notebook support, Terraform, and a ton more stuff. So we plugged in. It's super exciting. There's a lot of capabilities here. You're probably asking, how do I get all this information? And how can I get started? There are quite a lot of resources. There's documentation. Click on this capability where you can do a Fabric trial, and you can sign up for a Fabric trial for 60 days. We have a lot of Learn modules. We have episodes from our data exposed. Also, please, as I said earlier, provide us a feedback, and we are listening for your ideas and any product enhancements or capabilities you would like. We also have demand learning series, and please do join us at the FabCon Las Vegas in March 2025 and learn more about it. There are actually pre-con tutorials and a lot of exciting sessions. So thank you very much. I hope you enjoyed this session. Have a great day and a great evening. Bye.
All of you are listening to KSQL. That's Microsoft's data radio. Just kidding. You're actually at SQL Conference. It's SQL Conf 2025. It's a developer marathon of content, SQL-oriented content for developers and engineers just like you. We've got something special here. We've got a special guest. That's right. You stayed near the end, and now you get a special guest. That's going to be Davide, one of my colleagues here.
Yep.
Davide, thanks for joining in.
Yeah. So happy.
You know what's funny? We've already seen you. You were the very first session, and you've changed shirts.
That's right. Because I was waiting. I was stressed about delivering the session live. No, just kidding. Yeah. I saw some. I just took a sneak peek of some of the session. Great content, really.
Yeah, it really is. And we've been able to show all kinds of features inside SQL now that are geared specifically for developers, all the changes and updates and tooling to make it so that their experience is better. We showed the data API builder. We showed all of the pieces around the SQL projects and SQL package. Just the story just goes and goes and goes and then extends into Fabric as well. The developer story is a broad narrative that is honestly filled with love for the developer from our team, including you.
That's right. And I love how everything goes comes together with Aspire, because you have the projects and data API builder and SQL and kind of just magic. Fabric is also cool because it's all like SaaS, so very nice, polished, easy. So I think this year we have a great features for developers, so they can just have some fun.
That's how I feel too. It's a great time to be a developer interested in SQL. That's for sure.
Oh yeah.
And we've done the best that we can for sure. And I was just making the point earlier that all of these features that are inside Azure SQL Database are all up in the cloud waiting for you in Azure. But at the same time, we're bringing like the busload of all those features into SQL Server in 2025 as well.
That's
to
right.
make sure that if you're on-prem, you get the same sort of love and benefits.
Yeah, correct. And actually, I see people asking for code shared in GitHub. So my code is definitely in GitHub. I think also the video will be shared later, right?
That's right. Yeah, that's exactly right. All of this will be chopped up into individual episodes to make sure that each video gets its own place in a playlist that'll be around SQL Conf. So once all that's put together, we'll make sure that that's shared out on social media as well.
That's great. Yep. Yeah. And I see also a lot of interaction, so it's fantastic.
Wow. it's been a great day. We got 2 more sessions. In fact, we just finished with Idris. That's our second and last Microsoft Fabric session. The next one is James is going to talk about using PowerShell to interact with SQL. It's actually one of the most novel presentations we've ever had. And so that'll be a lot of fun. And then finally, we'll get down to static web apps and interacting with it to connect your application to the database. Spoiler alert, by using Data API Builder.
Yeah, love it.
Yeah, a lot of neat stuff. We were able to basically cover as much as we could, that there is a developer data-driven learning path and applied skill that developers can go and not just learn about the features of SQL, but also show their proficiency. You missed just before your session. It was Moasma here talking to me about the new free database that we have for Azure SQL Database. You can go in and have 10 of those databases, each one with all the capabilities. None of them are handicapped. Every subscription qualifies, and you get it for the lifetime of your subscription as well. So there's a lot of kind of beauty right there. Again and again, we try and show how Data API Builder is built for free, open source, not just inside Azure, but also on-prem for Microsoft SQL, but also Cosmos DB, Postgres, and MySQL. Another one of those pieces of really sweet candy we give to developers to make their lives a little bit easier. And of course, I know you have a special place in your heart for Data API Builder too, since you are the godfather of Data API Builder.
Yep. I'm also getting my hair white. So yes, I'm really the godfather.
Yeah, I'm waiting for that to happen to me. So
but you look cool.
Yeah, no doubt. All right. One other thing was we still have the SQL database projects, and that's 2 parts. Not only do we have Visual Studio and VS Code interaction, and we went through with Drew all the capabilities that are coming from that. Now that we're doing the migration basically from Azure Data Studio into VS Code, but we also have the CLI, and that includes SQL package so that we can do all kinds of deployments right inside your CI/CD pipeline. So here we are, ready to have James talk to us about PowerShell. But let me ask you a question, Davide. If you were able to speak to our developers directly and you say one thing, what's that one thing you would like to say?
That 2025 is going to be rich with features, release, new stuff that you have been asking for years, and we can finally have like a release that contains all this stuff. So make sure you keep your eyes on the news, on the social medias, because as soon as we can, we release stuff. And I definitely think this is going to be a great year for developer and SQL, because I guess everything that you always wanted, it's going to be there. So it's going to be big.
That's right. Yeah. This is the year that it's not like we just started caring about developers. It's that all the work that we've done for the past few years needs to be culminating right now. This is like the pivot point. It's really exciting.
Yeah, absolutely.
All right. Well, let's turn our attention here to James. James is going to be our next session. He'll be talking about developing. No. That's not what James is going to be talking about. Oh boy. Oh, James is like, wait a minute, that's not what I'm talking about at all. That was one of the smoothest transitions. That was going to be so perfect, and yet here we are.
Murphy's is low.
Yeah. All right. So let me back up and say this is SQL PowerShell for the win. It is actually James talking about it, but this is the correct title. Davide, thanks for popping in.
Thank you, man.
All right, we'll see you again.
I'm James, and today we're going to talk about SQL and PowerShell for the win. Let's get started. First, the obligatory who the heck am I? Well, I'm James Brundage. I'm ex-Microsoft full-time. I'm an ex-member of the PowerShell team. Currently at Microsoft MVP in PowerShell/Azure. I'm a maker of many tools and toys, a bit of a jack of all trades, and a master of PowerShell. And occasionally am brought in as a DBA/ETL wizard. So hopefully that qualifies me to talk here. All right, what are we going to talk about? Well, we're going to start off with some SQL 101. It might be a bit of a refresher, but never hurts. And we're going to talk about some PowerShell 101. Might be a bit new to everybody, maybe not. Then we're going to talk about combining them together, SQL and PowerShell 201. Then we're going to go do a bit of a demo time, and then we're going to do a bit of a story time, and then we're going to talk about how SQL and PowerShell together give you wins. Ready? Let's go. Let's start off with a bit of SQL 101. Might be a bit refresher. Sorry if it is. But, TLA is first. SQL is the structured query language. It is quite old at this point. There has been some form of SQL for about 50 years. It comes in many flavors, often called variants. It is great for working with tables of data. It is very much a query language, and not to throw any shade at SQL, but many people are very aware, sometimes very painfully, it is not technically a full programming language. It has its strengths, and it has its weaknesses. So let's talk about each of those. In the pros column, well, it's really quick to query. That's part of SQL's whole thing, query language. It's also very efficient in how it stores data. Because SQL has a limited number of data types, it is very good at storing them very compactly, basically regardless of what SQL variant you use. It's also implicitly stateful. In fact, you might be able to call a database a collection of states. And it is mostly server-side. While you have a few SQL variants that effectively work locally, the vast majority of SQL Server use you will have is against a server. Now, that's mostly good, but it does kind of bring up a few weaknesses as well. Because it has to be constrained, it has a finite list of types, and it has fairly limited validation. You don't want a validation to become too expensive if you're taxing the server. And it's not particularly easy to extend. It works with other languages, but it is not a very extensible syntax itself. It also has very limited string manipulation, and this can get painful in all sorts of ways. So let's talk a little bit about syntax. Again, sorry if this is review for everybody here at a SQL conference. SQL syntax is fairly simple. You've got a limited number of keywords and support for parameters. Keywords tend to be capitalized. Parameters have to start with an @ There are a few fundamental building blocks, plenty more keywords than this, but these are the ones that most people are going to run across. You've got create table, which creates tables, select selects rows, insert into inserts rows, update updates rows and table, delete deletes data, and execute run stored procedures, at least presuming your SQL variant supports stored procedures. Got this nice little handy dandy reference slide for some of the basics. Again, this should be a review if you are at all a SQL person, but if you are just learning the language, this is a good cheat sheet. So that's covering our SQL base. Now, let's start to talk about PowerShell. Okay, so PowerShell 101. PowerShell is a shell of a scripting language. It's a bit younger, a bit cooler, about 18 years old at this point. It's been built into the box in Windows since Windows 7. It comes in two flavors. You've got PowerShell Core, which is cross-platform, and Windows PowerShell, which again has been built into the box since Windows 7 timeframe. So you definitely have PowerShell installed on your system, at least unless you're still running Windows XP, God help you. But you might not be that experienced in it yet, so we're hopefully going to ramp you up a little bit today. PowerShell is really great for working with objects, and it is very much a fully fledged programming language. In my biased opinion, it is the best .NET scripting language, partially because it has so many fun bells and whistles. And it also has its share of strengths and weaknesses. Possibly a few more strengths, but it definitely has areas that it is weak. So let's cover the strengths and weaknesses. Strengths column. Well, you can automate anything with PowerShell. And I do really mean anything. PowerShell is all about building bricks that you can kind of easily interconnect with each other, building little blocks that you can reuse. And that makes the whole PowerShell ecosystem available to you once you're able to tap into it at all. It's also got very flexible validation. I can say that a parameter has to be a specific type. Any .NET type will do. I can say that it has to match a regular expression or be in a set of values or be within a range or match any arbitrary validation script. It's very easily extensible. I can basically create types as much as I like and extend them to do any additional functionality I might need. It supports any .NET type. If you can load the assembly in PowerShell, you can use it. It also has incredibly flexible string manipulation, and it is mostly client-side. While it is, possible to run PowerShell server-side, you are more likely to encounter it in the PowerShell terminal, in Windows Terminal, or in VS Code. It does have a couple of well-known weaknesses, though. One of them is that it is actually fairly slow to query. While you've got pretty much infinite flexibility for how you can query, the language itself is nowhere near as fast at querying as SQL. The other one is that it has some inefficient storage. While you can save any object in PowerShell, you're going to save that at generally a larger cost to disk and memory than you would if you were saving it to SQL. So hopefully you can already see how these two languages kind of complement each other a bit. Now let's talk syntax. This might be a little bit more complicated than SQL, but let's start. For one, there are thousands of commands. Usually they're in verb-noun format. They don't have to be, but that is the most common form of command you're going to run into in PowerShell. I'm going to actually teach you your 3 best commands in a second. The trinity of discoverability: get-command, get-help, get-member. Show me what I can run, help me understand how to use it, and show me what an object can do. These commands are often joined via the object pipeline. A good example of this might be something like get-command, pipe to get-random, pipe to get-help. Get all my commands, pick a random one, get help about it. There's also thousands of types. .NET Core and Windows PowerShell both have a considerable number of types built in, loaded whenever you're using the shell, and any assembly that you load in .NET can work in PowerShell just fine. It also has all the operators. It has them in a bit of a funky format, though. So you have them in -eq, -ne, -like, -match, in, as, etc. So it's just a little bit different in operator format than most languages, and that might take some getting used to. You can do very easy variable assignment. Just go ahead and set it to a value or to the output of a command, and you can very easily do string expansion, which is what we're doing here. We're expanding either a variable or a sub-expression. Variable can just be $variable name inside of double quotes, and the sub-expression can be $parentheses, whatever expression of code. Now, as with SQL, I'm going to go ahead and give you a little bit of a cheat sheet here, so we can go ahead and see that get command, pipe to get random, pipe to get help. We can show you how we reference a type, and we can go ahead and create an object with a static method, that's that : and new. We can go ahead and do simple comparisons. We can do match extraction. We can do string expansion. PowerShell is a very, very potent language. And again, a lot of its strengths complement a lot of SQL's weaknesses, and a lot of SQL's strengths complement a number of PowerShell weaknesses. So with that in mind, let's talk about using them together. Okay, So let's talk about SQL and PowerShell together. SQL has always supported .NET. It's supported for decades. Since .NET 1.0, most of the stuff that I'm going to show you has been part of the .NET framework. And PowerShell has also always supported SQL out of the box. PowerShell and SQL were launch partners way back in 2006 when PowerShell first came out. Loaded .NET types are all accessible with bracket type syntax. We can always omit the system namespace. So we can refer to something like a SQL connection with bracket data.SQL client.SQL connection. And you might also use a data adapter, that'd be bracket data.SQL client.SQL data adapter. Static methods are available with : all types will have a constructor, or most types will have a constructor. So you can do : new to see the constructors. And that makes SQL connections easy, and working with SQL very, very simple on PowerShell. So let's take a quick look at a one-slide version of how simple. The first statement up here is just creating the SQL connection. And that is, again, just getting our type, using the static constructor, passing connection string to it, and great, we've got a connection. This is creating a data adapter and filling a query. We're going to go ahead and create the adapter, select star from information schema tables. We're just going to go pull out data pool data, create a data set, fill the data set from the data adapter, and go output the first table. That's how easy it is to basically do raw SQL on PowerShell. It's very handy. Variables are also very easy and very flexible. So is discovering what a variable can do. We're going to come back to this again and again in the demo, but you just pipe it to get member. This will go ahead and get you back methods, properties, and events. And SQL connections have a number of useful methods that you might want to look at. My favorite, personally, is .getSchema, which will get available schemas. And you can also pass a schema name to it to get schema information. You can also call create command, which will create a SQL command. So to kind of recap for demo mode, PowerShell supports SQL out of the box, always has been. SQL client ships with PowerShell core. PowerShell extends SQL. Table columns are exposed as properties. Tables are automatically enumerated, and this will work with any variant of SQL. So if you have SQLite database, SQL Compact, MySQL, whatever, it'll work. Let's demo some of the ways that we can script a database. Ready? Let's go. Okay, let's do some demos. We're going to start off with the basics. Again, PowerShell supports SQL Server out of the box, always has, always will. Let's see how simple it is to work with those SQL objects in PowerShell. We're going to start off by creating a connection. My connection string is in the variable demo connection string. No, you cannot see it. That is the path towards getting hacked. Please don't leak your connection strings. Please be very careful with them and keep them safe. I can, however, look at the members of SQL connections safely. So I can do that live. And we're going to go ahead and take this live connection here and get member and see what it can do. We've got a few events up here. Then we've got all these various methods. Create command we're going to end up using a lot. Get schema is the one we're going to explore in a second. But all of these are quite potentially useful and interesting. We can also search in this list by one or more wildcards. For example, I just want to go ahead and get all the gets. And, I got get hash code, which comes with every object, and get lifetime service, which I don't have to really care about, and get type, which will just tell me a bit more of the SQL connection type here. But the ones that I'm interested in are get schema and its collection name overload. So let's go ahead and open our connection so we can get at our schemas. Cool. Now let's find out about our database. It's called get schema, and it'll return back, oh, hey, I've got these different types of collections you could go get more schema information about. For instance, procedures would have your stored procedures, tables will have tables, columns will have the columns. You get the point. Let's go ahead and ask for more information about schema by saying get schema tables. And I should get back a list of tables in this database. Now let's go ahead and create a command. And let's look at its members. Again, there's quite a few things that I can do here, but I don't have to care about all of it. In fact, I am primarily interested in the command text. And I want you to know about two parts of this here, the execute non-reader, which is basically fire and forget the query, and execute reader, which will give me back a reader to, read over the results. Speaking of which, let's go ahead and change that command by setting its command text property. This is the long way to go ask for a set of table schemas. Now we're going to go ahead and execute that query, which will return a reader. Now the reader is going to give us back stuff one row at a time. This is very handy. There is another way we can run things, which I'll show later, that allows you to fill a whole data set at a time, but going row by row can sometimes be a little bit quicker and a little bit less impactful on memory. We can also assign the results of the loop to a variable in PowerShell, so we can just kind of go over while there are new reader results, taking each particular result that we get, creating a dictionary here to, hold the result row, and then walking over each column and getting the name of the column and the value of the column and putting it into this dictionary, and then turning the dictionary into a PS custom object, which just turns it into a regular everyday PowerShell object. And looking at the results, there we are. We actually have basically the same object coming back. This is a good, quick way to be able to run a query. And, the SQL Reader approach is quite handy to know. It's also what you would need to do if you wanted to do a bulk copy of the tables. But we're going to go update our table in a second. For now, let's just go ahead and close the reader and stop this particular demo. All right, next demo. Let's go ahead and try to get a little creative. Specifically, let's create a table, insert some rows, and read them back. We're going to do a little bit of light metaprogramming here, and we're going to do some things that SQL couldn't on its own. But right now, let's just go ahead and create a command. Pure SQL does not allow us to parameterize the table name or columns during create, but PowerShell does. So we're going to do that real quick. Let's go ahead and pick a random table name. This is a sub expression that has test table, $parentheses means this sub expression here will run, and it'll run the command get random, which will just give us back a random number. So I've got a randomly named test table just like that. I want to go create a list of columns, and I can just create a list in PowerShell with the @ operator and include both of these items, basically just in direct SQL. And we can construct the SQL query to create the actual table. All we need to do with this is a little bit more string expansion here, and we create table, $table name, and then in parentheses, we create the columns, joining them by comma and a space. So that'll give me my create table command text, and we're going to go and run this. Congratulations, we got a table. Now let's insert a row or two. So create a new command for the insertion. We can reuse our table name and define a message parameter. We generally like to use SQL parameters if we can, because it reduces the likelihood of code injection attacks. So I'm going to say insert into table name, message, values, @message. And I'm going to add a parameter to that. Just, hello world. Cool. Insert the row. Great, it's in. Now we can rerun this with variation just by changing the parameters. So if I want to insert 9 more rows, then I'm just going to go ahead and I'll do it. Change the parameter for message value to one of these 3 random words and execute each non-query. Cool. Let's read our data back out a little bit differently. Remember, I said there was a little bit of an easier way to do this. So we're going to use a SQL data adapter to fill a data set. This is generally faster than a reader, at least for large tables, and less code. We can create our own SQL data adapter with a SQL command and a connection. So here I'm going to go select star from table name with our SQL connection we already have. And we're going to create a new data set to hold our results. And then we're going to fill the data set. And let's take a quick look at the data set. Now, by default, PowerShell will show you all the properties of an object that it does not have formatting for. This is handy, but most of the time when you're dealing with SQL, you're going to be getting one table back, and you can just go ahead and look at the first table in the data set. And there we are. So it appears to have a few too many rows. By the way, we can also save that data set to an XML. And last but not least, we can clean up after ourselves by dropping the table. Create a command, drop the table, set our command text, run it, and we're done. All cleaned up, all done with demos. Hope that was fun. Okay, now that we're done with demo mode, as promised, it's story time. Long ago, I helped a competitor to Zillow. They build realtor websites for all the major brands, and their ETL is a DBA's nightmare. They have over 700 different data sources, and none of them are directly supported by SQL. Their intake had been taking days, and I do mean days, 3 to 4 days to update new listings. And this annoyed their customers, obviously. If your realtor website is several days out of date and Zillow has a more recent copy, this is not good for your realty business. So, had to kind of make it a little bit better. They had been trying to do it all with SQL views. This, in my opinion, was a bit of a mistake. It resulted in many a SLAM server, and many SLAM servers made them buy more servers, or rather rent more servers in a data center that was costing them about $30,000 a month. So they needed to stop being built on sticks and glue. They needed to figure out how to run in parallel, efficiently aggregate information, take the load off of SQL servers. And this is where we get to SQL and PowerShell for the win. How to fix it? Well, we'd use PowerShell to do the heavy lifting of querying and standardizing the data from RETs, IDX, and RESTful sources. Then we let the shape of the object dictate the intake. So rather than trying to spec out 700 different tables, we would create tables that match the shape of our input. And then we would standardize the shared information. We'd say, all right, here are the 50 different fields that we have. Let's map them all to this common set that you need for each of the customer scenarios. And we'd shard the storage by region, rather than make one massive database or table to hold every listing, create lots of tables in each appropriate region to get all the listings. Then we figure out how to run in parallel. And that almost ends up being it. Just let the data describe itself, put it into SQL, give it a extracted form or transformed form of the view or data, and throw it into another table. Make sure you shard this table or this out into multiple tables and run it in parallel. How much better did this end up getting? Well, a purely SQL approach, again, was 3 to 4 days at 100% CPU in a $30,000 a month data center. SQL and PowerShell? Guess. I'll wait for a half second. Wouldn't be that much of the total runtime. You see, it was about 15 minutes at 10% CPU in 8 cloud workers with a total compute cost of less than $100 a month. I don't know about you, but I would call that a pretty big win. So, in my opinion, every DBA should learn PowerShell, and every PowerShell programmer should learn SQL. They complement each other very nicely. SQL can store and query much faster than PowerShell, and PowerShell is much more flexible than SQL. Using them together is the best of both worlds, and I hope this helps you understand that and see that. Thank you very much. Here's some doc links in case you needed it. You will keep coming back to that SQL connection, SQL data adapter class. I really could not get through any presentation about SQL and PowerShell without mentioning the wonderful DBA tools module, which you can find more information out of https dbatools.io. If you want to reach me on social media, I consider GitHub a bit of social media. You can get to github.com/startautomating. You can also reach me as Mr. PowerShell on Blue Sky. And don't forget to check out the new data-driven applications applied learning skill. Thank you very much. Have a wonderful day.
That is Data API Builder, but it will host it for you, hiding the container behind the scenes. Do you have as many knobs to configure it and control it? No, you do not. However, you also don't have any of the complexity around whether or not you want to use ACI or ACA or Kubernetes or whatever it is you're going to use to manage and host your container. So it's a great way to get a POC up by lunchtime and then wrap up your application by the end of the day. It is sort of insane how straightforward and easy everything actually is to do. Let's not wait any longer. We'll go ahead and have Dheeraj walk us through connecting your web app directly to a database. Go ahead and take it over, Dheeraj. Thank you.
Hey, y'all. My name is Dheeraj Bandaru, and today I want to talk to you about how you can connect your front end directly to an Azure SQL database without needing a backend. So quickly before we get started, I wanted to introduce myself. My name is Dheeraj Bandaru. I am currently a product manager for Azure Static Web Apps. I'm super excited to talk to y'all today about what Azure Static Web Apps is and what it does. Our feature database connections, which allows you to connect directly to a wide number of databases that are hosted in Azure. And then a quick demo of how it actually all looks in production. So to get started, Azure Static Web Apps is Azure's premier front-end hosting offering. We offer two plans right now. We offer the free plan, which is obviously free, and then a standard plan, which is $9 a month. The database connections feature that I am referring to is actually available on both of these plans. Some of the key features that make it so awesome to host front ends on Azure Static Web Apps include our managed CI/CD with GitHub Actions and Azure DevOps support. We also offer built-in authentication, and then we offer managed deployment of back-end serverless functions. Additionally, we offer these easy connections to databases and easy connections to other backends as well, not with managed deployment, but just linking them. We can link to Azure Container Apps, App Service, APIM, and other functions. So what is database connections? To put it simply, it's the simplest way in all of Azure to connect a database to your web app. How simple is it? This is code taken from the demo that I will show you in about a couple minutes here to list all of the entries in this particular table. It's 4 lines. All you have to do really is connect to this endpoint that we provide called data-API, and you can list out all the values in your Azure SQL database on your front end. It's really that simple. So database connections is a configuration-based setup. The database connection sets up a connection to your Azure database securely using Azure Security, and you're able to build something like what you see in the picture here with those 5 functionalities available to you and your front end. So let's go ahead and get into the demo. I have a very simple demo set up here today to go over what this all looks like. Let me bring the code over. So here we have some code for an app.js. So taking a look at what that front-end React code really looks like. We have the following content: static web apps database connections. We have our 5 functionalities all listed out here as buttons that users can click on in order to get that functionality. Below, I have those functions written out. So again, the first one we have is list. I have my endpoint as data-API, REST, and then I want my person table from this database that I've set up in the portal. I want to make sure that I get that data back as a JSON so that I can go ahead and list it, and I output this content to a console. But obviously, once you get back that content, you can list it wherever you want within your front end. Similarly, I have my get function here. I'm going to fetch using that endpoint and ID, and then I have that response returned to me as a JSON. The update functionality I have is a little bit hard-coded just for this demo. I'm specifically updating ID number 4 to say, have the name Molly instead of whatever the name originally was. And I have my endpoint again. Here I have a put method that sends a JSON with that data. And again, I'm outputting the result that this all worked in a table in my console. Last 2 here, we got create. It's another functionality that's available to you with database connections. That's a post method. You post that data up. Delete. That's a delete method. And you again can log all of that in your console. So the reason I'm starting with this is from a code standpoint, these are the changes you have to make to your front end code in order to accept the database connection. This is pretty much all the code you will need to write in order to connect to any database, as opposed to having to maintain your whole backend, maintain the security on that traffic, as well as a number of other considerations that you'd have to do generally. With database connections, this is all you got to do. And then to actually connect to your live database, we have this file right here called the database.config.json. One of the advantages for it being all configuration based is instead of having to worry about how I'm doing this securely, and if anything changes with my database, how do I update my code? It's all in one place here in my config file. So you can see here, the schema we're using is from Data API Builder. The database type set as MS SQL because today we're going over how to connect to an Azure SQL database. And then we have my connection string, which I have in my environment, REST, GraphQL endpoints. I'm allowing localhost 4280 because the SWA emulator, which I'll go over in a second, allows me to test all of this locally. And I think that's really huge because being able to test a connection to my live database without actually having to deploy saves me a lot of time, especially in this particular instance. And the SWA CLI really allows you to do that with database connections. provider, static web apps, entities. This is where you have to customize it to your particular table. I have my person table and I have permission set to anonymous. As I said earlier, Azure Static Web Apps offers a really neat feature that allows you to authenticate people built in to the platform itself. So for example here, if I had my role as authenticated instead of anonymous, only authenticated users would be able to access this particular entity and do these sort of operations, which is extremely useful because you don't want anyone touching your production database. How you set up that authentication is, again, it can be config based with a little bit of code. All of that information is on the Azure Static Web Apps documentation page. So if anyone's interested in finding out exactly how easy setting up built-in auth is for static web apps, you can go ahead and take a look there. But yeah, maybe some of you are wondering, how do I even get to this stage? How do I get this config file? And that's where Static Web Apps CLI really comes into play. So the Static Web App CLI I have here running in my terminal is used to set up local emulation. We have a couple key commands. SWA-db init is the one I kind of want to talk about, which I've already done, obviously, because it created this folder structure. But if I were to use SWA-db init now, what that would generate is it would generate this folder, SWA-db connections, and in it, this static web app database config.json file, which is used to actually connect to my live database. And it's just one command, generates the schema for me. I can go ahead and fill it out in whatever way I feel necessary. For example, I can put in my own entities. I can put in my own connection string. I can allow different things through my cores, etc. Once all of that is done, I can go ahead and test if this works or not before I even ever deploy to static web apps. Obviously, I would have had to have set up a Azure SQL instance in Azure already, but that's separate from this process. So with SWA start, data API location, SWA-db connections, I'm able to see this. Couple notes on this particular command. I will say SWA init needs to happen because you need to initialize your SWA. That creates this SWA CLI config JSON file, which is another file which just basically allows the emulator to understand how to actually run and build your app. After that, SWA build needs to be ran. And this will allow the emulator again to actually have the build artifacts. All of this we've summarized into one macro. If you just type in SWA, it will run all the commands necessary all the way up until deployment, and then it will give you a choice of whether you want to deploy or not deploy. In this particular case, I would say I don't want to deploy, then I would run SWA start with the data API location as SWA-db connections. So I already have this running just to save myself a little bit of time. Let's go ahead and see what that looks like. So first, I want to show you localhost 5000. This is the port on which the managed data API builder is currently running. You can see here, status healthy. We're using DAB OSS 1.319, and that all looks good. Next, let's go to 4280. This is where our entire app is currently running. If it'll load. But what this will essentially do is it'll pull up that app that was shown in the picture and we can run through it. Let's go ahead and click that. And there it is. So here, this is running locally on my machine. Let's go ahead and open up the console just to see what that looks like. So currently there's nothing in the console. Let's go ahead and click list. You can see here, this is everything we have in our database right now, that person table. I got 4 Pedros, all with different IDs. Just to check if that's actually what we have in the database, I'm going to go to my portal. I have my data set up here. Let's go ahead and go to the editor. I'm going to log in using my login and password. And I have my table here. I'm going to go ahead and select my top-down entries. I'm going to run this. And you can see here, in my live deployed Azure SQL database, I have these 4 entries. In my local testing, I have the same entries. Let's go ahead and get ID number 3. That's Pedro. That's correct. If you remember, the update function in this demo is hard-coded to change whichever instance is at 4 to Molly. So let's go ahead and do that. It responded with that. Let's go ahead and see the list. And you can see now ID number 4 is Molly. So this is how we're able to do this locally. And it just makes my inner loop development a lot better. A lot faster, because I don't have to deploy every single time I want to make an update to my front-end application. I can just check whether it's happening or not. Just to confirm that this actually changed the live server, we can go ahead, run this command again, and you can see here, Molly appears in number 4. And this is, again, my live database that I'm running from my local instance. So, now that we've tested that everything works as planned, we're going to go ahead and deploy this to Azure Static Web Apps and link it to our Azure SQL database in production. I'll go ahead and show y'all what that looks like. I already have it deployed here. Again, this was my URL to the Azure Static Web App. If I go to data-API, you can see that it's running, it's healthy, and this is what my React app looks like once deployed. We can go ahead and get that list here and see, boom, there we have it. We have all of the same instances, entries as we did in the local running version, and it all works just as expected. So how did I do this? When I was in my terminal, the command I would have ran after swa start was swa deploy. That would have taken me to that URL, the agreeable water URL. I can also go to the portal and check in my static web app resource. You can see I can find my URL here. One thing to note is with the database connection, in order to officially set up the production link, we also need to go to the portal, go down to the settings, database connections tab, and we need to take an action here. This does not automatically get linked. We need to go ahead and click Link Existing Database. I've already linked my database here, and that's why it already exists, but you can see below for my preview environment, it's asking me to link a database. Let's see if this loads. If not, let me go ahead and close that. Let me go ahead and click this so that I can run through some of those options. But yeah, generally on this side pop out, what we see are some options to select the databases that are available in your resource group or in your subscription. And then we're given a couple different authentication methods. This includes using Azure identities as well as a connection string. So it finally loaded here. Let's go ahead and click Azure SQL. resource group. I'm going to go to my resource group. I'm going to go to my name. This is my resource group. My sample database. And so yeah, here we have authentication type and we have a connection string. So you would just input your username and password and then you'd be connected. The other database types that are available with this particular feature include Postgres, MySQL, and Cosmos DB. Just to see what that looks like, once finalized, you can see here, once deployed, it does get access to that database.config.json file to make the rest of the setup a breeze. But this manual setup will be necessary every time you want to connect a static web app to a database once deployed. But yeah, that is Azure Static Web Apps and Azure SQL and how easy it is to make all of that happen. Let me go ahead and pull up my slides again here. So it really is that simple. That demo I just ran through is actually our quick start. And so if you wanted to go and use that yourself, you can go ahead and find it on learn.microsoft.com, Azure Static Web Apps. Look under the Database Connections tab, and then look under Tutorials, and you'll find all of our tutorials there. And yeah, it's just really easy to use and hopefully really powerful for a lot of devs moving forward. Other things, if you want to get a certification to develop data-driven applications using Microsoft Azure SQL databases, you can go ahead and find that at this aka.ms path. And yeah, I appreciate everyone for coming out, listening to my talk here today, and hope y'all have fun coding. Thank you.
And thank you, Dheeraj. All right, that's the implementation of static web apps. Adding a database connection that automatically deploys Data API Builder for you to give you REST and GraphQL endpoints directly into your database that you can access over HTTP and interact with it just as you do already with JSON. Nice and easy. Static Web Apps is an easy way to get started, and because there's a free tier, it's pretty exciting to think about coupling that with the free version of SQL. And so those two things together actually add a lot of power. All right, this is the end of SQL Conf. Thank you for staying as long as you have. We certainly appreciate you as the developer and engineer. We hope to do this again, but the idea of 2025 is just a magical and special year for us, to bringing so many capabilities and so much candy and so much happiness to developers. We have only honestly covered about half of what we wish we could have covered. And so we look forward to kind of circling back a little bit later in the season so that we can cover a little bit more indeed. So all of you developers out there, obviously, we want you to succeed. We want the things that you're doing and be part of. So when you're using the tooling that we're building, we want you to love it. When you're using the features that we're building, we want you to love it, and we want you to see the entire scope of the story, that everything that we're doing, from our documentation to the engines and tools and libraries that we're providing, all make it so interaction with SQL is better than ever before. And when you think about SQL as that multimodal database where you can put JSON documents and interact with them in a very high performant way, or you can just call out to REST endpoints from inside a T-SQL statement, interact natively into AI componentry, all of those things up in the cloud in Azure, but also on-prem when you're using SQL Server. So all of the capabilities are right here for you. Thanks again for being with us. We're going to take all of these, slice them up into individual videos and start sharing those out on social media. My name is Jerry Nixon. I'm at Jerry Nixon on Twitter. You're welcome to find me there. That's certainly one of the places we will be sending out all of this content. If you have any feedback directly to us, obviously you can go to our blog and interact with us there. You can go to social media and interact with us there as well. Whichever you decide, certainly we welcome it, because the feedback that you give us helps us to tailor and perfect the tooling that we give to you, but also to other engineers just like you who also like excellent tooling and excellent libraries. Okay, this is the end, and this is Wednesday. I hope you have a terrific Thursday, rest of the week, and a weekend after that. We'll see you again.